After the presenter is turned off, please take back the USB receiver to avoid losing it. After the presenter is turned off, please take back the USB receiver to avoid losing it.
Hello, 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 hello. It's so nice to see so many faces. Just so you know, we do actually have additional seating up around this amphitheater as well, if you guys are looking for a seat. But I still see some seats intermingled. But hello, welcome to the 4th edition of DeSci Berlin. I'm Ella. I will be your MC for the day, guiding you through, pushing everyone around, instructing everyone. So yeah. I will walk you through all the rules of the venue and everything a little bit later, but we're actually just going to get straight into it. Our first speaker is someone who needs little introduction and is one of the faces of DeSci. It is Paul Kohlhaas, who's the founder of both Molecule and Bioprotocol. Paul started out really as sort of an early member of what was to become a DAO, which was a biohacker community in Reddit, at a very young age, and started just sort of hacking himself and got really into sort of exploring health and connecting with communities. He then moved on and studied economics at the University of St. Gallen, founded his own company, exited, and started Molecule. And here we are, I think 7 years later? 6 years later, yeah. So welcome. 2018, yeah, so wait, quick maths, that's 7 years. Thank you, everyone. But yes, welcome to the stage, Paul.
Cool, good morning, everyone. First of all, a massive thank you for coming to the 4th edition of DeSci Berlin. I want to start out by saying a massive thank you actually to the organizing team, to Julia, who did such a fantastic job, Ella and everyone else. Fun fact, Ella is actually from South Africa, where Molecule first began. So kind of to make a full round trip. It's never easy opening this conference because there's so much kind of expectation that rides with it, especially as an entrepreneur. And so I always like looking back at how much we've achieved, and where we need to go. DeSci Berlin has really had the honor to become like a founding ground for so many of the organizations that operate in the DeSci space today, and has had the pleasure to kind of lay parts of its culture. Fun fact: who's in this building for the first time? Oh wow! Okay, almost everyone. Okay, fantastic. We had the pleasure to get into the touch with the current kind of owner of the building. And so, fun fact, if any of you don't know, it is a former brutalist church that was built in the, I think in the 50s. It's also an art gallery. And so we got in touch with the owner because he was exhibiting an art piece, a very famous NFT called Machine Hallucinations, which was one of the first seminal pieces in kind of AI-enabled art as NFTs, and he auctioned it, so we got in touch with him, and this room just happened to be available, and we found it very befitting that a former church could also be the home for the future of decentralized science, especially given kind of the relationship of the church and science throughout history. So this used to be the former community prayer room, or the community sermon room. Cool. Ella already introduced me, so I'm not going to do that. First, to start off with, why are we here? And many of us might be also investing into crypto or have found a belief in systems like Bitcoin over time. And maybe to preface, some of you may have heard this talk previously. There are elements that kind of I repeat as I go through different talks. But it seems like many of you are also entirely new, which always makes this really, really exciting. And so people invest into crypto often because we believe in kind of sovereignty, in liberty, in open source access, and in freedom of speech. And people have begun to really believe in those things because something has been taken away from many of us, kind of slowly and silently, over the last couple of decades, or over the last decade. So Bitcoin really famously started out after the great financial crisis. And after the great financial crisis, a large amount of money printing began to kind of support the system as we have it. And that led to an enormous amount of inflation. So you think about it, only since 2020, inflation is mostly almost 40, 50%. across most Western economies. And there's very little that people can do about it, other than, for instance, decide to purchase Bitcoin, which is fundamentally based on a very different system. And so it provides an exit mechanism from a current system that people chose not to believe in anymore. And science and medicine, in my opinion, are trapped in a very similar kind of power structure that we deem too big to fail. So to take the analysis again with Bitcoin and the central bank, it was really kind of the banking industry that forced the Federal Reserve to kind of go on this permanent spree of quantitative easing. Yet with the pharma industry, for instance, and the way that the FDA functions, or the way that the patent office functions as kind of a safeguard for innovation, we're really trapped in a similar kind of power structure. Science is obviously much bigger than medicine, but here I'm just going to use the example of biopharma. Many of the organizations that we help work with are tangential to the biotech or the pharma industry. And so to take a US-centric view, biopharma, for instance, in the United States consumes about 18.5% of the US GDP, and about 9% of that is used on spending of drugs and pharmaceuticals. And it's really all entrenched by 19th century era patent system. And so these are all things like power structures that we accept. There's a very famous quote from Balaji, former CTO of Coinbase. We're also very lucky to have him as kind of an investor and supporter in many of the ecosystems that we help generate. Some of you might know him from his network state work. But so Balaji says, in order to begin, like someone had to invent Bitcoin to change any part of what the Federal Reserve was doing. I think we should take a similar approach. Someone had to invent or like think through all of the structures that are being developed in DeSci in order to actually begin changing these kind of the inherent power structures that we have today. And that's really the potential to kind of invent something entirely new. And you're gonna hear from many incredible teams that will kind of walk you through what they're inventing or some of the frameworks that they're using. What defines the current system? So in today's world, treatments and kind of recurring revenue dominate the healthcare system today. The system that we've created needs lifelong customers, and fundamentally, for instance, it disincentivizes cures. So there's a really famous article from Goldman Sachs, it was published in 2018, and the article caused such headlines because it basically asked, is curing patients a sustainable business model? And the answer of the article is obviously, it's not. The Goldman Sachs report resulted in the downgrade of a company, and I think several executives were fired at the time because a very famous pharma company had invented a cure for hepatitis C. This pharma company previously had multiple treatments on the market. Other companies also had treatments on the market. These treatments were lifelong treatments. Hepatitis C at this point was like a very damning diagnosis. You would have it all of your life and very hard to treat, massively decreases the kind of quality of life. But it would have been much more profitable for these companies to just keep selling treatments rather than developing a cure. And so as a company in today's ecosystem, you're punished essentially for really fundamentally solving a need. And this is something that I think massively needs to change, because otherwise there's so much inefficiency. Like imagine this number, this 18.5%, it's much lower in other countries. In some countries, drug spending is like 0.5%. You can spend all of that on infrastructure, education, you can do all these amazing things. And so this fundamentally holds societies back. There's a very interesting game theoretic principle called a Schelling point. In fact, the inventor of bonding curves, some of you may have heard about systems like Pump Fun or other kind of launchpad systems. They all utilize a function called a bonding curve. And so the inventor of bonding curves, his name is Simon de la Rouvière, he defined it as a Schelling point where attention naturally accrues. So a Schelling point in game theory is a point where kind of devoid of all other options, like participants in the game go towards that option. And cures are not Schelling points in today's kind of economy. It's also why, for instance, the pharma industry is fundamentally not so interested in longevity, right? And it's been a really big debate of the longevity industry over time. Why wouldn't the FDA actually make aging, like mark aging as a disease? We could run clinical trials in a very different way. It's because it's not a Schelling point in today's economy, because you don't actually want to keep people healthy. right? Because then it's very hard to sell treatments. Let's look at the other side of the equation, right? On the one side of the equation, we have patients or the beneficiaries of science. On the other side, we have scientists. And so this is a really famous quote. We actually got from the first scientist we ever worked with. And then we confirmed it over and over time. So scientists today spend 80% of their time applying for funding, 20% doing the science. Imagine if this applied in software development, right? Imagine if software developers had to spend 80% of their time like trying to get money, even just to write a piece of code. So there's an enormous amount of inefficiency, again, that is wasted by essentially resource allocation problems. And it leads me personally to believe that most of the world's potential scientific talent today actually remains untapped. Like funding is really concentrated at a bunch of the major universities around the globe, around the major biotech ecosystems. If you're operating outside of that, and maybe many of you may have experienced that in your lifetime, it's extremely hard to get funding for your ideas. Like it can take up to 1 or 2 years to even hear back on a grant application, let alone try to raise biotech VC funding or any other forms of kind of commercial funding for your endeavors. In summary, unfortunately, we live in a time of science friction and not of science fiction. Like, as much as we hear about science fiction and all the cool things happening, we still live in a time of science fiction. And maybe some of you are familiar with this meme. It's a meme I personally really like. It's like, essentially, you can say, if only we did X, Y, and Z, here's what society would look like. The top is just a graph. It's a slightly outdated graph, but just about a massive decline in venture capital investments into science-based industries. That actually holds true today. Biotech, I think, is seeing one of its lowest investment records, like lowest investment periods on record in biotech. And so fundamentally, if we want the kind of the picture below, then we need to invest into science. Like it's very, very clear. But how should we invest into science? So this is from a Nature piece. I think it was late last year. So a scientist treated her own breast cancer with viruses she grew in the lab. This was published in Vaccines in August. It outlines how a scientist called Halsey self-administered a treatment called oncolytic virotherapy to help treat her own stage 3 breast cancer. And she's been cancer-free now for 4 years. And it took one really brave publisher to even publish this study at all, because no one else wanted anything to do with it, even though she had all the data, because it's a very ethically flawed practice. And so even scientists who are massively pushing the envelope will kind of get buried in the current kind of establishment and in the way that science has been done to date. And give this guy a follow. He posts really good analysis. So scientist does science, she cures cancer. The science establishment, no, you can't do that. And then we wonder why scientists are fleeing academia, right? Because it's actually very hard to innovate, do new things, and be brave. Like that's not rewarded. So in summary, what we really need is permissionless science. What do I mean with permissionless science? I think especially as we go into like an age of knowledge acceleration, we need to create a system where science itself and the ownership around science can become self-sovereign, right? I've always personally really loved this idea. Imagine an idea could own itself and incentivize its own kind of, its own bringing into life. And that's often actually how tokens have worked, or tokenized ecosystems. We often ask ourselves, right, like, take a community like Dogecoin. How has Dogecoin survived over time? It's still at this point, I'm not familiar with the current valuation, but I think it's in the tens of billions. And people found it silly over time, but for some reason, this community incentivized itself into existence. And nobody owns it, just like Bitcoin. So I think applying this idea to science and essentially having scientific ideas as selling points for humanity is something really interesting to work towards. So what is DeSci? For anyone that's completely new, decentralized science is a public movement that aims to build public infrastructure for funding, creating, reviewing, crediting, storing, and disseminating scientific knowledge fairly and equitably using Web3 technology. This is a definition from 2021. I don't think it's changed much, and I actually think it's really good if definitions that are created over time actually hold true. So, also DeSci really operates as a collaborative ecosystem. So many other organizations that are here might be working with each other. And I thought it was really interesting today to look back a little bit. In the beginning, when DeSci came about, lots of people used to do these like industry ecosystem overviews. And so I took one from 2022. This is from 2022. It was published by Ultra Rare Bio at the time, Jocelyn Pearl. Big shout out to her. The interesting thing is, so this is from 2022. There was like a really big expansion of kind of the ecosystem at the time. And then I tried to look for very current ecosystem overviews. And the difficult thing over time is like, it's actually expanded a lot, but then also it's shrunk again significantly. So unfortunately, many of the organizations that are named here or that are on here do not exist anymore. And so it's actually interesting to see over time and to look at data what makes certain things work and what doesn't work. I'm really excited to say that any organization that we worked with at the time is still around. And also a massive shout out to all of the entrepreneurs who like tried to do and achieve really, really difficult things. Some of them have evolved and have actually like gone fully Web3. Per Laura, for instance, big shout out to Ethan Perlstein, was one organization, if you've ever, in the rare disease space, that was really pushing the envelope already in 2018, 2019. And actually, we have had the pleasure to launch a DAO with Ethan just this year, and he'll share more about that soon. This is an ecosystem overview from 2025. It's the most recent one that I found. If anyone has a better one or a more up-to-date one, it's very much been reduced. It was published by Binance, and so Binance typically also looks at ecosystems that have an underlying token, or that might have an underlying token. Again, this is a very, very reductionist review. But it was difficult to find a very up-to-date one, and they've actually become more reductionist again over time. There was also a very large expansion of coins that we saw at the end of 2024, like a ton of meme coins. I think it's a bad overview. It's missing Wellshare. It definitely needs Wellshare. Yeah, if anyone has a better up-to-date one, it's interesting. So it's interesting even over time if you look at a 2024 one, and this is like being a scientist, right? You want to look at your own ecosystem, you want to see what expands and how it shrinks. So what really makes things work over time? So in order to expand sustainably, and I have 2 more points on this, in order to expand sustainably, DeSci or organizations in DeSci or even scientists really need to work together. Like working together as an industry is so important to avoid replication. What you saw, for instance, in this part, there was a lot of replication in this. In this, there's a lot more kind of focused individual work by all of the individual players that are contributing to its success. And then with work together, there's something that I also noticed over time. It's with something that is very difficult in DeSci. It's very hard to do science. Like most scientists will probably agree, doing good science is really hard. Validating novel hypotheses, and then taking science to market is even harder. Simultaneously, working in Web3 is also really, really hard. And it's actually, and many participants would agree with this, it's gotten even harder over time. So working together is like one of the most important things that we can really do, and validating each other's frameworks. And that's not something that is so common in academia often. So something that we found over time is that many scientists or scientific founders in DeSci shy away from collaborating together and massively criticize each other constantly. Because again, like criticizing or critically analyzing is something that is very, very natural to scientific work. The second, and what I think is one of the most important pieces, is to build, scale, and refine primitives. And so primitives are kind of the cornerstone of technology, of open source, for instance, but also of crypto. Primitives are the cornerstones of that. And so there's 2 core primitives that we really helped shape at Bio and Molecule. And our teams later today are going to talk much more deeply about them. So one of them is tokenized IP and data. The other one are tokenized communities. Very quick recap about both of the organizations that I found and represent. Molecule is a protocol for on-chain scientific IP and data. So we turn siloed research into liquid markets powered by open data. The other side is Bio, which is a curation and liquidity launchpad for scientific communities. We bridge DeFi and DeSci and help scientists, patients, and investors collaborate to launch real-world IP portfolios and fund them. I'll give a quick anatomy of how an IP NFT works. And the interesting thing about primitives, this is a design from 2022. And yet it's outlasted, it's been used over and over again. However, we've discovered over time that it also has a lot of flaws that we're really actively refining. Kevin today is going to talk about how molecules like fundamentally reshaping that primitive. But at the very basis, an IP NFT is a legal contract that is attached to a smart contract. The smart contract allows you to kind of exchange the IP on chain, move it around. The legal contract essentially specifies I am a university and I am out-licensing this piece of research in exchange for X amount of funding to a contracting party. These are very normal legal contracts. Over time, we've worked with some of the best kind of law firms in the US and in Europe to essentially attach these IP rights. And then finally, you have kind of the encrypted IP and data storage part. You can kind of imagine this like a decentralized Google Drive or a data pipeline where any updates about the IP are continuously coming in. This design and this framework has also been criticized a lot over time. And so we've taken in all of that criticism and we try to really actively evolve that. The second kind of big primitive that has been developed, and again, there are many primitives. These are just the ones that we know well, and the ones that we're really trying to actively work on and refine. The second one is a BioDAO. So a BioDAO is a patient community or a scientific community. It can issue a native governance token, and it can then use that governance token through input from the community to direct funding into all sorts of scientific causes. Yeah, pretty much. And what does it then do? Those scientific causes, those scientific ideas are then ledgered on chain, and what is done with that IP portfolio is now decided by that community. So the IP can be out-licensed, it can be commercialized, or it can be sold directly to consumers. So we already have multiple BioDAOs today that have discovered something and have then commercialized it and are now selling it on their own kind of websites to consumers. This only works this only works, of course, if you're not working in something that is highly FDA regulated. What has this resulted in? So VitaDAO, really one of the most, kind of the first really DeSci organization, I think it helped massively coin the term, has funded a lot of IP NFTs already. And some of the IP NFTs have turned into IPTs. So an IP NFT is really a one-of-one representation of IP. It's like an on-chain patent, right? And an IPT is now almost a sub-DAO or a mini community around this research project driving it forward. This has actually worked quite successfully. So both the researchers at those universities received funding, science was done. I think VitaDAO itself is working on to publish multiple papers on some of the work that has been funded. Vice versa, the IPTs, I sat in a meeting about 4 weeks ago with a major government regulator and their kind of their equivalent of the FDA to get approvals for clinical trials for not one but two of these lead compounds. And so we took something from a university, it got funded for roughly $500,000 each, and if we can progress it now to do a clinical trial, that would be massive. So despite some of these frameworks having their flaws, a lot has been accomplished over time. So let's take a big step back and look at kind of the bioprotocol ecosystem. Like, how does the demand side see this? So this is kind of taking what is being approached from a science perspective. Here we're starting to look at what is actually happening on a numbers perspective. So one of the best metrics that we found over time was really to look at the tokenized IP value in the ecosystem over time, which currently, this is a snapshot, currently sits at about 14 million. Last year, there was kind of a big excitement and kind of hype that actually brought it up to, I think, 50 million, just in the tokenized IP value. Tokenized IP for us would only be the two top things, and then we would account for anything that has been funded at cost. We have about 160,000 members in the different BioDAOs that we're counting now, the ones that we can see. Then ecosystem token holders is sitting at about 28,000. Yeah. This is a dashboard of all of the DAOs now that currently exist in the ecosystem. And this is so exciting to me because it's constantly more being added. And so this is now, like, if we actually take a step back in history, this is, where do we have BioDAOs? This is DAOs. And so these are the ones now that are continuously launching through our system. But in order for them really to scale much more, we need to fix the primitives. We need to continuously build on the primitives. So also anything that you find needs to be wrong, we really want to actively improve. And so the thing with primitives is, once built, they can be infinitely used freely and openly, but they have to be refined as shortcomings are discovered. This is so important with primitives. The second big thing, in order for DeSci to really succeed, DeSci needs to become data-driven. It's why I actually just went and tried to show a bunch of data. So we need to be much more data-driven. And then the third thing is we need to be demand-side oriented. Often, a lot of DeSci over time has tried to orientate themselves purely by like the needs of the scientists, not so much by the need of the demand side. And the demand side is two things. You need someone who benefits from the science. This can be a patient, but it can also be someone else. Right? It could be someone who benefits from a new material, or so many things, or just benefits even from like an entertainment value. I think a lot of science can be done if we focused on the entertainment value of science. Elon often says this, the funniest outcome is the most likely, and I actually think in a fully open world, the funniest science is the most likely to get funded. But so demand side orientation is incredibly important, the payer, right? In crypto, this is actually the person who puts in the money into these tokens, right? Like catering to that person is incredibly important. If we don't cater to them, we shouldn't be surprised that it's difficult to get funding. And so I ran through this. I know I'm running a little bit late. For anyone that is new to this still, actually, IPTs are kind of the last demand side primitive here. They can be exchanged for work, funding, or contributions from the demand side. I think we get a detailed case study about Vita RNA later. Kevin, you're going to give that? Awesome, cool. So I can skip through this. I just want to highlight that actually there are really, really amazing success cases being pioneered by some of the DAOs that we have to like massively enable. Kevin's also going to present this later today. This is something that we're unveiling, which is basically, this is, for instance, now purely built for the demand side, where this is kind of the new DeSci screener discovery page, where now anyone interested in all of the individual subtokens and research projects can look at the financial data, can look at how these markets are growing, but can also look deeply at the scientific data. So in the future, in the system that we're building, being a token holder in this should enable you to progressively, through access control rights, see all of the underlying scientific data. These are some of the exciting upcoming launches. We have several of our BioDAO founders also presenting and showcasing these different DAOs to you today and tomorrow. There's also an immense amount of progress coming out of the lab. And so really, really proud of one of our founders. His name is Rohan Dixon. He's building a DAO dedicated to long COVID research. So just over 2 months ago, the first patient in their inpatient study got pre-treatment blood work done. And then I think about a week later, they began treating him with a first cocktail of drugs dedicated to long COVID, dedicated to curing long COVID. It's really exciting to see these DAOs very quickly going out, doing inpatient trials, for instance, and for the first time ever, gathering data about something that kind of affects hundreds of millions. So in 2025, really as an organization, but also I think as an ecosystem, the biggest focus should be on scaling primitives. Not just our primitives, and kind of any primitives that you think are really important to build in this ecosystem. That's how we get scale. And yeah, want to really invite anyone to help. How can DeSci, like last point, we're hearing so much about AI and AI acceleration and the role of AI in science. And so scientific agents, especially like have become a really great new tool and framework for scientists. And we believe that it's probably one of the largest accelerators for how scientific ideas and novel hypotheses can actually be natively born in DeSci. And can very quickly accelerate. So we also have a presentation from our team around bioagents that will automate core research functionalities for a lot of these scientific communities. Big shout out to Future House. If any of you have come across Future House, they've developed an amazing agentic science framework. And so about a week ago, one of their AI scientists with a lab in the loop discovered a promising new treatment for dry AMD, which is a major cause of blindness. And their agents natively discovered the hypotheses, designed experiments, analyzed data, iterated, and essentially created a whole output for this. So we want to see a future where agents can generate thousands of hypotheses, other agents rank these hypotheses, evaluate them, design experimental plans, and prioritize them. Humans can then interact with these ideas and provide key feedbacks for rewards. So I think in a future of scientific agents, having crypto-native incentives and tokenomics is actually what will massively unlock this. So, in summary, we're building towards a world where scientists can spend 80% doing the science and just 20% applying for funding, and where anyone can fund and participate in science independent of institution and geography. Thank you so much.
Cool. Thank you so much, Paul, for laying the groundwork. I think that was super comprehensive and a great introduction to our fourth version of DeSci Berlin. So the way we were kind of thinking about our morning and how we were setting up the program was, I think, a lot of the sort of basis of DeSci is that, you know, the traditional systems are broken. But I think to really understand that point, you actually have to discuss, well, what's broken and what's slowing us down. So this morning's program is really about addressing the problems in traditional science. And for that, our next talk is a fireside chat between Logan and Michael Hart. So Logan is Molecule's Biotech Operations Manager. She has lab experience, she has operational experience, she's a general sort of Swiss Army knife of tricks. And then Michael Hart is a VC who got in pretty early with Beaker DAO, one of the investments DAOs in DeSci, and is now looking to start his own T1 DAO, type 1 diabetes DAO. So welcome to the stage, Michael and Logan.
Come, Michael. Come. Which side's your good side?
Here we go.
Thanks so much, Ella, for the nice, warm welcome. This is my second DeSci Berlin. I'm very happy to be back. And today I'm joined by the lovely Michael Hart. And I know the topic of our panel, Fireside Chat today, is kind of, you know, what DeSci can learn from TradFi. So I'm going to spend the next 15 minutes picking his brain, getting as many insights as possible. So yeah, of course, welcome, Michael.
Yeah,
and I would love to learn a little bit more about you because you have a very interesting background. You worked for many years at a hedge fund. So I think a lot of us are used to hearing the term, you know, venture capital here, but maybe we haven't met so many hedge fund managers here. So would love to hear how you got into, you know, kind of like the world of finance and how you stumbled across DeSci and how you ended up on this lovely couch here today.
Yeah, cool. Thanks for the intro. Good to see a lot of familiar faces here. Yeah, I guess my finance career goes back about 20-some years. My first job out of uni, I was at a corporate finance role in Tallinn, Estonia, actually at a boutique investment bank. Then went back to the States for grad school, and during that period, I met Peter Thiel, and you know, he had sold PayPal recently, and had started a hedge fund actually. And you know, for those who aren't familiar, a hedge fund is, you know, they're a private pool of capital, limited to the number of investors, and they can go short and long, and they tend to deal in liquid instruments, unlike, you know, venture capital, which is long time horizons and deeply illiquid. So I ended up working for Peter for about half a decade at Clarium Capital. And yeah, it was a pretty formative experience. It was when a lot of, you know, things that have become well-known now were taking off. I guess a lot of it, you know, we didn't know at the time, but a lot of it's become, oh yeah, sorry. A lot of it's become pretty well-known at this point. And then of course, he's probably more famous for the Dava hedge fund. It was a global macro hedge fund. And I traded currencies and commodities, a lot of oil trading, and So that was my formative experience, and then eventually got away from the sort of hedge fund game and went into more to venture capital. And my original intro was through the longevity community, which I'd been involved with for a while. And it's been a frustrating place to invest in. Nothing's quite worked in the longevity space. Hopefully, VitaDAO changes that. But and then got into public biotech investing, which has been in a brutal bear market since 2021. And I think it's an interesting thing to consider, because when we're looking at a lot of the BioDAOs and things coming out of DeSci, there's a lot of competition right now from the public biotech space because valuations are incredibly cheap. So I think it's always worth asking in the DeSci context what's going to drive the marginal dollar to some of the tokens and investments that we're discussing here in the next 2 days. And it's definitely an experiment worth running, but I think everyone needs to think about the value proposition pretty carefully. So that's a little bit about my background. We can get into... sorry.
I like fluid.
Really close. Okay. And I guess my DeSci journey began about 2 years ago at Zuzalu, in Montenegro, with Vitalik Buterin. Those who aren't familiar, organized a 2-month pop-up city, if you want to call it that. And I met Paul there, and James Brody, who runs BeakerDAO, and a crypto hedge fund, ID Theory, and is just a wonderful human being, and sort of pushed me in the DeSci direction, which is a bit of a departure for someone who's been around in the investment landscape for a while. But, again, I think it's an experiment worth running. There's still a lot about the model that needs to be proven, but, I think everyone's doing good work here, and if it's going to work, we're going to figure it out here.
Absolutely. I feel like everybody, you kind of mentioned this is an experiment, worth running. I really love the energy and kind of the attitude so far of the people in the ecosystem kind of having that mentality as well, that they're willing to just try something, iterate, learn from experience, start your version 2 and pick up where you left off. And you mentioned also, so you had experience working at a hedge fund, also at a VC, public biotech markets, and you mentioned, thinking about things from the demand side, which also ties into some of the things that Paul mentioned in his opening talk, right? Like the marginal dollar. If I have $1, where am I going to put it? What is the most compelling use case and story for this? So yeah, curious kind of from your experience in hedge funds, VC, and public biotech markets, if you have that $1, what are some of the maybe compelling narratives in DeSci, like taking these perspectives into account, and where is there room for improvement when you're looking at it through your traditional investor lens, that you're like, these are the types of things I would normally look at, and these are, this information is missing for me in DeSci to be willing to put in that dollar?
Yeah, that's an interesting question. Again, like I said earlier, there's a lot of competition right now from the public biotech. I know Paul, where's Paul? He would disagree with me on this. He thinks the public biotech game is over, which it could be, but the capital raising demands are just enormous when you're doing anything in sort of traditional biotech, where you have to get through all the trials and all the compliance, and hopefully DeSci is a way to circumvent that. So I think there's a lot that could be done on sort of the cost structure and overhead that would make DeSci a compelling investment, removing just a lot of unnecessary expense. And I think there's always this problem in public biotech as well with principal agents. A lot of trials are going nowhere in a lot of public biotech companies, but they have enormous cash raised in better times, and they're not particularly interested in shutting down because a lot of the people involved are, making very decent salaries, and their interest is to keep using investor cash. And I think DeSci might be able to sort of circumvent some of that problem and fail faster. and not have these, principal agent problems to the same degree they exist in public biotech. So that would be a case for why structurally DeSci might make sense. And then just the enthusiasm and the global community. I think that's still something that needs to be proven out, like the community aspect. If you think about the compelling narratives in the DeSci ecosystem, I think it's the capital raising value proposition is pretty significant, and I think they've been pretty decent. Not huge amounts of capital today, but pretty decent at raising and deploying capital. So I think the funding mechanism is reasonably well established. I think the community mechanism and the sort of citizen scientist and having a global community that can contribute to this stuff, I think that's still something that needs to be proven out. That would be very valuable to the thesis if it is proven out. But again, experiment worth running. But I think that's still something that's in the works.
Yeah, and you mentioned the kind of principal agent problem that we see in kind of traditional biotech companies. So just like on paper, looking at some of the math of these things, right? Like most early stage research is going to fail. And the problem actually arises when something that should fail is not allowed to fail. So you can imagine, you find an interesting result in the lab, you spin out a company based on this result, you hire your team, your CEO, your CSO, your operating team. You get maybe like 1 to 2 years of runway to run your experiments to decide whether or not you want to continue. You reach the end of those 2 years, you don't necessarily have data that supports continuing the project, but how motivated is the team actually to close the company and kind of hang up their hats and say, yeah, we took this as far as we could, but this is not a viable hypothesis anymore. This is not going to work. Nobody's going to just willingly give up their job and say, no, please, like fire me, kill my only project that I'm working on.
Maybe you.
Sometimes you
knowledge shared past position. I think you were willing to do that, but it's a very rare thing for people to sort of voluntarily want to shut down their own job and return cash to investors or what have you.
Yeah, exactly. Yeah, I had one experience that Michael knows in a former company. We didn't necessarily have data that supported continuing, and the team and I were actually quite proactive in giving this position to our investors and saying, like, look, if we're not going to find another way around it, then it's not worth pursuing. And it may be kind of like a rare outcome, but it was more out of like frustration of wasted resources that I would much rather figure out another way forward than continuing to kind of bang your head with the same problem over time. And what's interesting about, DeSci, if we think about the incentive structure, like we love a Charlie Munger quote over here, right? Show me the incentives and I'll show you the outcome. So we talk a lot about incentives in DeSci and kind of using tokens as a tool for incentives, but sometimes I find that the conversation around this like ends at the conversation around tokens, right? It's like, oh, we're just going to have tokens and we'll just give them to people as incentives, right? But if we think about this mechanism, right? Like how can you incentivize people to only progress the things that need progressing and to be willing actually to speak up about the things that should not progress so that you can save your resources and allocate them better in the future? That for me is super interesting to try to figure out. And I think a lot of the DAOs, have the tools and capabilities to design in this space around it and try as much as possible to be even more capital and resource efficient. And I kind of want to shift gears a little bit in terms of addressing some of your community comments as well about the people in the DAOs. Here at Molecule this past year, we ran an inaugural course, so we called it DeSci EDU. We have a few participants here today, which is of course very nice, because we were noticing that, there's so many different topics overlapping here. I'm sitting here talking to somebody with like hedge fund manager experience. I have a scientific background. You have people from marketing, design, Web3. There's so many different intersections of kind of skill sets here that it's hard as one person to figure out how you fit into the grand scheme of things and like what's really the big problem and how do we tackle it in an interdisciplinary way. So We put together an 8-week course and had students from all different backgrounds learning about what it takes to bring DeSci to life. And there are a few other initiatives as well. So Barrett and Aaron from Muse Matrix also ran a fellowship program this year. So I think everybody's kind of figuring out that there's a little bit of a gap maybe in skills and education for people in the space. So curious, to hear your thoughts, given that you're starting a new DAO together with one of our DeSci EDU students here. How are you also thinking about talent development in the space, and how can we maybe improve upon this?
Yeah, I think there are a couple issues there. One is the Web3 knowledge, right? And the other is just the sort of general biotech knowledge. And you need both to really be functioning well here. And I think when you look at the model of the DAOs, there's an interesting paradox between like centralization versus decentralization, right? I mean, decentralization is of course all the vogue in this community, but I don't think these things work unless there's a strong core team really driving and managing and executing really well. And there are certain functions that just can't be decentralized. And there's this notion that everything will sort of bubble up from the bottom via the incentive structure, but I'm not sure that actually works, right? In the startup context, having a strong founder with like ego involved is usually a sign of future success. I think there's probably something like that will work in the BioDAO context as well. But I think Barrett and Aaron's initiative and DeSci EDU has been very valuable on the Web3 side, trying to get people more literate in what everyone is doing here and building. Then there's a background question of just like, how do you get very talented scientists involved? Because that's going to be what really makes or breaks a lot of this. And I think it's an open question what sort of is going to incentivize a lot of top people to do it. I'm very encouraged. We have Ed Boyden on later, someone I've met with before, a very talented individual. Incredible that he's taking an interest, obviously. Bob Langer, also at MIT. Getting people involved like that would really increase the credibility. But behind that, you're going to need a lot more education and literacy on the Web3 side. And I really appreciate the work that you've done. And Ella, or shout out Ella, and I don't know if Barrett and Aaron are here, but they've done an incredible job. And I think we've also thought about doing something like a DeSci-focused pop-up for a few weeks. Barrett and Aaron already did one in Castalia in Mexico City, but something along those lines could be compelling going forward. The network state idea is something I've also been fairly involved with in the past couple of years. And I think that idea has legs, and that could be useful in the context of educating people on DeSci.
Awesome. Thank you so much, Michael. I think our time is up, so I'm going to wrap it up here. But if any people here today have any questions, comments, want to come chat to either Michael or I about, education in DeSci or incentives or, any of the topics here today, then you know where to find us. But thank you so much for joining me here, Michael.
Cool. Sorry. Excuse me, guys. Thank you so much, Logan and Michael. Is this on? Yes, it is. So great to hear from both of you and to get sort of the TLDR on what DeSci can learn from TradSci. Up next, we've got another sort of scientific panel, really digging into the issues in traditional science. It'll be led by Shreya. Shreya actually has started a BioAC podcast. BioAC means bioacceleration. It's one of the sort of key catchphrases you'll see around in DeSci, and is currently studying molecular biology at Harvard. She'll be joined by Kai. Kai is sort of an expert in the biotech space in Germany, and has worked in drug discovery, marketing, and international business relations. And then he'll be joined by Chris. Chris has spanned the clinic, industry, and academia and has developed patented technology. So it's really sort of gone from that earliest stage to getting something patented. And then lastly, we have Hannah. Hannah, who I actually met for the first time at last year's DeSci Berlin, but is one of the co-leads of Nucleate Berlin, and also is a biologist turned VC. So I'm super excited to hear from them. Welcome to the stage.
All right. Welcome, everyone. Thank you so much for joining. I just want to start this panel off by, asking why you got into your respective roles and work and what you love about it.
Okay, we'll start from the middle then. So I'm Hannah. My background is in biology and neuroscience research. Originally kind of started off in academia as a very typical scientific background. I'm actually originally from Boston, grew up there and studied outside of Boston. I was in research for a few years, and then I was kind of interested in the idea of startups in the scientific area, but I didn't really know where to get started, which I think is a very typical experience for scientists. I wish I'd had Nucleate around when I was kind of in my research phase, but ended up finding my way into VC kind of through a chance meeting with someone, and ended up finding that it really fit with what I was interested in. So, getting to work with a lot of scientists who are working on really cutting edge research and thinking about how to actually apply their research and spin it out. And I also got, around 2 years ago, in contact with people from Nucleate as it was beginning in Germany. And Nucleate is an international nonprofit that helps scientists spin out their research. So essentially trying to bridge this gap between academia and the startup world and encourage more science to be built into companies. And so that's been a really amazing community to be a part of, and a really good chance to kind of use that framework to try to build up the life sciences ecosystem here in Berlin. So I've also been active the past 2 years with Nucleate, and as I mentioned, investing in early stage scientific startups with Apollo Health Ventures.
I can go next. My name is Chris. I'm a neuroscientist. I actually have the opposite path. So I started in industry. I have a background in engineering, working in robotics, but was interested in learning and tried to go into the lab. So the past part of my career has really been in the lab, working with human patients, also non-patient humans, trying to understand visual processing and visual learning. And then realized kind of that we had a bottleneck in terms of the information you could get in neuroscience. We were really kind of tool constrained. So started developing also tools to understand more about the brain, and so now try to integrate electrical and optical methods to record from the intact brain in animal models. And some of this research has resulted in patents, so we are developing technology for reading and writing from the brain, and so I have colleagues as well who are interested in commercializing or creating products around some of these things, so we start to look at ways of funding this, either going the traditional route through VC, but I've also been following the blockchain space for quite a while, and am interested in the possibility of also funding things in this DeSci way, and so it's great to be here.
Thank you. So I'm Kai, I'm a chemist by training. Started a classical pharma career in Bale, Switzerland, then came to the biotech industry here in Berlin, failed in 2000, so the company went in insolvency. We started a new company, got into a trade sale, and then later I was becoming active in ecosystem building. First was in a small organization called Biotop, Berlin-Brandenburg, just focusing on biotechnology. Later, Health Capital, which is the entire health and life science area. And I have a contract with Berlin Partner, which is the economic development company in Berlin that attracts new companies, that supports startups and existing companies, builds ecosystem, and does all the marketing for the state of Berlin, except of tourism marketing.
All right, thanks everyone. So I wanted to start this off by talking about the different financing models in traditional biotech. And so obviously, bringing anything to market in biotech is an extremely capital-intensive journey. And I think in the past 5 years, we've seen a lot of different sources. I mean, academic grants, strategic partnerships, venture capital, public funding. And so I wanted to get your thoughts generally about these different sources, maybe some of the benefits and challenges for them. And Hannah, since you specifically work in venture capital and also you do run equity-free programs through Nuclea, I'm curious about your opinions on, giving up equity very, very early on in this very capital-intensive process, and how you maybe guide founders into thinking about when is the right time to go to VC.
Yeah, I mean, I think public funding that is in place for academic research and VC funding, of course, they're very different models and they should be applied in very different situations. So, and they also need each other. I mean, I think, venture capital funding is a very high risk, potentially high reward. It needs a company with potential for huge growth. And it's necessary in order to get research to a place where it is a potential VC model. You need to have that non-dilutive public funding for basic research that you don't know is going to turn out anything economically beneficial, but you need to have the freedom to be a little bit detached from the sort of typical capital incentives that you get in a VC model, of course. I think there are also challenges, of course, with the VC model. I mean, there can be great research, great science, great medical applications that are not necessarily VC cases. So this is actually a frustration that I have sometimes in my work, where I can see, meet a scientist, talk to a scientist about the research that is really promising, but it just doesn't have a big enough market to make sense for a VC to invest in it, because VCs need to have the potential to see that 10x, 100x growth. And so I would give an example of cell and gene therapy, for example, as a new, really exciting area of medical research that has a lot of potential to help patients. I think everyone would agree, about the curative potential of this, but the business model is not fully figured out yet. And that's why you see companies who have very successful science still failing, because they just can't make the economics make sense. And so, as a VC, it's frustrating because I come from a science background, not a finance background. And so I'm driven by the science and the tech and, what interesting research I see. And it's frustrating to not be able to invest and help fund projects that I think are great scientifically. So I would love to see other alternatives, to come in and be able to fill that gap potentially without the constraints of this very specific VC model.
Yeah, I don't know that I have a ton of insight into this. I think I'm more exploring. I think that, the amount of money, especially if you want to go into something that is FDA regulated and in human trials that is necessary for these, is quite large. And so, and then there's a huge spectrum of science as well, where I think I'm kind of on the border between commercialization of scientific results and then really basic science. And one question I have in the DeSci space, I think in general, is how to fund things across that spectrum. So not just things that will have a product in the next 18 months or 2 to 3 years, but also like long-term, really understanding fundamental principles. And as everyone knows, I think the funding mechanisms for science, pure science, are shaky as well. And a lot of our time is committed as scientists to trying to raise more funding to continue. And if you look at the amount of funding, it's really peanuts compared to, like, for example, the capitalization of a small startup. And so I'm more kind of here as I think observing the possibilities in that space and trying to find long-term funding for basic science with maybe some future commercial possibilities, but yeah, longer term.
Wow, that's a big question, a big field you are opening, actually. So if you are looking in the early phases in Germany, and looking especially here on the German situation, it is not difficult to get state funding. Yeah? So you will get state funding. However, there might be difficulties for the researcher at the university to get some 100,000 validation money. Yeah, one aspect where DeSci could come into a place, actually. So it's really difficult to get money for research towards product development and not to an academic paper or so. This is one problem. Then in Germany, it's not too difficult to get some early stage venture, but already at the next round, where you need some couple of millions on the table, it becomes difficult. You need international money, and things then become very, very difficult. And even the international ones, especially the US ones, are very careful right now. So we already learned about the situation since the last two or 3 years. So actually, one of the problems, I think, is, and this might be a problem that is addressed here in this room, this group. So how do we get the money of more people of really into the game, to get early funding and to get this money really to getting very fast to a decision whether it might be good to spend more money or to disrupt a project. So there we definitely all have to learn. And I must say to this community, outside in the traditional finance communities and the traditional science community, there's not much people knowing what is going on.
Yeah, actually, I wanted to follow up on that. So I'm from Boston, so I'm very familiar with the biotech ecosystem over there, and you know, it's like relatively okay. It's accessible to raise rounds there and multi-million-dollar rounds.
Even these days?
Okay, fair. But even with sort of the reduction in VC money for biotech year after year, I still see people doing it. It's not, you know, it's doable. But in Germany, I've been hearing some sort of reports that there's a robust academic innovation. There's robust innovation at that very early level, but there's sort of a loss when you go and in that translational aspect of actually spinning out companies. And so Kai, this question's maybe most applicable for you. But what do you think is sort of the main bottleneck there? Is it like GMP infrastructure? Is it like a financing thing, or you know, tech transfer? I've heard is like relatively fragmented in Germany. Correct me if I'm wrong, but would love to hear your thoughts.
It is definitely not GMP infrastructure. So GMP infrastructure is needed, but I think this is not the bottleneck actually. So it starts actually with the transfer and intellectual property. In Germany, some of you might have heard of German bureaucracy. Things take a little time, and too much time. So especially if you're funding a company, it takes too much time. And then, of course, each university, each Max Planck Institute, not each Max Planck Institute, but all the organizations, Helmholtz, Max Planck, Leibniz, they have their own organizations. And sometimes it's extremely difficult to just negotiate a simple contract. The problem people have seen, there is a problem, they are working on this problem. And I hope that they come to a solution where it's quite easy that the money, the person that gives the money really fast can come to a contract. This is one of the problems, actually. The second aspect is really German safety. So even a lot of young German scientists would not like to end up in a startup that has financing only for half a year or 2 years. So there's a lot of reasons to stay in the system, to go to pharmaceutical companies and things like that, to have a safety. Whether this safety is really true, I don't know. Sometimes it's not. So actually, it's a question of education to show the chances, to show the positive results. There's a lot of things you could improve.
Yeah, so I have a lot of ideas about this topic via my work with Nucleate and also coming from Boston and kind of seeing both sides of how things work. So I think there are a few things. One is tech transfer, of course. That's a big one. I think it's really, there are very different experiences between different universities. It's a younger ecosystem here, so a lot of universities just don't have as much experience as they do in Boston, for example. And so certain places it goes really smoothly, other universities it can be a slog. So it varies a lot. Another topic I would say is, of course, kind of the culture of innovation, but I would say this is also partly has to do with it being a younger ecosystem. So, you know, in Boston, you have the sort of culture of academic research more closely tied to the culture of startups and entrepreneurship, and also just because of geographic, it's very close together, all of it in Boston. And because it's a more developed ecosystem, you have more scientists who know people who have gone and spun out companies, and you know people who have kind of role models in that space. And here, you're starting to get that more, but you have fewer examples that young scientists can look to of people who have actually gone that path. But this is something that is changing. This is something we're trying to work on with Nucleate as well, by bringing together people who are in research to show them examples of what it can look like to spin out your research, to build companies, and sort of close that gap between the entrepreneurial side and the academic side. Another challenge that I see is bureaucracy, not just in tech transfer, but in kind of founding companies, and just setting up a company in Germany can be quite paperwork intensive. But this is another thing that there's really good progress on. So for example, maybe some of you have heard of EU Inc., the European-wide company structure that's been proposed and pushed by a Berliner, actually, Andreas Klinger, who started a petition that kind of got a lot of traction and has now been taken up by the European Union, and they're planning to set up a digital-first, European-wide, startup-friendly company structure that should streamline a lot of this paperwork. So really positive movement in a lot of these directions. Funding is, of course, another challenge. Yeah, as you also mentioned, I would say there's a lot of good early-stage funding in Germany, but there are a few gaps that need to be filled, and kind of later-stage funding can be a challenge and is still something that needs to be done globally a lot of times.
Yeah, I think you guys covered most of the big points. I would say, just to underline, I think culture is a big aspect, and the unwillingness maybe to make this risk, to this jump from academia into a startup with a much more uncertain future. But that the community also, I think, especially building this community so that seems like less of a risk because you know more people who have done it, you have more support structure, you see a path. Whereas if you're really in, I think, the academic structure, it can be hard to necessarily see this bridge if you're coming from a Max Planck Society, for example. Or so even though they have a good innovation office and I think a well-developed, a kind of patent structure there, I think building the community is huge, and maybe DeSci can also really play a role in that.
Yeah, absolutely. I know we've been talking a lot about, the biotech landscape, concentrated more in the US, how, capital markets have kind of dried up over there. I mean, we're seeing a decline of IPOs every year. We're seeing fewer overall M&A deals, which usually goes up, I believe, when capital markets tighten, but we're seeing that go down as well, maybe an FTC thing, I don't know. But, there's a reason this panel is called Bottlenecks in Biotechnology Innovation, because there are definitely many. And so we talked about Germany a little bit. I want to expand out maybe to US and global markets, what you think the main bottleneck is. From what I see, it primarily seems like a financing problem. I was reading the stat somewhere that like 90% or something of biotech startups fail because of funding. We're seeing VC rounds go down year after year. So these trends, for me, it seems like that's primarily the problem. But I know in the US there's lots of other problems. Regulatory is getting a little more challenging. So curious just to hear your thoughts about some of those trends, and maybe how you would encourage young founders who want to build in biotech to navigate that, that climate right now. And I'll start with maybe Kai, if he wants to.
So life science, especially biotech, has been and probably will be for long, long years a very difficult market because it's a highly regulated market. So in contrast to many other industry, it takes a long, long time even to start a digital application. It's not just the pharmaceutical product that takes 10 years. So think of diagnostics, digital applications, whatsoever. So this is a big problem. You mentioned the aspect of regulation. There is little help available for those guys starting. And if you come, I should not talk about Berlin right now, but for the LAGESO or European institutions or even international institutions, this is a difficult thing really to have the right experiments, the right protocols on the way because you could commercialize the product. So it is not just the finance, and I will stop with this.
Yeah, I mean, I think globally, I would say one of the bigger challenges that I've seen in the past couple years with biotech, life science funding is funding at the later stages. So I think there starts to be a little bit of an imbalance between the amount of funding and therefore kind of the valuations that you can get at early stages versus more growth stage funding. And so there you have a lot of companies that do okay at the early stages and then run out of funding and can't scale. And so, and also this kind of goes along with the more limited exit pathways. So it's for a VC model, those are things that you need. You need to know if you're investing early stage that there will be growth stage funding, that the value of the company will continue to increase, and then there will be exit pathways. So this is a challenge along the whole pipeline. So, I mean, I guess I would advise anyone who's getting into life sciences, biotech, entrepreneurship that, I mean, it is a challenge. It's a super risky area to be in, but also in the world of startups, contrary to kind of the culture of academia, failure is normal. Like, it's also fine. If you work on something and it doesn't end up working out, you gain so much from that experience, you learn so much from that experience, and that's also kind of part of the process. So I would say, I mean, I still think it's worthwhile to try to bring this research to patients and to really take what's in academia and make it applicable. That to me is something that's really worthwhile to do. I don't have the solution for the funding issues. I do think that, you know, there are a lot of opportunities, for example, for VCs who want to look in Europe to find lots of talent, which, you know, it's less expensive to build companies here. There are certain ecosystems like Boston that are great, but are also really oversaturated, and it's very expensive to build companies there. So maybe we see a little bit of a decentralization of the sort of innovation hubs. But I don't know, I don't have the answers. I see a lot of the problems, but I would say it's worth going for it anyway, because I think biotech is only going to continue to be a more important field.
Yeah, I think I would highlight two other things in the culture of academia maybe. I totally agree. I think in Europe in general, there's great innovation, great academic innovation. But one thing has to do with the way research is done in academia. It's really more of a proof of principle. And so people focus a lot of effort and work into getting something to work. They show that it works, and then they move to the next thing, the next stage that they want to show, rather than trying to solidify around, you know, for example, reproducibility or getting it to work in someone else's hands, trying to make a commercial product, which is a huge jump. I mean, you don't just go from like a lab result where you can get it to work in this lab, in this conditions, to something that you can put in a box and ship, you know, across the world and have it work then there. I think about this specifically in my case of trying to get brain implants. You can get it to work in some hands. You know, there's a lot of kind of knowledge that can't just be maybe easily encapsulated in terms of how you do the surgical procedure, for example, and have that reproducible. And so there's awfully not the effort put into this in terms of maybe making video guides or having some sort of, you know, kind of documentation around getting this reproducible, because there aren't incentives in academia for this necessarily. I think it's changing a little bit, but that's one. The other thing I think has to do a little bit with the conservatism of science in general, where it is a very skeptical enterprise. You want to doubt a lot what you see, and so that also means you don't necessarily see what you're producing as the best thing and the solution to some problems, but you see all the faults with it and the reasons that it shouldn't work for this thing and that, which is really ingrained, I think, in the training for science. And so it makes people a little nervous to then really kind of overpromise something and say, oh, this is going to change the world, and so on and so forth. So I think those are two big issues that I see that are more on the academic side.
One idea. So there's, of course, one big game changer, and this is AI. Use certain development costs. So allowing communities that are not so old and experienced and so rich, like Boston, to play an important game. It brings, of course, other competition in the game, which is definitely China. So China, for lots and lots of years, everybody was thinking, okay, they are quite good, but they are not advanced enough. Now they are advanced enough. So there's a lot of competition coming from China.
Yeah, definitely agree with AI reducing development costs. And Hannah, you bring up an interesting point in that, later stage financing is probably the trickiest thing. And I'm not sure if that's because there's just less money, or maybe, these companies are not great with like capital allocation at that stage, or maybe the technologies themselves are more expensive. Like you mentioned, cell and gene therapies, like scaling those can be quite capital intensive. So yeah, I definitely agree with that. It looks like we don't have too much time, so I want to end this on an optimistic note. We've been talking a lot about what are the failures in biotech, and I wanted to ask you what trends, maybe technologies, applications of tech, are you excited about in your field?
Okay, I'll start. I mean, one thing that I mentioned as a challenge, cell and gene therapy, is a challenge for business model reasons, but it's also something that I think will be figured out, and I think scientifically is really exciting. And I think there's in general, a movement of biology from more of a science to more of an engineering discipline. So we have the ability and the understanding to be able to do things like cure diseases that was just not possible before. So I think that's really exciting. Neurotech is another field that I find super interesting, just kind of increasing advances in neuroscience, in electronics, and in AI combine to make neurotech a really interesting field at the moment. I just got back from a conference in Canada of the BCI Society, which was really interesting, just seeing all of these researchers and companies that are working on those topics. And I would say a move towards more preventative medicine and longevity topics, which can be quite a mixed bag scientifically, but I think is really interesting to see a lot of scientists tackling diseases at the earlier stages and looking more towards prevention than just reacting when diseases are already more advanced.
So the long-term trend for biotech and life science is intact and is great. So whenever a company failed, and I've seen a lot of companies failing, all the people working there went to a new company and the number totally is growing. And now we are really in the situation on this general intact trend. We are changing from illness to health. So this is longevity, and there's a lot of black magic and stupid things within longevity, but the awareness that we not only would not like to be ill, but we would like to stay healthy and feel good, I think this will bring enormous amount of ideas and power and money into the system, so I'm very optimistic for the future.
Yeah, I would also just say I think there's never been a better time to do basic science or translational science. I think the technological developments, especially in the biomedicine field, have been astounding in the past decades. And yeah. Also, I think there's more money. Even if maybe it shrinks in some terms, I think there's plenty around. So yeah, I think it's a great time.
Great. The tech bio revolution is here. Thank you guys so much.
We have to leave, huh?
Amazing, thank you so much. Yeah, there was something that Chris said there that was sort of asking scientists to also be a little bit more not so fixed on everything that's wrong, but all the things that they're doing right, which I loved because so my background is biochemistry, And I now work in scientific communication. And I think so many researchers also don't know how to explain what they're doing, pitch what they're doing, sell what they're doing. And I think this is also a huge gap that is people, researchers tend to think very about the immediate thing at hand. And one of the nice things I see in DeSci is that you get people who are a little bit more like entrepreneurial or creative, and they start really pitching this long sell and this idea of where something could grow. And I think that's quite great. But anyway, I've got a little bit of time now. I'm going to run you through all the details, the house rules, that sort of thing, before we go into our first break. So yeah, as I mentioned, I'm Ella. I work with Molecule. This is my third DeSci Berlin, 4 DeSci Berlins in total, and this is my second time being the MC. So a bit of an expert, I'll say. But it's really nice to have you all here. DeSci Berlin started out as a conference, really as a function of getting people together in one space. I think decentralized communities are amazing in the sense that you can connect with people all over the world and there's so much accessibility. But we've always seen that sort of once you get everyone in a room and you get them to meet and connect, so many projects start, so many new things blossom. And so I always find DeSci Berlin a really exciting time because it's kind of starts, it's like sowing fertile ground. And then over the next couple of months, you see lots of things pop up, which is great. But yeah, this is our 4th one. It's our 2nd one in our lovely Molecule office that Paul told you about. We have 2 days of conferences. We've got 4 different themes. So as I mentioned, our first track was TradSci bottlenecks. In the afternoon, we'll have DeSci use cases. So you'll be meeting a lot of the new DAOs, hearing from Kevin and a bunch of different DeSci projects. Tomorrow morning, we have a very interesting track, as I think everyone can see. AI is one of our emerging trends. Bio has also been running an AI agent hackathon, building AI agents for science. So Wednesday morning, that will be. And then Wednesday afternoon, we delve into cross-chain science and citizen science. So looking at really sort of community-based projects, and also discussing the long-standing Ethereum-Solana debate of where to build. We also have a workshop room. So this is our main stage. Obviously, we got you guys in here. We've got a little co-working area up here. So you can come up, there are plugs, you can work silently. Just remember that it is obviously part of the space and we are very echoey here. And then we have the cafe where you guys all arrived. This is your communal hub, chat, network, vibe, have fun there. And then upstairs, we have the workshop room. Workshops will kick off, I think, in about half an hour as the break ends. 2 days, packed, we're busy. What else? Thank you very much to our organizing team, our streaming company, all of those involved. It's been a massive effort. Every year it is, and every year it gets better. We are streaming the whole thing live, so hi everyone who is watching. There are streaming links. Share it with your friend. If you can't come tomorrow, watch it, all of those things. This evening, we will be having a side-hour event in this office. So if you want to stay later for the event, that'll be happening right after the conference ends. Our schedule is printed on QR codes. It's also on the website. It's also printed out in various areas. So if you want to know what's happening, just check out that. Tomorrow evening, we have the hotly anticipated bio rave. We will be sharing details about that, and you guys can sign up on the Luma. What else? Merch. First of all, I think some of you would have gotten the DeSci Berlin Uniqlo bags. We also have stickers and merch up for grabs. Additionally, everyone that you see in one of these Molecule t-shirts or bio t-shirts, obviously work for Molecule or bio. Go ask them questions, pester them, they'll be able to help you. And lastly, if you are making any social media posts, please tag DeSci Berlin or Molecule. Cool, let me see if this is my list of everything. Yes, other than that, have a great time. We'll be around, and I'll see you in half an hour. Cool. Everyone, it's not half an hour.
After the presenter is turned off, please take back the USB receiver to avoid losing it.
can't go out with friends on days when my back pain is really bad. I can't sleep without medication. It's horrendous. I psychologically now have just felt so alone in my back pain, like it is something psychological, and I end up doubting myself, like what if I have all this pain and it's so real because it's stopping my life.
Going good. Amazing. Hello. Hi everyone. Hi. Time to sit down again. Hi. Can one of the volunteers please just make sure the people from the cafe and outside know that it's time to start? Cool. Welcome back, everyone. Welcome back. Cool. I'm going to wait another minute just to get our last stragglers in. But while we're waiting, I can go for a joke. So next up speaking, we have Kevin, our Chief Product Officer at Molecule. And a couple of weeks ago, Kevin was at DeSci London, which is another DeSci conference that happens every year. And Kevin was at this really fancy investor dinner, and he's chatting to the woman next to him, and you're pitching Molecule, you're pitching DeSci all the time at these sort of things. And he turned around to the woman next to him and he said, yeah, no, we put IP on chain. She turned around and she said, you pee on chain? And since then, I've literally never been able to hear IP on chain the same. So that was my joke to warm up the crowd. Thank you, everyone. But yeah, Kevin is our Chief Product Officer at Molecule. He guides the product team and the tech team with an iron fist, but with great grace, and always brings a great vibe into the office, and I think has been really doing a lot of thinking about where Molecule's protocol is going, and the next talk that we're going to have is he's going to be sharing that vision with you. We have some pretty exciting developments underway, sort of getting closer to the researchers and the data. But yeah, I'll leave it to Kevin to explain. Here he is. Do you want to leave it in there? Sorry. Oy, fuck. Sorry. There we are. I was going to say, you have so much to hold.
Hi guys, what an amazing intro, so thank you very much, Ella. I actually wanted to start off with that joke, so she stole that. No, all good. Cool, slides are on, so welcome everyone. Good to have you in our home, in our DeSci church actually. So maybe to the people that didn't know this yet. Oh, I need to go closer? Okay. I'll just stand like this. This used to be a church, a brutalist church. I think Paul mentioned this actually. So welcome to the DeSci church. Good to see all of you here. Yeah, last year I was a spectator here. That was my first DeSci Berlin. This year I get the honor to speak today. So let me guide you through the, from my perspective, most exciting presentation this whole conference. So I hope you all pay attention. I'm going to introduce to you live today our new product, which is going to be Molecule Labs, so stay tuned. Cool. Maybe before I start, who has some crypto experience, has some tokens, did this, maybe raise your hands. Who's never touched crypto before? Nice, I like the hand up. Courage. Cool. Well, let me show you. So usually what happens in crypto, and you maybe seen the slide, or the title of the slide, which is like when science, this is the sentiment in crypto. It's like when token, when the airdrop, and when my 10x. That's literally usually how the crypto space works. People are quite short term. They want to see results immediately. And this is something where, of course, working in DeSci and trying to make the connection between tokens and science, it takes a long time, a bit challenging. Before I dive in, and of course, as a VC-backed multi-million-dollar crypto startup, we delivered on the when token, right? So maybe just quickly a recap on our primitives. We have the proof of invention. We, by the way, have an amazing workshop led by Noor at 2, I think, which is going to be upstairs. Yes, Noor, you go. That is going to allow you to work with this. Literally time-stamping service for your ideas on chain, so you can prove provenance and ownership about what you have cooking, whether it's a recipe, a picture, full-blown white paper, you decide. But basically, Noor's going to do that, and Noor's going to be generous. So if you don't have any crypto, you in the front, you can go there and get some crypto. Cool. That's the first one, very top of the funnel. Then, of course, we have our beautiful IP NFT and our minter, which Paul has already talked about. It's more or less a representation of IP on chain. So it's a unique piece, a unique token. Most of you know them from NFTs, right? The expensive JPEGs, the expensive apes that people sold 3 years ago that are now all down bad. But we use this technology to basically bridge IP on chain. And I cannot say IP on chain anymore. But yeah, so immutable proof, secure transferring and licensing right, and then also just the digital future, how we bridge IP on chain. Then next up, we have the IP tokens. So this is more or less another fractionalization. So think about you have one big thing, and then you can separate this into a lot smaller things, and you can start distributing these things, right? You can sell them. You can incentivize people and say, like, here, have a share of these tokens. If it goes up, amazing. If it goes down, you're bad. But it also allows you to do a lot of other cool things that are actually quite relevant to the Molecule Labs product that I'm going to present in a second. So this being said, we have all of the primitives, and we went one step further beginning of the year and launched a DeSci screener. So if you go to molecule.xyz, and I know we're developing the plane while flying it, so it could be that the page is broken right now because we're pushing the new product, but it allows you to basically get a curated list of top projects within the space. So you have a user profile, you'll be able to understand what kind of categories are there. So are you interested in longevity, climate, whatever you want, you will find these tokens there. This was very much done initially to cater the dark side of the crypto, dark modes, to the degens, so people actually trading those assets. So it's very much about prices and basically getting insights into the tokenomics. So yeah, why am I talking all about this? It's actually the next one, right? So it's when tokenization is easy, but the hard part and the most crucial part for Molecule is actually being able to showcase the value that's backing these projects, which is the science, right? And this is something that we come along as well during our journey, was to notice that the audience or the investors or just people generally looking at DeSci were criticizing this. They were saying, okay, cool, yeah, like you have all of these amazing tokens, you raised 5 million for 7 research projects within 48 hours, but what the hell is happening behind this? Like I have this token now, but what? So I'm super excited and super stoked to introduce you. Oh, not yet. I have 3 more slides. Sorry. We very much believe in the blockchain primitives, which is don't trust, verify, and we're applying this to science, right? And basically, Web3 is really primed to distribute different sectors by creating trustless systems, meaning that you really leverage this decentralized nature of blockchain, and we're applying that to science. So the big question is, how does that look for science? How does that look for Molecule? How does that look for DeSci? And the answer, the one and only, not the one and only solution, one of the solutions is actually Molecule Labs. Woo! Cool. This being said, I'm going to introduce you a bit briefly what the product does. So to give you some context before I dive in, we really started this from 0 to 1 a couple of weeks ago. My team was going insane with crunching in. We were there yesterday, I think almost until 2 a.m., not bragging about this, just saying like we really squeezed in to get this done today. So just want to, at this stage, give a big shout out to the whole product and tech team at Molecule. You guys rock, and without you, I couldn't stand here today. So this being said, let's dive in. What is Molecule Labs? Basically, I think the easy way to describe it, it's the home for tokenized science. We want to make scientific progress transparent on-chain, so it doesn't sit in a G drive or some centralized database, but actually we want to make it transparent, so you guys can check what the hell is happening with these projects. Am I allowed to cuss? I hope. Investable and also liquid. So basically what you can expect, and this is how the product looks for the project leads, you will be able to more or less manage your whole project. So verified regular updates on scientific progress, delivering on the milestones that projects also promised while raising funds, immutable on-chain records. So every data drop that's been added, and we have an amazing provider that gives a talk later, Kamu, that will go into detail how this works, is being ledgerized on-chain. So information can't be lost. It can't be just altered by one single person, right? It's a public decentralized data storage solution. And also it is there for eternity. So Kamu leverages different solutions on how to ensure that data is not being lost somewhere. But yeah, I will leave this to the talk later from Kamu. And then last but not least, and this is where the IP token comes in, you're also able to give access permissions based on who you want to share information with. That is the public, so literally everyone can see this. That is token-gated information, so token holders have an incentive to hold the token and then also get a bit of alpha into the data that the project is generating. And then, of course, you have super confidential information that is the core team, basically thinking about like, okay, only, for example, the researchers have access to this. And when the time comes, you can still decide to change those access permissions. So what we want to do is we want to highlight the progress, we want to highlight the value that comes out of it, and then ultimately showcase the impact that comes with this. Cool. What does that mean for the project leads? So looking at VidaDAO, looking at Cerebrum DAO, Valley DAO, I know a lot of you guys are in here. You basically can think about this as a GitHub for DeSci, for science. So this is how the project is going to look like. It basically starts off with initial data room only. So because everything starts from scratch with the data, we need to get the data first. You can upload, organize your data. We support all kinds of file types. We basically allow you to get decentralized storage from the get-go, including versioning. So we'll have an on-chain record on how the files change over time. And then also making sure, because what is all of this data valuable when it just sits somewhere in isolation and no one can see it, you have an automated Telegram bot integration that allows you to create announcements on the get-go, creating shareable links for your socials, whether that's LinkedIn, Twitter, you name it, we don't choose. You can use this to just inform your community whenever there's progress, keep them updated. And the idea is not just to use this as a retrospective reporting tool, but also looking into the future, right? Thinking about like, okay, we did X, Y, Z, we raised $500,000. Now we're going to do Y, Z, and Z, and for this we're going to need follow-on fundraising in 6 months, and we're going to keep on delivering, so that also helps with credibility for the respective project. So the idea is really highlight these good projects, make sure that the DAOs and the projects are accountable, and then also make it super, super easy for users to understand how they can validate the science. For the user side of things, so token holders, public, degens, PhD gens, as Benji would say, what we are doing is we're connecting the science with the markets. So we're basically bridging that gap that is currently happening, right? Like the space is still small. We have a BioDAO ecosystem, but it is already really tough for a lot of people to follow along and understand what these projects are actually doing. And there's also a lot of critique, and for the right reasons, right? This product is here to solve this. So we are bridging that gap between the science and the markets. So you as a user, you have super easy access. You can follow the Telegram, get automatically pinged. Every file announcement is gonna be directly highlighted on the DeSci screener, so that's the black screen right there, that allows you to view the files and validate what is actually going on. It's one interface for project teams and the public together to come along. We started off with the demand side, now we're adding the supply side and bridging both of these together. So you kind of think of the yin and yang. The white one for the clean science, the black one for the degens, the speculators, to try to cater to these users as well. You can visit this right now on molecule.xyz. I hope the site is up again. And basically get instant clarity on what projects are building and shipping and which projects are not. Last one. All of this is super cool, but we're just getting started with this, right? We just started with the data, which is the most crucial part, but actually what comes next? The way we want to do it, so in this initial version, we just go with public information, right? Because we need to ensure that there's proper encryption in place and token gating mechanisms to really make sure that the data that the project leads are uploading is also protected. We are going to give a lot more advanced analytics to the project leads as well, and also, of course, to the public, where it really breaks down, for example, the tokenomics of the respective project. What are the top holders? Are there any whales? Are they making any moves? Cool, I'll manage. Yeah, anyways, advanced analytics, and then also, which is super crucial, because Paul highlighted this, right? Funding is a big part of all of this, is that this platform is going to be basically the cockpit for your respective DeSci project. Whether it's going to be tokenization, whether it's going to be IP tokens, whether it's going to be doing fundraising for your project, you can all manage this within this cockpit. So the call to action now, and I have 5 minutes, is go to molecule.xyz, check out the DeSci screener. I instructed the project leads to push these announcements. So we have VidaDAO, VidaRNA pushing, we have CerebrumDAO that's going to push updates, and we also have ValleyDAO that's going to use the product live today. I know my lawyer is in the house, so no financial advice on any of the tokens. But yeah, I really encourage you to check it out, visit the page, see the data that's being added. Join the Telegram groups, of course, of these projects as well. Stay in the loop. And then, of course, always grow the space. So if you want to launch your own tokenized IP, whether that's through a DAO or just your own project, and you want to manage this with Molecule Labs, that's something we're also going to work on in the V0.1. We just started off with the whitelist for the projects that are within our space. But yeah, next step is to open source this, so all of you have access. And yeah, don't trust, but verify the science. Thank you guys very much for this. Thank you. Cool.
Thank you so much, Kevin. Yeah, this has been such an exciting update, and we're really glad to have it out for everyone. As someone with a scientist background, I am always happy when we get to bring stuff closer to the science and people closer to the science. So yeah, call to action is you guys go and check out some project updates, or launch your own IPT. That could also work. Cool. So next up, we have James Sinker, who is the Chief Science Officer at Bio, and he'll be walking you through the Bio Launchpad, and then you'll get to meet some of the new DAOs that are going to be launching. So for those of you who don't know, Bio DAOs are community-run organizations that look at funding and progressing science within a specific topic or an area. Molecule and Bio have helped launch a number of DAOs over the years. A lot of shared learnings and things that we get to share with other people, which is great, because I think that is really the ethos of DeSci, is, everyone helps each other. So yeah, the DAOs that you're going to be meeting today have not raised yet, but they're looking to raise, or actually, I believe some of them, Spine DAO I know has raised. But other than that, we have Spine DAO, obviously Spine Research, Reflex DAO, Dick DAO, I'll let you guess that one, Sleep DAO, Microbiome DAO, and T1 DAO, Type 1 Diabetes DAO. They'll all be presenting their projects. I also had someone come up to me and ask, how do I get involved in DeSci? What's the best area? And I actually would say, honestly, these new DAOs, they're really nascent, and they often are looking to build team members and can use the support.
Please take back the USB receiver to avoid losing it.
Sorry, the laptop's talking to me. But if you guys can't hear it, then that's all good. But yeah, I think these are a really good place to get started and to get in at the ground up, honestly, when people need the help most. So if there's anything here that piques your interest, find that person and speak to them later. Cool. Thanks so much.
GM, everyone. How are we doing this morning? All right, there we go. Thank you. Thank you so much. My name is James. For those who don't know me, I'm the chief scientist here at Bio. For those who have been paying attention, we have been doing a ton of work putting incredible BioDAOs on chain. I'm going to start this one off. It's a very quick, brief intro for what is Bio, what we do, what are the DAOs, and then as Ella mentioned, we're going to pass it off to our fantastic BioDAOs to give you a taste of the science they're working on. All right. We heard this morning from Paul. We know scientists spend way too much time trying to get money, not enough time actually doing the science. As it turns out, pharma also has an absolutely massive problem. For those who don't know, we have this term in the industry called Eroom's law, which is the inverse of Moore's law. Eroom's law states that with every passing year, we get less and less efficient for producing biopharmaceutical drugs with every dollar that we put in. Also, we've learned that companies are encouraged to be spending money developing treatments instead of cures. The lifetime value to a biotech company goes down if your patients are cured of their disease. This model means we cannot expect people whose incentives are to generate profits for themselves to come and save us. We have to save ourselves. This reminds me of an adage Balaji has said many, many times on podcasts, which is it's easier to invent Bitcoin than it is to reserve the Fed. I think we have an opportunity to do the same thing here in biotech and with DeSci. BioXYZ has built this infrastructure. We're a platform where anyone can financialize and co-own scientific R&D and medicines of the future. And I'll go a little bit into what this looks like. In the same way that Fed and fiat money became Bitcoin, trad biotech is becoming DeSci, or bio. Bio is this new system. Bio DAOs are the networks, the groups, the scientists, the research collectives that are actually making that science happen, and you're going to hear from a bunch of incredible DAOs in just a moment. But for those who don't know what a DAO is, these are a set of tokenized research collectives or networks. So these DAOs are co-founded by really passionate patients or scientists in an area of expertise. They then launch a token to finance and fundraise for their research. That money goes and is spent into cutting-edge R&D. That R&D develops intellectual property, which is then monetized, and the proceeds of that monetization gets put into the next generation of R&D. The beauty of this model is that patients are now in the driver's seat. Instead of you being stuck and hoping some biopharmaceutical executive cares about delivering you a cure instead of a treatment, you are in control. You have a governance right and get to direct how this research gets developed and what the paths to monetization are. No one knows better what to do with a breakthrough drug for a disease than the people who have that disease. We've launched over a dozen DAOs in our ecosystem so far across a ton of different R&D ecosystems, and we have a bunch more that are in stealth, and I'm excited for you to hear about later. Finally, bio represents this growing portfolio, ever-growing, of DAOs and intellectual property assets that are backed by cutting-edge science. On the right side, right here, is some of the intellectual property that VitaDAO has developed, our most mature DAO that's 4 years old at this point. But as you go to the left on the stack, we get higher and higher level, where bio is sort of the representative of this entire growing ecosystem. And our vision is that we can tokenize the world's best scientific assets. We want to let patients and consumers participate in the wealth creation of biotech and actually be the drivers of where medicine goes. We foresee hundreds of bio-DAOs tackling the most important science across the world. And soon you're going to hear from some of the most exciting ones up on stage next. Thank you.
Cool. Okay. Let's welcome to the stage first. Do you have a set running order that you want to follow?
Whatever the slides have been.
Okay. Cool. Well, first up, we've got T1 DAO. Jackie? Is it you or Michael? Okay, perfect. Cool. Okay. Sorry, guys. 1 minute. While we're waiting, I'll tell you a bit about the history of this building. So the St. Agnes Church was a parish that I think started around 1920. And then post-World War II, they decided to build themselves a home. And this is how we got this fantastic building. But around 2001, they needed to scale down. And in 2011, Johann and Lena König bought this gallery. And turned it into a gallery space. They've kind of tried to keep it as similar as possible. So there's a lot of what you'll see is pretty much what you were seeing 50, 60 odd years ago, which is amazing. We are currently sitting in the town hall, essentially. So lots of education and stuff happening around in this space. It is why we colloquially refer.
Please take back the USB receiver to avoid losing it.
Computer keeps talking to me. It keeps telling me to take the USB receiver out, but hey, not my problem. But yeah, so a church space, which is why we call it the DeSci Church. Cool. Jackie and Michael, here you are.
Hi, everyone. Thanks so much for having me and Michael here today. I want to take a moment to just thank the DeSci Berlin team for putting on such an incredible event. So I have been in academia, in particular in type 1 diabetes research for the last 6 years. And if there's one thing I've noticed during that time, as we've heard today, is that traditional science and academic research needs our help. But today we're going to be talking to you about how we plan on helping T1D research in particular through the formation of a T1D-centric DAO known as T1 DAO, which is a global community advancing solutions for type 1 diabetes. So I just want to first start by setting the scene and talking about the global impact of type 1 diabetes. But what actually is T1D, or type 1 diabetes? It's a chronic autoimmune disease. So it means that when patients are diagnosed with type 1 diabetes, they live with it for the rest of their life. And it's characterized by the beta cells within the pancreas that are responsible for making insulin that controls our blood glucose levels. They are attacked by one's own immune system, which renders the patient unable to make their own insulin. And unfortunately, this disease has no cure. So instead, patients have to undergo lifelong insulin therapy. But unfortunately, insulin therapy cannot completely prevent long-term complications associated with type 1 diabetes, such as vision loss, nerve damage, kidney disease, and cardiovascular disease. But also what's very concerning is that, like a lot of autoimmune diseases actually, the incidence, so the number of new cases per year of type 1 diabetes is on the rise. So currently there's 9.5 million people living with T1D globally, but that has been predicted to reach around 13.5 to 17.4 million by 2040. And there's also a significant financial burden associated with T1D. So it's been estimated that the societal economic burden is around $500,000 per patient in the US alone. So with that in mind, it's clear that solutions aimed at managing and treating type 1 diabetes are needed. And so investing in research and development in this space, we hope that we can find such solutions. So why does T1D research actually need our help? So there's a couple of reasons listed here. First of all, there's this untapped potential in directly involving patients and advocates in T1D research. But also we know researchers in general need support both financially and through peer-to-peer collaboration, which can be facilitated through a global network. And lastly, early stage research often struggles to receive funding from larger funding bodies, despite its enormous potential. So therefore, T1 DAO has this vision to create a global community dedicated to accelerating T1D solutions. So we want to bring together researchers, clinicians, patients, entrepreneurs, and advocates in the space to collaboratively fund and contribute to T1D research. So how exactly will that happen? We've got 3 key strategies that was listed here. Firstly, as I mentioned, we want to create a global T1D network. This is really critical in bringing together people from all jurisdictions to advance T1D care. And secondly, we've come up with a strategy which comes from the fact that we're aware that finding long-term solutions that can cure type 1 diabetes will take a lot of time. And so we want to create this short-term revenue to sustain our DAO in the short term. And we want to do that by partnering with market-ready companies in continuous glucose monitoring and in consumer health to drive adoption through association with our DAO. But of course, in the meantime, we want to be investing in long-term solutions so by that we mean funding research projects, IP, and startups that are around treating and preventing T1D. So I'll hand over to Michael.
Cool, we're gonna go quickly. We got a 2-minute warning. So this is just a flywheel, and there have been a lot of models in the BioDAO space seeking to get revenues early on via consumer products, et cetera. HairDAO's done some of this, I think VitaDAO a little bit as well. So our idea is to capture a little bit of the device market in type 1 diabetes, CGM, continuous glucose monitors, and pumps, et cetera. The idea being that people would want to support a global community effort rather than a big pharma company that produces their devices currently. And some of that funding can be recycled back into the sort of early stage research to overcome some of the value of death problem in the space. So quickly, yeah, and this is our timeline, pretty self-explanatory. This is all subject to change. We're looking really for someone like a superstar academic or someone in the space to sort of headline a lot of this. I think it needs that sort of scientific credibility to move forward. And that's something that would be good for BioDAOs in general, to have someone with a little more seniority and credibility in these communities to really lead the charge rather than just Web3 people. Nothing against Web3 people. This is our team. I think one of the distinguishing characteristics of this is the excellence of the advisors. Brian from Cerebrum DAO, James Brody's a legend in the space, Web3 space, and great guy. Russell has type 1 diabetes himself and is willing to put in some funding towards this. So everything's really teed up. We just need collaborators, and particularly, someone to really lead the charge on the scientific side. So I think that's it. If you want to scan the QR code, if you have any thoughts or suggestions, we're happy to have you.
Hello. Thank you so much, guys. T1 DAO is one that I'm super excited about, namely because the team met during our DeSci Edu course, which we were running and I helped run, and is my baby. So really excited to see sort of the fruits of those labors. Next up, we have DermaDAO. DermaDAO is obviously looking at skincare, which I think is also, again, another really interesting use case, because it kind of aligns with the same sort of principles that HairDAO has, which is, these issues that I think people are confronted with every single day. And it creates this really, really impassioned, active community. So I'm looking forward to see what they say.
Nice. Today, I would like to share a story, a bit atypical. A story that I kept secret for a long time, but that I would finally like to share with you, because it is also the reality of more than 600 million people in this world. Yes, you heard right. 600 million people who, like me, are in prison.
After the presenter is turned off, please take back the USB receiver to avoid losing it.
All right. Yes. This prison is called my skin, a very reactive skin that bleeds and itches day and night, night and day. It is the story of eczema, a disease that tripled these last 50 years and touches more than a third of the kids worldwide. And did you know that eczema is not just an annoying cosmetics issue? It is also deeply linked with depression, with all the stigma, the shame, the loneliness and isolation. This disease does not have a cure yet, and is still very mysterious to this day, as its research is incredibly underfunded and communities underserved. To observe the current global funding trends in eczema treatments research, we can see there are two sides. The nonprofit and institutional sector that have put up to 8 million, and on the other side, of course, the big pharma and private sector who have put up to 2.5 billion until now, but mostly not in any long-term cure or treatments, but more in short-term band-aid solutions, and I've tried quite a few myself. And these numbers here, we're talking on a global scale. Despite these alarmingly poor numbers, and despite eczema being one of the top most burdensome non-fatal diseases worldwide, eczema is still an illness that has yet to find a cure. Because the incentives of the stakeholders who do have the money to fund its research are not aligned with the incentives of the ever-growing pool of patients. And skin is an underrated healthcare intervention. Eczema is underfunded, not because it is unimportant, but because it doesn't align with the current funding system's priorities. There are also many systemic issues in the industry, such as data, trust, integrity, that all slow down innovation. Eczema, in this context, I would have loved to have a voice and a choice in my past 30 years of eczema skin health adventures. a voice in a patient-driven community where I could share my pains but also my hopes, a voice, a choice in a never-ending spiral of blind steroid creams prescriptions. Unfortunately, I did not have that chance, and today I still suffer from eczema, but I don't suffer in silence anymore. This is why we're launching DermaDAO. We're a group of skin health enthusiasts that are building a better way. Instead of relying on academic funding, we're community-funded and owned. Our community is extremely passionate about their skin and will stop at nothing to build a world with healthier skin. And why now? We have tried all of this above, and while results are promising, we could do so much more. Skin is ubiquitous and easy to culture for doing real biotech. We've seen so many DAOs succeed in the past, and our existing patient community would love to use it to finally find their voice and choice. These screenshots are snippets of the comment section of my YouTube videos around skin health and eczema treatments. And these have been written by my community of skin angels. Our skin angels here share their unfiltered skin stories of pain, of hope, of self-compassion, of forgiveness. And they support each other by liking and commenting on each other's comments and the comments of the comments. And this is just giving me shivers because there is really something happening here. There is a demand to be heard and needs to be met. So many unmet medical needs. And here, they share tips and advices of different length and depth. And yes, there is really something here that is happening. And our dear, dear skin angels, they are the ones, I believe, that will be the first voice of our DermaDAO community. And now I'd like to introduce you to our Skin Angels team with our doctors. We have 3. They're all skin health experts, and they've helped me throughout my worst crisis in my skin journey. I've also learned so much from them, as they are also involved in different functional medicine and dermatology research initiatives. And they also advised me a lot these past years, as this is not my first venture in skin. I have built a company of skincare for kids and babies. And here on the second line, Jiyoung and Miriam, who have all the global audiences and communities in dermocosmetics, and Anne and Sarah, who have all the expertise in knowledge and products from small to big pharma companies. Last but not least, there is me. I'm a French-Korean eczema awareness and wellness advocate, and I co-founded skincare brands educating families and kids around eczema. I worked 8 years in Web3, and today I want to merge these 2 worlds to bring you DermaDAO. Here's our product roadmap. I had a 2-minute warning, so I'll skip fast. Phase 1, Community and Data Foundation, with the MVP Skin Scan app launching and Skin Streak Challenge to incentivize our community to upload pictures of their skin. And then Phase 2, Validation Engine, will launch Open A/B Trials platform and tokenized reputation without patients, research, and community. Phase 3 Plus will launch the IP crowdfunding and moonshots, such as fund biotech partnerships and launch biobank pilots with molecule labs and our communities. In terms of long-term moonshots, partial reprogramming therapies for skin renewal, phage therapy for skin microbiome correction, a big one, and a hyper-personalized aging prediction model with facial scans. So this was my atypical and atopic story. And every skin condition tells a story of hope, of trial, of patience and resilience. DermaDAO gives that story power, and it is time to stop scratching the surface. If my story, the story of so many, resonated with you, please ping me on Telegram at DermaDAO or scan this QR code to find our website and join our first newsletter. Let's write a new chapter in skin health together. Thank you.
Wow, amazing. Thank you so much. I was a childhood eczema sufferer, and I really do understand how it changes the way you interact with the world. So you've got a community member in me already. Okay, next up we have, I'm waiting for the slide, SleepDAO. Welcome to the stage, SleepDAO.
Sorry, guys.
I think we've got the wrong deck up here. Let's move on to the next while we sort this out.
Actually, this is what you guys saw earlier. This is the design work that we did as the Sleep DAO with the bio team, their graphic designer, and it was phenomenal work. Like, shout out to the bio team for the great support they provide all of their.
I was going to say, I can give you some hidden alpha. So we have our DeSci designer, Sai, who has been involved in many of the DAO's branding, and he will be giving a workshop tomorrow. So if you want to hear all about DeSci branding, you can chat to Sai. Okay, next up, we're going to have Microbiome DAO while we sort up the right deck. Yeah. We'll sort it out. Cool. Thanks for the clap, everyone. Microbiome DAO, I feel like every time I come up here, I say I'm so excited, but I really am genuinely excited about all these different DAOs. Microbiome DAO I'm very excited about because Kiho is about to get up on stage, and Kiho came to work for Molecule as a nucleate fellow about a year ago. His DeSci Berlin was he was maybe a month into his DeSci journey last year, came, met people, and literally from that sort of came Microbiome DAO, and now Kiho's full-time DeSci Max, he's spreading the word. And is starting his own DAO, which I think is really amazing, and, in all honesty. So yeah, welcome to the stage, Kio.
Thank you, Ella. Thank you for the intro. I was at the same seat there when I said I want to build a gut health DAO last year, and now we are here with Microbiome DAO. Let's go. Yeah. So what is microbiome? First, basics. Microbiome is basically a collection of microorganisms. This can be bacteria, virus, fungi, archaea. This can be around us, within us. And one of those prominent microbiome that we are discussing here today is gut microbiome, because it is most extensively studied microbiome. And if you see, microbes kind of overpower us genetically. For making up this entire complex human systems, we need 20,000 genes. But for the cumulative genetic output of these microbiomes is around 9 million genes, and they total for 10% of the metabolites that's produced in our body. And gut microbiome is the OG influencer. From obesity to depression, it produces a lot of things, and it's kind of linked with disruption of gut and other ailments that is linked to brain health, regenerative health. It could be cardio diseases, muscular health, skin health, reproductive health, a lot of different things. And why microbiome is a problem now? Because we have lost around like 44% of our microbiome compared to our ancestral population. That means we are running with half the capacity. And how are we compensating to this loss? Is by endless drugs and supplements to kind of support our system to keep us alive. And one of the prominent things that we might hear often about microbiome is that 90% of the serotonin, which is the hormone responsible for long-term motivation and happiness, is produced in the gut, stimulated by these microbes. So imagine a situation where you don't have these microbes responsible for producing the precursor of serotonin. You might not feel happiness from within. That's when you go for external supplements and drugs to feel more than what it is. So if now you understood like why microbiome is important, and now you start to look for solutions to solve this problem, right? But the microbiome industry is broken. Usually your microbiome journey starts with a stool sample. You take a sample of your fecal matter and you analyze it in the lab. And depending on where you send the sample, you get 30% variance. And each test might cost you around $250 plus. And all these data sets that has been created by collecting all these microbiome samples are predominantly coming from, around 70% is coming from Western population. So imagine if you build an AI model training with such data set, it's gonna be skewed. It's not gonna work for the global population, right? And around $1 billion worth microbiome data sets that lying down there in academia and in general microbiome ecosystem is rendered useless because they lack one important thing, which is the metadata, like who the patient is, what he ate, and what sort of medications he was going through, what sort of clinical predispositions this person had. So because of that, it's not useful. So that is where we are exactly building the data layer. We are supplying the data layer for the microbiome ecosystem, because you see like there's a lot of funding that's been pumped into microbiome research in academia, and you have $1 billion market that's operating in the space of testing companies and probiotics. So we are not going to go there. We are operating somewhere in between to provide them with real-world data sets. So our journey started here at Zoo Gramma. It's one of the pop-up cities that happened in India this year. And we ran a study with a bunch of DeSci enthusiasts, and we did a microbiome study with 55 participants around 21 days at 1/5 the cost of clinical trials, traditional clinical trials. Of course, it's not a clinical trial, but you could run trials at a cost which is way less. We just tested a lifestyle and dietary intervention. We tested a particular dietary protocol. And this is what happened. This is the first time science is coming out of institutional border. It's not just about decentralizing science, it's also deinstitutionalizing science, giving power to the people, right? So here is where we started the first village. And so this yielded some data sets, like it can be anything from patient data to clinical data, and this will belong to this data room. And then we will scale this up to a couple of other villages, and then this will generate further data rooms. As funders, you can go fund one of these pop-up city science trials, which is phase 1 of the microbiome DAO. And then this will all be part of the IP hub, something like Molecule Labs, part of microbiome DAO. The co-founders own this. And then this in the front and the back end is protected by this sort of pay-to-compute model. So this is a place where we are moving from user privacy to user sovereignty, where we are not just giving any more privacy to the users, but also giving them the ability to monetize their data and earn from it. And with this model, the buyer will not be able to copy or download your data out of the system. They will be only allowed to run computational algorithms on top of your anonymized data set. So your data remains same. You can monetize it several times. So this buyer could be anyone from a pharma company or a biotech company who's looking at gut-brain axis, gut reproductive axis, or multiple things. And we will connect them with you. And then whatever returns we get, it goes for the funders, the DAO treasury, and the co-founders, be it any other DAOs that support us in the study. And then a part of this goes as rewards for the participants. We are planning to test this, validate this MVP by end of this year. We already did one village. We have a couple more villages, which is already scheduled. And quickly going to the next one, this is so this is something that we are trying to match the speed of crypto with biotech. So it's sort of a biome trial prediction market. Let's say you have a hypothesis. You can put this hypothesis. Once a considerable stake is given to a certain hypothesis, a trial is mobilized, and then a data room comes. Again, you can validate hypothesis at a speed of crypto, closer to the speed of crypto in this way. And again, like we connected with the buyers and validate this by end of next year. So the next natural step is to incubate and use these data sets, real-world data sets, to incubate biotech ventures, specifically into the microbiome science, using DAO resources and community. And this is our value creation model, as I said. Knowledge to market products, and knowledge to innovation can be data sets and protocols. So quickly, last step. We have some current projects. One is Biome AI. You can go to our Discord and test Biome AI. What it does is trying to keep microbiome science in current, which is the knowledge graphs. So it informs physicians and everyone on what is the current update on microbiome science. And the digital twin will help you analyze your microbiome report in your personal context. Each of these reports are 50 pages long. This AI will help you to understand for your personal context. And it will challenge you in a personalized way to build new habits. And this is our app, which we are building. Interesting one thing is poop monsters. So testing, if you want to taste a stool test, it would cost you a lot, and it's not scalable, it is not affordable, and it's not available in every part of the world. So what you can do is already start using your #1 biological waste, which is your poop, as #1 health indicator, and build on that. You can collect images of your poop to build these monsters, or you can just record manually. And then if you feed it with your diet logs, then the monster would grow, and you can, at a point, you can kill this monster to generate a free microbiome testing kit, which could then help you to analyze your gut more in a more sort of personalized way. And the last project is Golden Poop Protocol. We are trying to connect with, so yeah, Golden Poop is really a golden poop. There are some people who tends to have this sort of unique microbiome, which is full of like healthy bacteria and all of that. And this is only one and only FDA-approved therapy, which is FMT, fecal microbiota transplant. You basically take a shit from a healthy person and give it to an unhealthy person, so the person recovers. And we want to connect it in a decentralized ecosystem, because this can cost you from $800 to $10,000, depending on where you live and different context. So we want to build a decentralized ecosystem for that. That's it. So finally, we are Microbiome DAO, global nonprofit. Biome is your single token to fund science and own the upside. You can join us, be a contributor, funder, give your time, help us build a community. And we put community first. And microbiome isn't a collection of bacteria. It's a natural force you don't reckon it with. Last thing, scan this QR code. We have a special DeSci Berlin micropunks. We are releasing it here. You can directly mint it to your wallet. It will be randomized based on the response that you give. And probably then you could use these micropunks to get a fermented drink after your lunch. Awesome. Thanks.
Okay, cool. So before the poo transplant, we'll just all have micro fermented drinks. Thank you, Kiho. Okay, next up we have Dick Dow. Let's hope they rise to the occasion.
Hello. Hello everyone, I'm Sun. I'm a medical doctor and I'm also a Web3 lead at DickDAO. It's really great to be here. Now, everyone please repeat after me. Are you ready? 1, 2, 3, Dick. Thank you, thank you. So, how do you feel when you hear the word Dick or even say the word Dick? Funny? Shameful, uncomfortable, and yes, sometimes it feels wrong to say the word dick out loud. And that's exactly how men feel when they have to talk about their men's sexual health problems. At this moment, there are 300 million men who are suffering from erectile dysfunction globally, and their testosterone level have dropped more than 20% in the last 30 years. Men's sperm count have decreased more than half since 1970s. And yet, there's no funding. Data shows that from 2012 to 2021, the NIH has only spent $1.6 million to fund men's sexual health research. That's only $160K per year. If this is not underfunded, what is? Now, when the system are ignoring 300 million men who are suffering, that's when we build. Let me introduce you to DickDAO. We are an upcoming bio-DAO fixing men's sexual health on-chain. Our vision is to create a community where doctors, researchers, scientists, patients, and everyday men working together toward a real solutions. They will co-create, co-contribute, co-invest, and they will co-own the cure to the real sexual health problem. At DickDAO, we are not only focused on one symptom, one disease. We are trying to fix men's sexual health as a whole. We are focusing on both physical and mental aspects of men's sexual health. And right now, we are caught in a death spiral, where if we are not doing something now, we are going to weaken the next generation of men. As you can see, both unhealthy mind and unhealthy body are both the leading cause of erectile dysfunction, low testosterone, decreased sperm count, and male infertility. And all of this will be imprinted in a genetic level or will be passed down to the next generation. And on a side note, a minor problem like forceful circumcision in some countries are one of the leading causes of unhealthy mind and unhealthy body in men's sexual health. So what are we going to do? We are going to cure erectile dysfunction. We are going to stop the declining of testosterone. And we are going to reclaim what was taken, which is called foreskin restoration. And yes, it exists for a long time, but it's now a painful and very long journey. And we're going to make it better and more efficient through science. And I want to introduce you to the infinite flywheel, where we will invest in men's sexual health research and IPs. And we will looking to use the revenue from product sales, IP licensing, tech transfer, use the revenue to buy back the DIC token, to invest in more research, more IPs, and reward contributors. That way, we'll be going to build a sustainable flywheel of innovation in men's sexual health. Now, let's talk about the elephant in the room, like, why DIC? To be honest, right now, the attention in DeSci space is not really great. Because crypto people, they care about new shiny things, funny stuff, memes. So we are going to introduce a new component into DeSci space, which is fun science, scientific memes. And that way we can grab people's attention and invite them into the community where they will learn about the real problem that we are fixing, the challenges, the cures, and the science. Essentially, we use DIC to grab attention. And we will use science to create contributors. In crypto, we have to be fast. And in science, we have to be faster because people are suffering. And right now, we are ready. Let me introduce you to this. Libio. It's our first science-backed supplement that we have been working on for years. And right now, as we speak, we are planning to conduct a scientific survey with real patients in our clinic. And after DICDAO launch, this will be our first IP token, and we will initiate a full-scale scientific trial to determine the efficiency of the product. We aim to create the first IP token that uses the revenue to accrue the value back into the IP token. So the flywheel will start since day one. Our team is led by Dr. Ravi or Dr. Nat. He is a urologist from Thailand. He specializes in men's sexual health, has treated almost 1,000 cases of ED and more. And our team consists of medical doctors who are also Web3 native like myself. So I have both medical literacy and I understand Web3 culture. So I believe we are perfect fits for DeSci. Lastly, I want to state that we are not here to compete with anyone. We are here to build in the valley of death, where no one will. I believe what we are doing here matters. DeSci matters. And I believe that DeSci will win. And I believe that we will win. Thank you. Also, I have a lot of swag and sticker to give out, so let's connect afterward. Thank you.
Thank you so much. I think it's great that they have sort of a supplement already on the go and ready to be distributed to people. I think people start DAOs at varying stages and levels, so very cool to see that there's a supplement ready for the people. Next up, we have Reflex DAO. Oh, does someone have the clicker?
Testing? Yeah. Hey, my name is Robin. I'm one of the co-initiators of Reflex DAO, and we are all about chronic disease detection, early detection of chronic diseases. So, and we do this by monitoring the autonomic nervous system of people. And so we do this by using fitness wearables, so wearables that people are using, and we are selling our own one. So the idea is the heart rhythm of a person in a fine granular way can really give you a lot of insights into dysfunctions and help you to predict when somebody will have a chronic disease in the future. So this can be 5 to 10 years in the future, and other independent research also now supports this. See this? And so our mission is basically to bring together the people who are collecting the data, scientists, which then use the data to help predict the chronic diseases, and the technicians which build all of this. So from our point of view, most chronic diseases are really preventable. So if you know about them early enough, you can start taking measures, and by continuously measuring yourself, you can then see whether these measures are effective for yourself. And so chronic diseases are kind of a very big issue. So 90% of the US health spending is because of chronic diseases. So when you have one, it's then too late to really do much about it. So our point is that you have to start early enough to measure yourself, to get information, and then to prevent it. So our team is Jason, who is doing the science part. He's a doctor in the US. Mike, who's working on the DFlow and technology. Max, he's our online marketer. And Robin, I'm the blockchain and AI guy. I work in the Web3 space for a long time already. And we're working with partners, so like we're building on existing technology, like Ocean Protocol, Peak, and we are part of UK Leap, so a research project in the UK. And we're working with other DAOs as well, and we are working with BioProtocol, of course. So the thing that we're offering is like the wearables on the one side, integrating an existing one, creating our own ones, which are then catered towards getting the specific data. We have an application in iOS and Android, and we are working on a biodata bank, where all the data is then decentralized collected, and where scientists can access the data and use it. So currently, we are supporting now the ReflexDAO R&D device. We're supporting Whoop without any subscription. So if somebody has a Whoop and doesn't want to pay, they can use it in our app. Polar H10 for ECG data, and Apple Watch. And we're working on integrating all devices that connect to Apple Health Kit and to Google Fit, so that every piece of data that users are collecting can be used in a decentralized way. Currently, we have our lab already live, so we have 102 users which are taking part in this decentralized trial that we're continuously running. So you can see we have around about 5,000 recordings, and if I could show the website, it's live, so if I do a recording now, it basically ticks up here. And this data is then available over our insights part in the decentralized lab to run experiments on it, to define trials. And our goal is to, in the future, connect this with like LLMs, so you can talk to the data of everybody, you can talk to your own data, and then you can publish these insights on the blockchain, and everybody can start using them. And so here it's in a more detailed way. So on the left side, you have the community, which brings in the data into the biodata bank. This is then connected to our lab, and from the lab, then in our clinic, you can create like products. So let's say a researcher finds a great insight, then somebody can create a subscription for the users. So they are able to then apply this to their own data. And so these are the technical components that we're building, a value chain to go from data to scientists and to clinicians, and then come back to the user itself. If we go into this into a little bit more detail, so then we have like a flywheel. So we start on the right side with the wearable users data, with the users and the data. It then goes into the biodata bank, and there can be a payment for this. From there we go to the researchers. From the researchers we go to the product, and then the individuals can start to subscribe to this. So like, let's say I want to know whether I have sleep apnea or whether I will have a fibrillation in the future. So I can take my mobile phone inside our app, I can subscribe to it. Let's say I pay $1. Now many people do this. And by everybody in the ecosystem using wallets, we are able to now distribute all of this money back to everybody without us taking the money, but the money going into a smart contract. And so we're able to now go from like multiple users' data over the scientists to the innovators who make the products back to the users, so the users get their own benefit out of it and can pay for it, but everybody kind of without the middleman is getting money back. And so, yeah, that's basically what we're building right now. We're quite far along the road, so like we're doing the algorithms right now and working on the subscription, so like we have many of the parts already covered. And the thing is that we're also on the BioProtocol Launchpad, so if you have some bio tokens and you want to create us, so here's a QR code that you can scan. After that, we will go to the auction. It's on the base chain. So if you want to put your bio tokens to a good use, then please help us with that. Yeah, and so you can also join us on Discord. So that's the QR code for that. We are selling our device already online, so if you want to buy our device, you can join us with that too. Yeah, so That's Reflex DAO. Thank you very much.
Amazing, thank you. Yeah, I mean, I think wearables have sort of permeated into most of our lives, and DeSci really is the perfect use case for it, because when you bring in those principles of Web3, of data sovereignty and decentralization, and sort of incentivization around your own personal health data, I think all the dots connect there. So yeah, really well done, Reflex DAO. Next up, we have Spine DAO. So Spine DAO is actually, I think, of the DAOs that are presenting in this slot, the only DAO that's actually run their fundraiser already and obviously has closed it and are now getting started. So yeah, welcome to the stage, Spine DAO.
Thank you so much. Thank you. So yeah, we closed. Yes. We're done with this. Okay, great. Thank you, everyone, for having me. I'm Alex. I'm a foresight strategist, and I'm also the com-lead of Spine DAO. So how is your back doing, guys? Who has great? Everything is great with your back? I'm not sure this thing is working. I can see. Give it a moment. We can do a stretch, because we're going to talk about our back. So, yeah.
We're just getting the slide deck up, everyone.
Yes, spine updates.
Spine updates. I don't know. Spine, there you are.
Choose the Google Slides, guys. There is a video there.
So yeah, maybe we can chat about Spine DAO's just raised how much?
Oh, more than 800. 800?
Yeah.
No, it's great. It's been a journey, guys. Be ready. Be ready, really.
Cool.
All right. I can see Spine DAO on this screen, but yeah, okay, great. Perfect. So yeah, we're going to talk about spine. So just quick overview. Sadly, 80% of people will experience back pain over the course of their life. It's a lot, so probably like some of you. Back pain is the leading cause of work interruption worldwide, the #1 cause of disability worldwide. And this is aggravated by our modern life, right? Sedentarity, sitting for long hours, longevity also. And then comes to this healthcare pain points such as the major shortage of medical professionals, millions of healthcare experts lacking today. And the expert burnout due to overload of bureaucracy and many other inefficiencies in the healthcare system. So that leads us to a very painful result and very painful patient story to hear, such as this one.
I can't go out with friends on days when my back pain is really bad. I can't sleep without medication. It's horrendous. I psychologically now have just felt so alone in my back pain, like it is something psychological, and I end up doubting myself, like what if I have all this pain and it's so real because it's stopping my life, why aren't doctors listening to me? When I first found out that it was like Scheuermann's kyphosis, I was like, okay, I had no idea what that was. So I went online to look, and basically all I got was a summary of like the kyphosis. It wasn't anything like specific on what causes it, on what to do about it, treatments that can actually help me. I'm trying to see doctors for the past 4 years for extreme back pain in the thoracic area.
Yeah, Samantha's experience is actually very common. And as you can see, her back pain and her back problems prevent her from living her daily life. The unmanaged pain leads to mental health problems and challenges. Also, strong painkillers usage, like daily usage. And she spent actually 4 years to look for the right expert, which might sound really weird, but this is actually super common in this field. So we have a lot of different pain points in this field, and this is what we've been working on at SpineDAO. So SpineDAO, our mission is to provide the right care at the right time, and to do that, we are building the next generation of AI decentralized healthcare dedicated to spine care. So as Paul Kuhl has just said this morning, in order for DeSci to succeed, I'm quoting him, it needs to be data-driven, and here we are. We are this generation of biodata focusing on healthcare, and if you thought that like DeSci was only about creating new drugs, think again. There are a new, probably like cohort of, DeSci projects that are more focusing on like care, healthcare, and we are somehow maybe opening this field, right, with SpineDAO. So why choosing the decentralized DAO pathway? Well, because centralized healthcare is not anymore a sustainable paradigm for collecting data, and we all know that, right? So we need to build primitives to enable individuals to contribute in exchange, like to contribute with the data in exchange to token incentives. Because in order to be like data-driven, we need to gather more and more data. Maybe you know about that. 47% of patient data are today unused. And we need to find a way actually to collect those data, and decentralization can be actually the solution. So we are building a very granular system that enables like many different things to enable actually our system to overarch the prevention, the diagnosis, the intervention, and the recovery in spine care. The agents enable conversation care, triage capabilities, monitoring of recovery progress per personalized health protocols, open access to cutting-edge studies of research, et cetera, et cetera. And so we actually, since our inception early this year, we have been launched products that are all going to be integrated into a single platform. So today, we launched Lamina. Lamina is our conversational AI agent for spine care. It's here to support both patients and practitioners with the latest in spine health knowledge, and it's actually like an AI that can listen to patients, provide information, could potentially collect also valuable data over time to help guide care decisions. We also recently launched Kronos, which is another AI. We won the hackathon, the Bio AI Hackathon from Bio with Kronos. It's a winning project that is actually overarching and bridging traditional medicine with modern science to create new hypotheses that need to be tested. And then last but not least, you will hear more about Filter very soon. It's our like patient triage AI product as well. So all those products are actually intertwined into one platform, enable actually to accelerate and solve all the pain points I just listed above, and we just heard from Samantha. So our team, it's composed, oh yeah, you can see Lamina, sorry. You can see Lamina here. This is our latest product, and you can actually use it. You can like ask any type of question related to spine. Soon you will be able also to upload all your medical imagery. And so yeah, this is SpineDAO. If you want to reach us, you can actually find me on Telegram and also on X. We are really open to welcome experts. We are welcome also to welcome technologists and also patients who would like to share their data and their journey. Thank you so much.
Cool, thank you. Yeah, I mean, like one of the observations I've made also throughout these pitches is like, I think the initial cohort of DAOs that started maybe a year or 2 years ago were really focused on funding. And so it's really cool to see now like the old DAOs and these new DAOs sort of diversify into like wearables, supplements, AI agents, and really starting to explore this full suite of what they can do. Cool, next up we have Long COVID Labs. Could we get long COVID labs? Is your mic back? Thank you.
All right. I'm here to talk about Long COVID Labs today. I'm Rohan, and at Long COVID Labs, we are accelerating a cure for long COVID. So the first question is probably, what is long COVID? So long COVID is defined as symptoms that persist 3 or more months after an initial COVID infection. So that's like fatigue, brain fog, neuropathy, heart issues, a whole bunch of stuff. But it seems to last for a long period of time. And, the pandemic's over. A lot of us have kind of moved on and memory hold that whole experience, but there are a ton of people who are still sick. There are 100 million people, at least around the world, who have long COVID now. That is costing $1 trillion per year to global GDP. That is a huge number. And now it is the leading cause of disability. It is larger than breast cancer. It is larger than asthma. It is larger than stroke. It's larger than diabetes. And this is causing a huge patient impact. The governments that are funding COVID-19 research have pretty much stopped doing that. Pharma companies are not that interested in funding this, and so a lot of patients feel desperate. And this is not just a numbers thing or a huge patient opportunity. This is actually my own personal story. So I myself got COVID in March of 2020. We're all Web3 people, so we're early adopters, so you gotta catch the new thing right away. And so I did. Initially, really mild infection. I was a healthy person, and then just kind of had 2.5 years of progressively worse symptoms. And then in December of 2021, I saw this paper from the NIH, and it actually totally changed my life. And that was an autopsy paper. So what happens oftentimes with new diseases and new viruses, we don't really know what's going on, right? And so you can oftentimes measure. And without measurement, you don't really know what's happening. What these NIH scientists did in the United States was they did autopsies of patients months and months and months after they got their initial COVID-19 infection. They died from, in some cases, not COVID, other things. But what they found was pretty horrifying. So what you can see here is basically a heat map showing viral particles all throughout the body and brain in these people up to 8 months after their initial infection. You can see particularly there's a bunch of red in the brain. It turns out that COVID-19 is a neurotropic virus. The virus had been in these people's brains for so long that it had actually started to mutate. So that's horrifying. But it's actually also very hopeful, and it was hopeful for me. Why is that hopeful? Well, it's hopeful because if long COVID, these symptoms that I was experiencing, that 100 million other people are experiencing, was caused by persistent virus, then there's a playbook that we can apply, which is antivirals. There is a host of other viruses where oftentimes you need to take antivirals and you clear the infection. Maybe that's what was going on here with long COVID. And so I started hacking on myself, finding doctors who would prescribe me antivirals and all kinds of different things. I tried a lot of stuff. And eventually I took a cue from HIV research. In HIV research, oftentimes you take these combination treatments, right? Combination antivirals. And so that's what I did. A long-acting monoclonal antibody combined with an antiviral, a replication inhibitor, and 3 treatments over 3 months. By the second treatment, my symptoms completely disappeared. And this is this journal that I was, keeping, which a lot of long COVID patients have some version of this on their phone or in their notes app or whatever. And you can see, I say kind of on, it's almost to the day, 3 years ago, I start feeling amazing, like healing is starting at my fingertips and toes and spreading all throughout my body. I'm ecstatic and thankful, and I can't believe I found a cure. It's a little hyperbolic, but it's how I felt. And we took this and raised $2.6 million with the help of Bio to basically take this idea and deliver it to as many patients as we can. And so what we're doing now is a moonshot to cure long COVID. So I use repurposed drugs. That is the fastest path to get people help, right? Those drugs already exist. How do we combine them in different ways to help ourselves? And so what we are doing now with the patient registry is basically looking at patients who, like myself, are self-experimenting with these different drugs and comparing them against each other so that we can see what doses are going to work, what combinations are going to work, what's going to be most effective to help clear long COVID. And again, like in Ethereum, people love to say it's all about coordination. Here, it's also all about coordination. So I was a hacker, a biohacker, let's say, experimenting on myself. There's a lot of us out there, but all that data is kind of just going into the ether. It's not really helping anyone. And like I mentioned right from the beginning, there's not really much funding now for long COVID research. So how do we take these patients that are desperate, that are spending oftentimes tens of thousands of dollars to find treatments and cure themselves, and turn it into standardized data that we can actually take to a cure with regulatory bodies like the FDA. And the way we do that is by standardizing the input. And so what does that look like? That looks like an at-home blood collection kit that we are sending to people. This is called the Long COVID Labs kit. So what you get is a blood draw, a wearable ECG, a clinical grade ECG, 2 minutes, okay, and a standardized symptoms test. And we take all that information, and I'll just speed it up a little bit here, and we put it into this patient registry to find out what is going to actually help people. And so we raised our community auction in January. Within 3 months, we had more than 1,000 patients that had put data into the system, blood samples, which we are now working with UCSF and other folks around the world to analyze in terms of virus, remnants of virus, proteins, and RNA. And we treated our first patient. We went from a DeSci auction to a cure, to a treatment, rather, in a clinic within 3 months. And I think that's a first in the world. And so if you have friends who may have long COVID, if you yourself think that you could help with our mission here, we're now trying to accelerate this as much as we possibly can. Governments, pharma have really left this huge patient population behind, and oftentimes you don't see these people because they're sick. They don't come out. And so it's an invisible illness, but it's a huge, huge burden. And so if you can help, please do. This is a QR code you can scan to follow us and join our community, and we would love to help. Thank you.
Amazing, thank you. And I was spreading such fake news earlier saying that the Spine DAO was the only DAO that had raised. Long COVID Labs was also obviously raised. Amazing. Last up, we have Sleep DAO.
Thank you so much. And I'm happy to be closing this amazing round of scientific DAOs. Okay, so I'm not going to go on about how important sleep is. We all know. But lately, sleep is having a moment in the limelight. This is something that I did a couple of days ago. This is Google search trends. You could see sleep in comparison to diet and workout. Honestly, I was shocked. I expected sleep to be trending up, but I did not expect it to be trending this high. Because, I mean, as far as I know, not as many people as people in my circle are interested in sleep, but this was really eye-opening for me. Sleep has a big impact on health and longevity. This has been studied for some years, but lately, over the past 10 years, there's been a lot more research and peer-reviewed research about the importance of sleep in many aspects for longevity, for disease prevention. This U-shaped curve is a relation between the hours of sleep and all-cause mortality. As you can see, the sweet spot is a bit more than 7 hours. And if you sleep longer than that, it's a mortality risk, which means probably you have other diseases. And if you sleep less than that, then it's a big mortality risk. Sleep is not as simple as just the number of hours. This is something that the research is getting more and more into. There is a formula called QQRT, quantity, quality, regularity, timing. Each of those are equally important, and science is now getting a bit deeper into what each one says about different bodily functions. For example, quantity has some correlations to heart health. Quality impacts metabolic and immune system. And you could look up some research about the metabolism of any sweets you eat, about the glucose spikes between someone who slept 8 hours and between someone who slept 5 hours. You'd be shocked how big of a difference it is. Regularity, which is arguably one of the most important things, which is going to sleep at a fixed time, waking up at a fixed time, has a big impact on vascular health, which leads to all of the vascular issues. And timing, which is when do you sleep, how regular it is, when do you wake up, has a big impact on cognitive functions, which is one of the most important things that all of us need. So our mission at SleepDAO is changing the way we approach sleep research by focusing on the community-driven part of the research in an applicable way. So what does that mean? It means that, as you saw, there's a big drive towards sleep these days, but there's not a clear community of where, there are some communities on Reddit and other places, but there is no community where science is being discussed in a transparent way, where people are collaborating. Many of the things that you've seen in the other DAOs, Spine DAO, Long COVID, people need a community to talk about, to share tips and tricks, to share issues, and to compare themselves with others. So we want to be that kind of community. Biohacker/sleep/longevity. So when I say sleep, it's not necessarily just to get a good night of sleep, but it's also how sleep can impact your day, how you can live in tune with your circadian rhythm, when you can work out at the best time possible, when you can have certain supplement at the best time possible, what type of food to eat, when. And our approach, and this is not necessarily the best approach, but this is the approach that works for us, is focusing on applicable research. So it's the research that can generate concrete results that could generate commercial output. You would see some of the examples later on. The team is me, Martin, and Aurelia. So I am a dentist by study, but I've always been working in tech as an entrepreneur, and I'm mostly a health entrepreneur, and this is what led me into SleepDAO. Martin is a sleep researcher at Stanford, and he's a sleep physician and has been practicing for over 17 years. And he built and exited a startup in ski with Bodie Miller, one of the best skiers ever. And over a year now, we've been collaborating gradually towards building and shaping SleepDAO. And Rum is one of the first people that went into VitaDAO, and he's someone who suffers from a personal issue towards sleep. And this is what led him towards working with us on SleepDAO. What are we working on? We're working on 2 projects. The first one is a Stanford study on sleep in centenarians. Some of you are familiar with blue zones. Blue zones are places in the world where people have been observed to live longer than the average lifespan. And our focus is 2 blue zones, one in Okinawa and one in Sardinia. There's been a lot of research, and there's a Netflix documentary about blue zones, but there hasn't been a systematic research on sleep, focusing on all the aspects towards sleep. Habits, the sleep architecture, the family history, the personal history, and the test results. So the idea is to work with around 100 centenarians, and we have most of those people signed up, work with them to track them over a period of a month, to try and collect all of this data, and of course publish a paper, a Stanford paper that's funded by the SleepDAO, but also most importantly is to make this data set, similar to what the microbiome was talking about, make this data set available to our community of researchers that would be part of the SleepDAO, and all of the potential value that could be generated from this towards advancing sleep and sleep science. And the second project is a regimen of sleep supplements that is in tune with your changing daily life. So this is an example. What you see here on the right is an example of what ChatGPT gave me when I asked about what are the most common sleep supplements. And there are a lot more, especially that are being researched. So our approach is to work on that research to figure out what kind of data do we need to look into personally, and how this data impacts the supplements that you should be or you can be taking on a regular basis. So imagine an app that's connected to your wearables and you're feeding it information and it's following you, and the app is giving you information about which supplements to take when. And it's not just about getting the best night of sleep, but it's also about getting the most out of your day. So the supplements that could improve your focus, improve your sharpness. And there are many of these things, but all of these things are being taken by biohackers. You could find some of these anecdotal information on Reddit, but a lot of this information is not structured, and we want to structure it and make it available in a product. So it's not just a supplement that you would buy from us or from our partner. It's a full solution that has the companion supported with some wearables and the supplement. What's next? We're hopefully launching soon. We'll let you know when. And we've been working with the bio team. We will have a new website up and running. We will publish our white paper also. All of this happening in the next few weeks. And we're looking to, I mean, we're still a small team, but now as we're getting ready to launch, and the Stanford study is scheduled to start in September. So now we're interested in collaborators, building our core team, working with more scientists, working with more DAOs. And our vision is to unlock 20% of the humanity's potential, because this is the part that we're missing by overlooking sleep and some of our circadian rhythm. Thank you so much.
Amazing. Thank you so much. Yeah, sleep is absolutely integral, and we all do it every day. So it's really important that we spend time on it. Cool. It's lunchtime. Lunch is out and around the corner. We'll see you in a bit for continuation of talks. Hello, hi everyone. Hi. Could everyone please start sitting down and getting ready for our next talk? Hi, everyone. So also, update for all of you. We know we ran out of lunch. We are ordering more. There'll be some more lunch in half an hour. So if you're still hungry, we will have some more food provided. But yeah, in general, event has been super oversubscribed, which is, I think, a great signal, even though we've run out of food. So yeah, I will announce when our additional food has arrived. Cool. Can someone shout at the people in the kitchen to Adam, I'm going to volunteer you. Please can you go and tell the people in the kitchen to come in? Yes. Cool, guys. Cool. Welcome back to, I guess, what we now call is the second half. Do you want to? Yes, I believe the streaming agency. So this is talk coming up next is going to be streamed to us live because unfortunately Ed is very busy and couldn't make it to Berlin. But yeah, Ed Boyden is a professor of neurotechnology at MIT. He currently he's a professor of brain and cognitive sciences, media arts, and biological engineering at MIT. He leads the synthetic neurobiology group, which develops tools to analyze and repair the brain, aiming to uncover the core mechanisms of brain function. We're super excited to have Ed speak. We're really honored that he's given us some time. So yeah, without further ado.
Great. Yeah, sorry I can't be here in person, but I really wanted the chance to maybe talk about a bit of the DeSci-ish or proto-DeSci work that we've been doing, and it's fun to think about where this might go in the future. So I run a group at MIT that works on technologies for mapping and controlling the brain. And recently, we've also started to think about how to apply these tools towards modeling the brain. Now, for me, the core motivation is really philosophical. I really, ever since I was about 9 years old, have been just sheerly puzzled by human existence and wondered, what are we? Why do we do what we do, think what we think, feel what we feel? Why do some of the objects feel things like us and others like trees and rocks presumably do not? And how can we be happy? How can we achieve meaning? Is there such a thing as a new kind of enlightenment that we could perhaps invent if we understood more about how we existed? So that was my childhood dream, and it was a long journey to train as a physicist and then as an engineer. And then as an adult, I entered brain science, and it also became clear that brain science was full of lots of other pressing needs. Over 1 billion people around the world have some kind of brain condition, Alzheimer's disease, ALS, spinal cord injury, the list goes on and on. None of these can be fully cured, and the treatments tend to be quite partial and have lots of side effects. In fact, these are some numbers from 2010. I think they've actually gotten worse, but to take a therapy out of the lab and into the marketplace could take a decade. The failure rate is very close to 100%. The cost is enormous, perhaps over $1 billion each in US dollars. And even if you make it all the way through those hurdles, the success is often quite partial. The treatments often don't work very well, and the side effects can be quite prominent. So what can we do? Well, I thought a lot of the history of science, and I trained as a physicist. And one very intriguing point, I think, that you can see from the history of science is that when a scientific field hits its ground truth, and one way to think of that might be, what are the fundamental elements, the building blocks, if you will, and how they interact? What emerges from the building blocks that make up a system? Then you can get to a period of great progress. Maybe the most famous example is physics, where quantum mechanics yielded the transistor, which of course led to the microchip, the laser, of course, the internet, wireless telecommunications, the list goes on and on. So physics is a great example where really understanding the building blocks and how they work together was able to yield a huge amount of progress that was not only foundational, but augmented everyday life. Chemistry, you could argue, also went through a similar renaissance with the periodic table and the molecular bond. What about the brain? What's the ground truth for the brain? Well, biology is different from physics and chemistry, and at least a couple of regards. So first is spatial complexity. The brain is a large object, right? But the cells that make up the brain are full of nanoscale tendrils and connections, and the geometry of those tendrils and connections is extremely complicated. You know, a cubic millimeter of the brain might have 100,000 brain cells with 1 billion connections, like the one we just zoomed into, called synapses. And the synapses and the cells are full of molecules, biomolecules. The human genome has about 20,000 or so genes. Those genes encode for countless kinds of biomolecules. So how can you understand a system across all those spatial scales? But it's worse. Time is also an issue. So if you are interested in Alzheimer's disease or learning or development or aging, those are slow processes that can take years, even decades. But the fastest events in the brain are quite brief, biologically speaking. Millisecond timescale electrical pulses within brain cells and millisecond timescale chemical exchanges between brain cells. So I sometimes only half-jokingly say that our problem is simple. We just have to conquer space and time. Okay, so to summarize the problem, we need a couple technologies, right? Ideally, those high-speed electrical signals, we could control them to figure out what they do and observe them as well. Those molecules, those wires, those synapses, we should ideally be able to map all of them. And such data sets, of course, are going to be extremely complicated. If we want to understand how these building blocks of life work together to mediate brain computations, we ideally need to simulate how they work together in computer software. So technologies for recording and controlling high-speed signals could be used at the same time, and then mapping technologies could be done and applied to the brain after the recording and controlling is complete, and such data sets could then be integrated. So computer simulation of the brain could potentially satisfy some of those goals that we outlined in the first slide. Maybe we could pinpoint therapeutic targets in the brain and help address conditions like aging or specific diseases. Maybe we could explore how brain cells interact to create thoughts and emotions, and maybe even touch upon the philosophical mystery that is consciousness. And of course, all too obvious in this day and age, but AI is of great excitement. If you can inspire new, more human-like AI with human-like creativity and even ethics, that could be quite interesting as well. So I'll tell you a couple of short stories about technologies we're developing, as well as sort of the DeSci prototypes that we've been thinking about over the years. And it'd be fun to think about where this all might head. Let's start with controlling the brain. So brain cells compute using electricity. Of course, you can't just apply electricity easily and hope to hit a single cell, right? Because electricity would go in all directions. If, though, you could install a little solar panel on a brain cell and then shine light on that brain cell, the solar panel would convert light to electricity, and you would be able to activate or shut down the electrical activity of that brain cell. You could dial in a therapeutic recipe even perhaps someday. And the brain doesn't have pain sensors, so you could bring an optical fiber into the brain the same way that electrodes are brought into the brains of even awake human patients undergoing deep brain stimulator implants. How to make brain cells sense light? Well, it turns out all over the tree of life, you can find molecules that convert light into electrical signals. And so in this animation, this is a single-celled green algae, and it has a little eye spot, that brownish spot in the back, which senses light from the sun and uses the sunlight to control a series of signals to control flagellae or tails to help the algae swim around. We just zoomed into the eye spot. The eye spot is full of light-activated proteins that when shined light upon, they will open up a pore and let charged particles or ions across the membrane of that eye spot. Then, through a series of signals, you get control of those flagellae or tails so the algae can swim and be near the surface of a body of water. So, this is where we got very lucky. People kindly shared the gene that encoded this protein with us. People have been studying these kinds of proteins for many years, over half a century, I guess, at this point, for biophysical and bioenergetic investigations. And we obtained the gene that encoded for this light-activated protein. And this is where serendipity hit. the gene's small enough that we can deliver it to a brain cell using a small virus. The brain cell took up the gene and was able to manufacture the light-activated protein. That was serendipitous, right? It didn't have to work. And then maybe even more serendipitously, when we shine light on the brain cell, we were able to drive the brain cells with electrical pulses, not unlike the electrical pulses that are in your brain right now as you hear me say these words. So that was a lot of luck. The molecule could have been toxic, maybe it would not have worked, but it did. Okay, this next slide has a movie with flashing images, so if somebody is photosensitive, maybe don't look at this until I get back to you. So here is an animation explaining how we can use this technology. So cells in the brain, this is a cartoon, are firing off electrical pulses. We can deliver the gene that encodes for the light-activated protein, or rhodopsin, to just some cells, for example, and not others if we so choose. So the cells that just lit up in green are little star-shaped cells called basket cells, a kind of interneuron. And if you drive the brain with light now, the cells, the basket cells that have this light-activated protein will respond, but their neighbors will not respond to light. Okay, the flashing images are now over. Okay, so this is where I would love to talk a bit about sort of the DeSci journey that we started upon. We invented a tool set like optogenetics, as we call it, opto for light, and genetics because it's a genetically encoded tool. And it's inexpensive, and we can disseminate it very, very effectively. And it gives you this sort of ground truth neural code. We deploy it. We share it as freely as possible for people to use to make discoveries. And then finally, we design. We can come back into the game and help people craft, based upon their discoveries, practical applications that benefit human well-being. I should highlight a nonprofit called AdGene was really key to making this field what it is. They disseminated the DNA encoding for these optogenetic molecules from our group, and now they disseminate, who knows how many molecules from thousands of groups around the world. And so they've sent these to tens of thousands of destinations over the years. Okay, so what kind of invent, deploy, design, as I like to call it, examples come to mind? Well, I love this example from Li Wei Sai's group at MIT. She studies Alzheimer's disease and drove brain cells in mice that model Alzheimer's disease at a specific rhythm, 40 times a second. If you do that, strangely enough, the brain starts to clean up the molecular hallmarks of Alzheimer's disease. You clean up plaques, you reduce inflammation, you improve blood flow. Now, how do we make a practical version of this? Well, the teams under Li Wei's leadership went on to design flickering lights and clicking sounds, basically movies that could replicate this brainwave, this 40 hertz gamma oscillation. And in animals, that was able also to clean up the molecular debris in Alzheimer's and to improve cognition. And so now we actually spun out a company and are running a large-scale clinical trial to try to see if we can help confront Alzheimer's disease with basically a movie. That's a great example, I think, of invent, deploy, design, and action. I'll give you one more example, blindness. Millions of people have photoreceptor loss forms of blindness. This is a mouse model of blindness that recapitulates such a condition. The photoreceptors are atrophied. The mouse is in a water maze. So mice love swimming, but they love sitting and doing nothing as well. And so the water maze has 6 arms, and the mice swim around. And if they find a platform under a lamp, they can crawl out like that mouse just did. But these are mice that are blind, and so they don't see the platform. It takes them a while to find the target. Now here's a mouse that was blind a few weeks beforehand, and now can go right to the target. We treated it with 1 dose of a gene therapy vector with our light-activated molecule, basically turning the spared cells of the eye into a camera. We share these tools with many people, and a team in Europe was able to take one of our molecules and with a blind person help restore some degree of functional restoration. He could recognize household objects. He could see doors in a hallway or lines of a crosswalk. Not perfect vision. He was not able to read fine text or recognize faces, but still very exciting to see the beginnings of a new arena of therapy. So those are 2 examples where we invented a tool, we shared it with people who then made interesting and powerful discoveries using it, and then we helped them design approaches that are practical to help people that are now in human trials. In the interest of time, I'll just tell you about one more story, which is both important for brain simulation, but also fits this model, mapping. We want a map of the brain, how our brain cells organize into networks, how our molecules organize within brain cells. I think we've all seen pictures like this, brain scans. They use MRI or other methods to image the brain non-invasively. And non-invasive is powerful, but you're not able to see individual brain cells or connections, which are much, much smaller. Each blob or voxel might contain millions and millions of brain cells. At the other extreme are microscopes. They let you see tiny things, but the wiring of the brain and the molecules that make up brain cells are nanoscale. You can't see them with an ordinary microscope. We had the idea, what if we just took the brain and made it bigger? The material in baby diapers is a swellable material. You can add water, and in this cartoon, as you can see, it'll absorb the water. The polymeric threads of the baby diaper material, shown as white lines, will spread apart from each other, and you'll get a swelling. We wondered, what if we could install those polymeric chains of baby diaper material inside the brain? If we chemically could weave a dense spider web-like mesh of baby diaper polymer, sodium polyacrylate for the aficionados, in between cells and around cells, inside cells, in between biomolecules, around biomolecules, do it just right, add water, and the polymer would swell and pull all those biomolecules, the building blocks of life, apart from each other. So this will not work on a living thing, of course, but you could use this to get the molecular anatomy of an object. And we found that it would work. Here in panel B is a small piece of the mouse brain, a couple of millimeters on the side. Panel C, about a day and a half later, we've swollen it 100 times in volume, about 4.5 times in each direction. And the polymeric threads start out very dense, like in the cartoon in the upper left, and then end up like something in the lower left. Here's a time-lapse movie of half an hour sped up to half a minute, where we formed the polymer throughout the brain earlier, and then we added water right there. And I hope you can see this piece of brain tissue is growing before your eyes. Okay, that's what it looks like to the eye. What's happening at the nanoscale? Well, what we're trying to do is to take a brain cell like this golden neuron on the left and make it look like something on the right, a constellation of biomolecules hovering in space. They've been pulled apart from each other, and that way we can image them and resolve them from each other using an ordinary microscope. What's happening chemically? This is a bit of a technical aside, but bear with me for a second because I think the payoff is worth it. In this cartoon, I'll explain to you how it works. What's happening at the nanoscale? So in this cartoon, proteins and other biomolecules are shown in brown. We had to invent anchoring molecules that would bind to these proteins and other biomolecules so we could pull them apart. Think of it as attaching little handles to everything so that we can yank on them and pull them apart from each other. Then we had to weave this dense spider web-like mesh of baby diaper polymer. We had monomers, little white spheres in this cartoon, and they self-assemble through a process called polymerization into these polymer chains that weave their way inside and outside cells and in between and around the biomolecules. And importantly, when those chains encounter a handle, they form a bond. We're almost there, right? We have a way to swell the brain and pull the parts apart, correct? Well, almost. There's one more step we had to figure out, which was softening. The molecules are very happy where they are. We have to loosen them up and get them to break their allegiance to each other using chemicals. And then we add water, and because of the softening, and because of the polymer, and because of those handles, we can now pull the building blocks of life, biomolecules, away from each other. We can then label those biomolecules with all sorts of different labels, like fluorescent or glowing molecules. Here's an actual piece of brain tissue from the hippocampus of a mouse. It's part of the brain involved with memory formation, amongst other things. And the brain cells are expressing fluorescent proteins, so they glow different colors. And we expanded it. And I hope you can see now that we can see the fine tendrils of wiring of the brain. Now, a big focus of our work, and I think this is very amenable to the DeSci philosophy, is to make things really easy to use, right? Optogenetics, which I told you earlier, is being used by thousands of research groups, Expansion microscopy is being used by thousands of groups. One of my favorite quotes from this recent news article about the technology: "It's so easy, even my 9-year-old can do it," said Dongshin Zhao at Carnegie Mellon. Okay, so let's get back to this idea of invent, deploy, design. We created a tool that can allow people to probe the ground truth of the brain. We deployed it, just like optogenetics is being used by thousands of people, expansion microscopy is being used by thousands of people. But here's something interesting. Expansion microscopy is not only easy to use, it's easy to modify. And so I'll share with you one last sort of scientific story before getting to my conclusion, which is a group in Germany led by Silvio Rizzoli was able to modify the technology and make it apply to a different kind of problem. So again, we invented the tool, we deployed it, and then working with others, we could help them design variants and adaptations of it. And here's what they did. Instead of pulling molecules apart from each other, what they did was take a molecule, anchor it to the polymer, chop the molecule into pieces, that's the new part, and pull the pieces apart from each other. And if you do that, you can kind of see the shape of the molecule. This is pretty cool, right? In gray is the ground truth, the known structure of molecules through classical techniques, X-ray crystallography, cryo-EM, now AlphaFold prediction. The false color images are single unaveraged expansions of these molecules. So it's fun to think that now with this variant that they developed on expansion, that you can visualize the shapes of molecules with ordinary confocal microscopes, in this case with the SURF super resolution configuration. Now, what we want to do now is to integrate all the different technologies towards modeling the brain. Can we record and perturb neural activity, as shown in the upper left of this cartoon, and then build molecular maps, as shown in the lower left? We can do that through optogenetic means and expansion means. Then we can make models based upon top-down machine learning inference. We can also do inference of underlying physiology of the models. And then finally, from the molecular maps, we could try to do bottom-up models. And we're doing this with a large and growing cast of characters, including many of the people named at the bottom of the slide. Our hope is to start with small brains, but to scale as rapidly as possible. Worms and fish have a fairly small number of neurons. Mice are bigger, and humans have much bigger brains. And so a very fun question then is, what versions of invent, deploy, design might we be able to encounter and explore in the time to come? I think of, in these short form talks, it's difficult to acknowledge all the people who contributed to the work, but I've had their names at the bottom of the slides. And here's an even longer list of people who have helped with these and other projects over the years. Our website is synthneuro.org, and my email is edboyden@mit.edu if you have questions. And I'd be happy to take questions now.
Thank you so much, Ed. That was extremely riveting. I'm just so grateful that you're trying to push this forefront forward on multiple angles. We have just a few minutes for Q&A, so I'm going to lead the discussion and then pass it off to the audience for questions. The first question that comes to mind here is, why do you think, or maybe I can frame this a little bit differently, there's so much promising science happening here. Why don't you think the science has progressed farther or faster than it has? What are the bottlenecks holding back your research from truly accelerating 10 times faster than it currently is?
Yeah, it's a great question. I think two things come up over and over again. I mean, I think this sort of bottom-up way of thinking about science, right, of really understanding all the building blocks and how they work together, is somewhat different than sort of a classical hypothesis-driven way of approaching science, right? But as a physicist who just wants to see the parts and how they work together, it seems very natural to me. So it's always been a bit of an uphill battle to, raise resources. In fact, when I was looking for a faculty job, I even, to set up my group and to do research, the majority of the places that I applied to actually turned down my application at the time. I was very lucky to find a home base in a interdisciplinary department at MIT, where I then was able to develop a lot of these approaches and ideas. The other thing that is sort of very interesting, and I tried to highlight this in the talk, is also just the extraordinary, almost omnidisciplinary need for knowledge. And this is why this sort of DeSci approach and philosophy is so appealing, and why we've tried to follow such kinds of principles from the very beginning. For optogenetics or expansion microscopy, we needed genes, light, hardware, chemistry. It's not just interdisciplinary science, it's omnidisciplinary. And so how can you bring people together or facilitate people to work together across every boundary possible? And that's why with the 3 stories I highlighted, the Alzheimer's therapy in trials, the blindness treatment in trials, and this version of expansion to see the shapes of molecules, I tried to really highlight how the need for expertise from sometimes very, very different sources and directions is not just helpful, but perhaps essential.
Definitely. I think it would come as a surprise to many here. It came as a surprise to me when I first talked to you. When you explained sort of the challenges or the lack of excitement when you first tried to describe the early research that you were doing, such as expansion microscopy and optogenetics. Could you share a little bit about that story for folks here to learn about what your struggles were like trying to get your research initially funded way back in the day?
Sure, yeah. I only recently started publicly talking about this. I gave my high school graduation speech back in Denton, Texas, a couple weeks ago, and then I actually, for the first time, publicly talked about how the vast majority of places I applied to for faculty jobs turned me down, and it was hard to, yeah, it was a bit surprising that people didn't really like, for the most part, the kinds of things I wanted to do. Yeah, it was sheer luck that helped me get a job. I was a teaching assistant for a professor. And I worked as an undergrad in the lab of another professor, and they worked in this interdisciplinary department at MIT where they just happened to have a job search that I guess they didn't find a candidate that they liked. And so that's how I got that faculty job. In 2015, when we came out with expansion microscopy, we kind of had a similar problem. We had a lot of struggles to get government grants. I think we had like 9 government grants rejected on the topic. And it was sort of sheer dumb luck. That seems to be a common theme of what keeps our group going, that resulted in us getting funded. So a member of our group was friends with a grad student who, it's a long chain of personal connections to the foundation known as Open Philanthropy. And they, at the time, I don't think really funded much science, but they offered to investigate what our group did and try to understand how we did things. And you can read the full report on their website, but it's like a 30-page report or something. But in the end, they said, wow, this seems like something that we should support. And so that's what kept us in the game. So it's always a lot of serendipity to keep things going. And I guess one reason why I'm interested in thinking more deliberately about DeSci and such themes in the current day is, can we do on purpose what in the past we did accidentally, right? So I gave a couple examples where invent, deploy, design kind of worked through, unstructured luck. But can we be lucky more on purpose here?
Yeah. Yeah, and that's definitely something we've been focused on, how to actually engineer these kind of outcomes instead of hoping that through luck or through serendipity, these kinds of things can naturally emerge. I'm wondering, that there's an abundance of need for scientific funding right now, especially with the day and age that we are in currently. If you could imagine that we could expand scientific funding by 1 or 2 orders of magnitude, what effect do you predict that would happen for society and for humanity globally?
Yeah, I think now is an extremely interesting time where science funding could galvanize um, real revolutions at an accelerated pace. And the reason is, I think that technologies are getting to the point where you could really try to describe a complex system in terms of all of its parts. I entered neuroscience about 27 years ago when I did my first undergrad research in neuroscience, switching from physics. And in those 27 years, I don't think we've cured a single brain condition. And even the treatments are partial and have a lot of side effects. So it's very clear that I think the big revolutions in terms of neural therapeutics are in the future. And so, but as I hope I've tried to persuade you over the last 25 minutes or so, the tools that we've built for mapping, for controlling, they're getting to be really good. And so my excitement and dream is that, in the coming years, would it be possible to map out, what an aged state really is, to map out what a disease state really is, and to pinpoint exactly where to intervene in order to resculpt that system towards a healthy or more well-being oriented state? As a very sort of bottom-up thinker who wants to see the parts and how they work together, it seems like that dream might be coming into view. So I do think that the coming years are going to be tremendously exciting. But back to your original point, I think funding to drive that forward will be, of course, essential.
I think it's something that we often say in the crypto space, which is it was easier to invent Bitcoin than it was to reform the US government or the Federal Reserve. And similarly, we think it's easier to create an alternative to traditional scientific funding than it is to try and reform the currently existing system. If you were in charge of building this new system, how would you like to see it operate? How would you engineer? What kind of incentives would you put together to have a system like this optimized for impact?
Well, a couple thoughts. One thought is, how do we evaluate scientific plans? I mean, it's very hard to do that, right? But I do think one could try to build methodologies of evaluation that are based upon first principles thinking. You know, if somebody's going to propose a new chemical tool or physical tool to investigate a biological situation or to confront a biological disease state, well, let's analyze it in terms of the underlying physical and chemical principles, right? Are there ways to evaluate science that are more structured and based upon, maybe deconstructive and analytical techniques that could be systematically applied? The second thing is serendipity. I mean, if you look at the history of science, look at CRISPR, look at fluorescent proteins, look at all the different, next-gen sequencing, the different technologies that have revolutionized biology medicine. They came from different people. They came from all over the globe. They came from collisions of fields. People often talk about Bell Labs, right? Which, had all these storied innovations in the 20th century, some of the most important programming languages, the precursor to the laser, the discovery of the cosmic microwave background radiation, the transistor, of course. And a lot of people then try to replicate, Bell Labs, right? But if you look at empirically where innovation pops up, the Bell Labs of the future is the whole Earth, right? And so is there a way to find projects and people as early as possible and then to help nurture them? And then the final thing that I'm excited about is connecting application and origins. So by the time something is commercially viable, maybe the precursor inventions, the precursor discoveries are so far back, and that leads to two kind of incentive issues. The first, of course, is that the people who developed the initial discovery or invention, they were so far ahead of their time, it was hard for them to get going. And then finally, the final commercial application usually is so far downstream that the originators aren't necessarily rewarded for their efforts. And so I'm very intrigued by blockchain-like or other ways of connecting origins of ideas to outcomes, both to reward originators of ideas and the beginnings of things, but also to connect resources to such people so that they can get going.
No, I absolutely agree with you. And from what we've seen, talent can come from everywhere globally. And we're building a new system to allow anyone anywhere in the world that wants to be a scientist actually have access to this ecosystem. Thank you so much, Ed. And let's give a round of applause for the legendary Ed Boyden.
Yeah, please stay in touch. We'd love to have more conversations. And yeah, sorry I can't be there in person.
Thank you so much.
Amazing. Thank you, Ed. Bye. Amazing. That was so interesting. To change gears a little bit, next up we have our investor panel. The investor panel is something we have every year. It's always a really interesting talk because I think as much as DeSci speaks about sort of bottom-up funding and community organization, a lot of times we do see VCs coming in and supporting these projects with sort of a little bit more significant money. And I also think it's interesting because DeSci can actually sort of appeal to both crypto VCs and also biotech VCs. So these are quite disparate sort of arms of VC work, but we see both of them coming up. And so yeah, without further ado, we'll have John from Primora Capital, who will be our moderator. And then we have Jacob from 1KX, and then Jury from, sorry guys, I should actually just unfold my paper. Give me a second. Jury from Signature Ventures. Jury also comes and hangs out in the office a lot, so it's nice to see him. And then Patrick Mayer from Prelude. Cool. There we are. So that's yours. And then you pass this one.
Is it on? Awesome. Thank you, everyone, for joining us. My name is John Spees. I'm the co-founder of Primora Capital. We're an emerging thesis-driven fund focusing on DeSci and enabling technologies. Our mission is to really back breakthroughs at the intersection of biotech and Web3. And we believe these next coming years are going to be one of the most interesting times in the sciences, with advances in AI, tech bio, and blockchain all converging. Super pleased to be here with our amazing panelists. We've all made investments and bets in the DeSci space, I think all with unique perspectives. So I'd love to hand it over to them to give a little background on themselves, what they're up to in the space, and what their thesis is.
Thank you, John. Yeah, hi, I'm Yuri. I'm running Signature Ventures, which is an early stage blockchain fund out of Munich, but I myself live in Berlin here. We're kind of investing into this new digital native space. So we started with blockchain, but it does encapsulate a couple more things as well, around cryptography as well, and identity, and also kind of AI. We have invested in Molecule back in the very, very first day. So since then, they can't get rid of me now. So I'm hanging out here. And this is my introduction also to DeSci. I myself, actually, I'm a stats person and did a PhD in computational biology. So that's my intro to Sci part.
Hi, yeah, Jacob. I work at 1KX. We're an early stage generalist crypto fund. Part of our mandate is actually investing into DeSci. And yeah, a little bit about myself. I was a biochemist back in the day. Kind of fell out of love with science for quite some time. It really felt like walled gardens. And then when I entered crypto full time, I realized there's this like whole new passionate space of like DeSci, where everything seems to just be going much quicker. Yeah.
Hi, everyone. My name is Patrick. I run an early stage first check crypto fund called Prelude. Until recently, we were known as Cherry Crypto. We've been looking at DeSci for a couple of years already. We're investors in Molecule and HairDAO. And yeah, sort of, one of the things that we always look out for is the application of crypto, Web3 technologies to new fields, and DeSci being, applying Web3 technologies to accelerating scientific progress.
Awesome. Yeah, I'd love to dive into a little bit of a bigger picture question. There's a lot of investor uncertainty in the markets right now. Bitcoin's been holding pretty steady, but a lot of other sectors within crypto are down from all-time highs. What's your case for investing in DeSci right now? And Jacob, would you maybe want to kick us off on that one?
Sure. Yeah, like first thing is, I think people like underestimate, and we just kind of, a lot of people gave up on like the fact that there's going to be sort of an alt market. Everyone's just like, Bitcoin is consensus. I think every cycle it changes. I remember around 21, people were telling me like, holding Bitcoin is stupid, like you should just do ETH. But in the end, it's just natural human behavior. As sort of we tap out on like the maximum range we can see for Bitcoin this cycle, people will be going down the sort of risk curve for more risky assets. So DeSci definitely does fit into that. And I think why we love DeSci at 1KX is not only the fact that there's a lot of like alts there that you could potentially pick up, but I think in many ways this is sort of a groundbreaking thing that not only captures the mind of the crypto degen, but it's also something that you can really explain to the average person. That's something you can have a conversation with your friends. It's not what shitcoin are you trading. It's actually like scientific research. How can we potentially use crypto to coordinate and improve the current processes that we have? So it is in terms of like price action, we might be at the bottom, and I think that's where really institutional capital comes in. It's you're a lot less emotional. You build up your conviction over years. You kind of filter out the good projects from the bad projects, and this is, if anything, a really good sort of entry point to back great companies in the space.
Yeah, I think there's like just two different ways to look at it, right? One is just looking at the price, and public tokens haven't been performing well in DeSci, but I just generally think that quality founders come into the space regardless of what the price is at. certainly something that we've seen over the years. And I think if you actually look at what's happening on the product side, I've personally never been more excited. I think we're making tangible progress, right? We have bio-DAOs that are, developing new drugs, bringing them to market, commercializing them. We have bio-DAOs that are running decentralized trials. I think there's a lot of people here in the crowd that I've been to a lot of the DeSci Berlins. There's a lot of people in the crowd here that I haven't seen before, a lot of new companies getting started. So I think it's, price is one thing, but I think if you look at tangible progress under the hood, I've never been more excited.
Frankly, I think it's a sign of maturity. Bitcoin is not the same as a bio token or a Vita DAO token and so on. And that they decouple from each other is natural and should be at some point. Now, I even believe that it makes it easier to get into DeSci now, and I see it by many people, many new people I meet here, because once all the shit basically of token action and price action is down, people with real science background and real science interest come in and they're like, okay, now we can build stuff. So to be honest, I think now is a great time to look at the new projects, and we see with bio-DAOs diversifying into very different directions what they do and what they build and what they want to achieve with. It's kind of a great time to invest now. And obviously, as an investor who's the long term in the game, exit in 10 years or so when they're going to really grow.
Yeah, no, I completely agree with all of that. And kind of just speaking of a lot of the interesting projects and kind of areas within DeSci that people are building, what are some of the more interesting kind of like DeSci use cases that you're examining? Is it strictly on more of the research side? Is it some of the publication, consumer apps? Like where are you guys kind of excited to see projects being built and that are currently being built?
Yeah, so I believe science has a big problem compared to, let's say, software programming, as in there is no horizontal tech stack for it really. As if you would be a programmer in science, you'd be basically given a bunch of components, you have to build your own computer, then you have to assembly code your project, and then to demonstrate that it actually works. It's a lot to do for a person who just had an idea of doing something. That's why in software there's a lot of tooling, a lot of tech stack, and once you have that, it's very easy to just go out and build something. So I feel like this is missing. Now, obviously, the things like molecule for the IP sector or bio for the capital formation, you're kind of starting to developing those layers and stacks. And I believe we need way more of those things and way more enablers. So I think AI agents, one of those things. Safe transfer of data, secure cryptographic data, computational stacks. So all of those things. So actually, I believe for the success of DeSci, yes, we need the people who are really excited. Yes, we need the people who build kind of the research and do the treatments and so on. But we also need the people who build the enablers for them to be able to actually do it as easy as possible, to be people to be entering the space as easy as possible, so they can build way more of that.
Yeah, I think the research space is, as we discussed, really undervalued. People are not appreciating it, being very emotional. I think, bio-DAOs like Curetopia have managed to be way more capital efficient than like traditional big pharma. That's kind of one thing that we're definitely interested in. But for other things, I think it's kind of the consumer space and really like, experimentation around could we like apply deep-in like models to sort of get as much genomic data. There's a lot of buzz around like acquiring 23andMe. I don't think ever anything has gone through, but I think we could use like deep-ins to try and like build a big data bank of genomic data. Other things are, where can we take this? Like, what could we do with our DNA? Could we potentially like, I've seen a pretty interesting project recently which is focusing on trying to basically build an app ecosystem of what can you extract from your DNA and what can it tell about you? And the ideas they had were pretty crazy, like dating apps where you like matching genetically, or could you potentially have games where your DNA is actually, or like your certain genotypes are actually giving you traits in a game. I think there's a lot to be done there, and this is like a totally underexplored space. And I think the last one is, DeSci really enables anyone to be a scientist. You no longer really have to go through like the long, painful journey of academia. And I think, democratizing the access to potentially people doing research. I think, experiments like pump science, enabling anyone, especially like, for example, young students or like high school kids, they want to like research supplements and stuff like that. This is now possible thanks to crypto rails.
Yeah, I think the way I, at a high level, look at DeSci is there's like 4 large categories. There's fundraising, there's execution, there's publishing, and then there's commercialization. And I think if one looks at BioDAOs, I would say sort of the first wave of BioDAOs were very, very focused on sort of the funding aspect, and I think a lot of them looked a little akin to venture funds, right? Taking sort of minority equity positions in other startups or funding third-party research. And I think what I'm particularly excited about are BioDAOs that actually go sort of full stack, that do everything from funding research to executing it themselves and then to commercialization. And I think we're starting to see that. I've already mentioned Herd, I'll mention them again. They've, at a fraction of the cost and at a fraction of the time, managed to repurpose an existing drug, ran an observational study, and are now commercializing it through their telehealth. And I think I'm seeing more BioDAOs really move into that space, right? Running, sort of designing the studies, owning the IP, developing it, and that's what I think at a high level is exciting.
Yeah, no, I think that's really exciting as well, and I think that kind of leads really well into our next question, as when you're investing into a DeSci project, how are you evaluating what projects are venture backable or investable? Is this distinctly different than other sectors of crypto? Do you need to bring in, biotech experts to help with diligence? Like, how are you determining, which projects are investable?
Yeah, I mean, so this answer is obviously very specific to us. I think we're first check investors, and sort of regardless of whether you're investing into DeSci or whether you're investing into, any other field, I think at the early stages, it's all about the team. So, that is the same, whether it's DeSci or other verticals, sort of what our perception is of the team. I would say what's specific to DeSci is I think you need a team that is, well-versed on the crypto side, but then also on the biosciences side, because I think you need to find an optimal balance of both. If you just have the crypto bit, you're sort of missing the science, and vice versa. You just have the science bit, and you're sort of, you're not leveraging crypto for the benefit of accelerating science. So I think finding a team that has the blend of both is probably the most difficult part, because you do need both, I think, to succeed in this space.
Yeah, I think pretty much every crypto category, there's like a common DNA of like, are these people like really understand the crypto game? I think there's a lot of that, and I think DeSci has a lot of like work to do on that side of things. I think there's incredible research, but we still need to like really understand the sort of nature of crypto and the fact that you might be actually everything in DeSci is maturing in terms of like the things that have been built out, but you're still playing the game of like you're going to be judged by your token price in many ways, especially from the people from the outside. That's the sort of easiest data point for them. So I think it's definitely like the ability to are they able to conduct the research? Are they actually really have a good shot at actually having some scientific breakthroughs, but also understanding how to play the crypto game, how to sort of cater to that, and sort of be visible also on the token side, because a lot of your token buyers, they're not going to even look that deeply into what you're building. They're like, okay, DeSci narrative, and just trading it. So you really need to be out there.
I think I agree with what you both said, and maybe add a little bit to that. We look really in, are you able to bridge from research to product? And sometimes you want to bridge that. It needs a specific blockchain component or blockchain knowledge, so this is more on the blockchain side, or the weight is more on the blockchain side. And sometimes it's more on the business model, really about like how you package that into a product and sell to people. And sometimes it's more on the research side. Can you actually pull it off and actually demonstrate that it works? So it's a little bit different every time, but it's about really bridging it from the research part to the product is really what we're about.
Yeah, no, I completely agree. And I think kind of finding how you can have a project judged by its token price, they don't always align. And that kind of brings me to the next question. Are crypto investing and biotech investing like compatible in a lot of ways? Because crypto is a very fast-moving industry. Funds are usually 5 years. LPs want liquidity, fast returns, and science takes a long time. I mean, it's oftenly quoted in this space that bringing a drug to market, it takes 10 years and $1 billion. And how do you see those aligning? And if there is that kind of perfect intersection, like where can the crypto investors find the alpha today to invest in DeSci? And anyone who feel free to take it.
Where should I start? So really, right now, I'd say they're not very compatible, right? If you purely talk about bio and purely talk about crypto, because as I said, I think there is a whole tech stack or stack missing to make them closer to each other. So my knowledge on crypto doesn't help me much about bio, and vice versa. And I can hire, of course, someone, but this is still, they're really worlds apart, and the way they become a product is very different. Now, obviously, you can get them closer over time, and it becomes like in DeSci, it becomes a thing where you start thinking, okay, can we get more people in that are with knowledge, but also able to explain it, make the videos, the research, the, simplify to the people to enter the space. And all together, as a community, start trying to push it forward. Now that becomes more of a thing now, because people are now complementary to each other, so it becomes about a team dynamic or community dynamic. Now I think this is where DeSci started. This is also what we needed and what blockchain is about there. Out of that actually comes a team that can develop something like, let's say, the last thing I saw, like HairDAO, coming from like a funding perspective to more like a laboratory perspective, developing something new, and that's kind of exciting to see, right? So if you want alpha, that's kind of the journey is the alpha, right? Look at the journey, and then you see how people developed over time, from a community to, say, something like a lab.
Yeah, I think the short answer is they can be very compatible. I think we've already seen like biotech VCs invest into DeSci projects, right? I think North Pond and KDT invested into Molecule. Pfizer invested into VitaDAO. HairDAO also recently added a biotech investor to its cap table. So I think the short answer is yes, it can be very compatible. And I mean, the goal is ultimately the same, right? You're sort of, can you bring new treatments, new drugs to market? And the way I look at crypto is just it's a new platform that can potentially accelerate drug development, right? I think a lot of people get caught up and think the crypto bit is just like the token piece. But specifically when looking at BioDAOs, it's, okay, BioDAOs are a new platform, right? Like how can we sort of leverage the community in different ways and incentivize them to accelerate our progress, right? And I think, it's sort of, it's an enabling technology in that way. And so I think we've already seen biotech VCs invest in the space, and I don't see why in the future they won't continue to do so and invest also larger sums of money.
Yeah, I mean, it's totally misaligned. That's how I think about it. Your token holder is a crypto degen that typically sits in pump fund trenches. The turnaround and their expectations for quick ROI is just unmet with how scientific research can be conducted. And I think another thing that when I talk to DeSci founders is, especially when they tokenize, is you're actually like a CEO of a public company, and you really need to like work on your comms. And maybe, I mean, like, how can you potentially align it is you exactly understand the crypto game, you understand the fact that, yeah, it might take you a pretty long time to actually get to a drug that can go into market. But can you be good at publishing research that's breakthrough? Can you show this sort of step-by-step process, be very transparent about it? And even those wins are kind of these catalysts for kind of aligning these. I think the other avenue to chase is actually supplement markets and things that can go to market much quicker. Things that like Pump Science is working on. This is a much quicker feedback loop.
Yeah, I think finding those overlaps between consumerism and patient groups and the retail investors being bought in and understanding the mission is super important for a success of a DeSci project. And yeah, I think we have time for maybe one more quick question, but like DeSci has evolved so much over the past few years. We've seen a lot of new projects come online, a lot of new infrastructure, like tokenized IP come out. When you're making these maybe future bets or evaluating current investments, and you're partnering with these projects for the next 5 years, like what are you hoping to see achieved in these next 5 years? Or what's your moonshot vision for what DeSci can really achieve? And how are you thinking about that from an investor's perspective?
Yeah, that's like why I love DeSci. It's something that can capture anyone's mind. This and the fact that we're using crypto is pretty powerful because this has like real life impact on human lives, even though they might have never heard about crypto. So I think breakthrough research coming from these research DAOs, that's something that I'd love to see. I think we're going to see potentially maybe some repurposed drugs either sold off to big pharma and the sort of distribution of royalties to token holders. These are going to be very huge catalysts in terms of like broader public interest into the DeSci space, and that's kind of what I'm hoping for, and I'm pretty sure we're going to get there.
Yeah, I think to put it simply, just the reversal of Eroom's law, right? Can we bring drugs to market at a fraction of the cost in a fraction of the time?
I'm maybe more conservative. I'd say in 5 years, proving the validity that DeSci actually works. Because looking from a corporate perspective, they like never heard of it most of the time. So even to that point is very important. And I believe either via royalties or selling IP, or even just demonstrating that the research works as well as a complementary point to institutionalized academia is very good in 5 years, I believe. Once we reach that point of view, I think there's no stopping though. So because this is kind of the Amazon showed us that books can be sold online, right? Now everything is open. But it's kind of my milestone I'm looking at.
Yeah, and I think I'm getting close to time, so I just want to summarize what we've all kind of said here today. I think we all agree that we're still very early in DeSci. We've made a lot of progress, but we're super excited about all of the new projects that are coming online and yeah, really just kind of where the space is evolving into. And I think just from what we've heard today, from the presentations, what we'll be hearing over the next few days, and I think we're all actively looking for investments in DeSci. So if there's any founders in the audience, please feel free to find us afterwards, and I'm sure we'd all love to speak. But thank you so much for the panelists, and yeah, thank you.
Thanks a lot.
Amazing. Thank you, guys. Thank you.
Cool. Thank you so much, guys. That was super interesting. Yeah, always a good panel, the investor panel. Next up, we have Ionia from HairDAO. HairDAO was actually mentioned here in this discussion. But Ionia is the Chief Technology Officer at HairDAO. We actually saw her talk in DeSci London at the beginning or a couple of months ago, our team, and we went, we wanted to speak at DeSci Berlin, and so we got her to come to speak to all of you. Ionia. Oh, there, surprise!
Hi, everyone. Well, it's wonderful to be with you all today. I can see a lot of new faces, which always makes me excited. But I'll be taking you through HairDAO. Our mission really at HairDAO, as the name suggests, is to cure hair loss. And we found that the best way to do that really is through decentralized science. So as the title also says, we're opting for a fully verticalized pharma model where, as a community, we do everything from research, drug discovery to development, and the commercialization part in-house. So I want to convince you today that this model works, and also if you have any condition that you're suffering from, give you the playbook, so hopefully you'll give this DAO approach a try as well. And I think, yeah, there we go, that's better. To kind of get you excited and make you believe that this approach has merit, I think one of the best ways to start is always to show a picture of our community member. This was him about a year ago, At this point, he's tried basically every hair loss drug on the market. That's not 1, not 2, not 3, actually 7 different drugs he was trying, both the gold standards, minoxidil, finasteride, but even more esoteric treatments. And this was the end result, until he decided to actually add our proprietary treatment to his treatment stack. And this was him 6 months later. So this community-driven approach really has merit, and I'll be taking you through how we got there. But first, I just want to put into perspective how many people are actually impacted by hair loss. And I was wondering if you all in the community would be willing to raise your hand if either you have experienced hair loss or you know someone that's experienced hair loss. Could you raise your hand? Yes, if you take a look around, that's a quite big portion of the room, and it's very much in line with the numbers. So it's actually about 80% of men, but also 50% of women that experience hair loss. And that can really be a big psychological burden. I mean, I've taken some excerpts both from our Discord, our community discussions, where people detail just, how painful this experience has been for them, but also more mainstream publication like The Economist's 1843, which details really the devastating side effects that people are willing to endure to regrow their hair. And so it's quite interesting that you can have this condition that so many people experience and suffer from, but you still don't have a solution. And so it begs the question, why is that? And as so often, it comes down to incentives. In the early stage of research, most funding comes from the government and goes to early stage academic research. The way usually these resources are allocated is in a utilitarian way. So most of the funding goes to the conditions that most people suffer from. But it's really diseases like oncology and cardiovascular disease that get most of the funding. And most other diseases are actually, fighting for scraps. And if, like hair loss, your condition isn't even classified as a disease, good luck. I mean, there's virtually no early stage funding for androgenetic alopecia. And then a lot of people ask me, okay, yeah, but what about pharma? Why aren't they interested? It makes fairly little sense. And the reason that pharma is less interested, again, is because it's not classified as a disease, which means for them, you just don't have this financial incentive layer to actually have insurance, reimburse these treatments. So pharma's not interested. Then, of course, there's also the beauty industry, like why aren't L'Oreal and these companies looking into curing hair loss? Well, they tend to stay away from prescription drugs. So, it's left this big vacuum that luckily a community has come to fill. But until now, I mean, really, the products that are available are inadequate. I mean, the only drugs that we have on the market are drugs that were actually, had the lucky side effect of regrowing hair, but they weren't initially developed for hair loss. But anyway, to take you through what does exist at the moment, we have minoxidil or Rogaine. This is considered the gold standard. The problem there is it's not necessarily effective in a large part of the patient group. So it's about 30 to 60% of patients, it actually doesn't regrow any hair. There's finasteride. This is actually a bit better. The problem with finasteride is that it comes with really, really nasty side effects. So one of our community members, for instance, he was on finasteride, and he actually had to quit it because he just got such bad depression. And even after quitting a drug like finasteride, there's actually something called post-finasteride syndrome. So the symptoms don't necessarily go away. And we're talking about, erectile dysfunction, infertility, severe depression. So it's really, really severe, but people are willing to endure these side effects because that's how much they care about their hair. You have hair transplants. These can be effective as well. Problem is they're very expensive. In the US, you pay about $15,000 to get a hair transplant. Some people tell me, okay, I can go to Turkey though. True, it's still gonna cost you about $3,000. And the problem is, your hair transplant doesn't last forever. Usually after a couple of years, the hair starts falling out, and then you can't get an infinite amount of hair transplants because you have a finite number of donor hairs. So eventually, you're gonna run out of hair to take from the back to put to the front. And not all types of hair loss are, if you have like diffuse alopecia, you can't get a hair transplant in the first place, so not good enough. So yeah, that's why the community came together to try to solve this on our own. And what I think is so exciting about this approach that I'll take you through is that you really can replicate it for whatever issue it is that you're suffering from. So the most important piece here is to find your scientist and patient ecosystem. So we have a group of about 2,000 citizen scientists suffering from research, and I tell you, they spend day in, day out thinking about hair loss. I mean, the just passion for hair loss and obsession with hair loss is unlike something I've seen in any academic institution I've researched in. I mean, people are, not remotely close to as passionate as they are in these ecosystems. And what's super interesting here is they'll actually, propose different research ideas. And as you do that, you earn our hair token. So for your discussions, and once people actually propose research ideas, they can use the token to vote on what it is we want to study in the lab. And why this is really cool in terms of alignment of incentives is that those people who spend the most time, researching, proposing ideas, debating these different ideas, they'll have the most hair token, and they're most obsessed with hair loss. So they'll really vote for whatever treatment they think is most likely to actually cure their condition. And once they voted on it, we go to the lab, as I mentioned. We will then test these different solutions. These can be gene targets or repurposed drugs on human hair follicles ex vivo. And if they regrow hair, we actually make them become part of our IP portfolio. And depending on safety and efficacy, we will actually take these into observational studies and then sell them on our telehealth. And all proceeds we've been making from our telehealth are really reinvested back into this flywheel. So we hope by recycling all these resources, we will solve hair loss. So the first picture I showed you was a collaboration between our DAO and Professor Ralph Paus, who is actually the most highly cited researcher in the hair loss space. And we had an average hair regrowth of about 42.5 hairs per square centimeters. Now, where this gets exciting is if you compare it to the regrowth of the gold standard. So minoxidil on average regrows about 15 hairs per square centimeters, finasteride about 18 hairs per square centimeters based on a 2018 meta-analysis. So really, really exciting. And the way we conduct this research is really with state-of-the-art equipment. So you can see this is with a trichoscan, which automatically actually measures the regrowth in the same area 6 months apart and automatically counts all the hairs. So as I mentioned, one of the types of research we do is we find interesting areas and commercialize them, but our community also ideates their own ideas, and then we research those. An example here being the dutasteride delivery vehicle study. So this is all about making sure that we package drugs in a way that target the hair follicle directly. And in doing so, you prevent, the treatments from going systemic and having these really nasty side effects. Very excitingly, we've opened our own lab recently. In doing so, we've also opened our own tissue bank. So we actually have a pretty much unlimited supply of hair follicles, which is very exciting. And here we're testing the repurposing of drugs and particular gene targets of interest. And some of the drugs we've repurposed, and by the way, the way we do this is pretty cool. So you actually take a healthy hair follicle and let's say a balding hair follicles, and once you have a lot of these, you can actually look at their gene expression profiles. And once you model them out, this is what a healthy hair follicle looks like, this one is what a balding hair follicle looks like. How can you shift that back to the healthy state? Which drugs are likely to do so? And here are 6 drugs we've recently patented. Some of them are prescription drugs, other cosmetics. And basically, we share all of our findings with our Discord DAO, and people are able to actually sign up for these treatments. You would be as well if you're looking to trial any new treatments. What is so cool about this approach is just how efficient it is. So as a couple of people mentioned before, to develop a new drug typically takes about $1 to $2 billion. Repurposing is slightly cheaper at $300 million. And we managed to do so for $140,000. So we're talking a 2,000-fold increase in efficiency and price. So really, this is a price tag where if you get your community together for a condition you're suffering from, you can actually really have an impact and you can solve that problem. And time, again, way more efficient. To usually bring a drug to market is around the 10-year mark. We did it in a year and a half. So really, really efficient. And actually, ever since we started our own lab, we're pushing down these price tags even more. And part of the reason we're also able to push the timeline and shorten the timeline so much is because the community actively wants to participate in these trials, because you're transparently sharing all this data as you go. And then people are like, oh, okay, actually, I trust this community, I trust these findings, and a lot of these drugs are repurposed. So you have an established safety profile already as well. So yeah, as I mentioned, our goal is to be fully verticalized, and we actually recently launched our own telehealth where we sell both the gold standards and our newly repurposed treatments. This is currently only available in the US, so if you are in the US, feel free to scan the top QR code that's going to take you to our telehealth. And if you aren't, and you're interested in hair loss, you want some advice or really to contribute your knowledge, you can scan the bottom QR code and join our community. So yeah, I hope this talk inspires you to maybe start your own DAO if there's something you're suffering from, or to join us on our journey. Thank you.
Amazing, amazing, yeah. HairDAO continues to kill it and is doing really interesting stuff. I mean, opening their own lab. If someone had said 2.5, 3 years ago that a bunch of internet nerds who all have hair loss are going to open their own lab and have a product to sell people, I think everyone would be pretty amazed. Next up, we have Clemens. Clemens is one of the bedrocks of Bioprotocol. He is the chief product officer and previously co-founded a venture studio focusing on Web3 and AI. Clemens has been around in the DeSci ecosystem, the mole bio journey for many, many years, and has been guiding bio excellently over the past couple of months and years.
Thank you. Hey. Can I also use this? All right. For everybody who's wondering, that image is AI generated, and it's basically when all your solutions work, that's how I'm going to look like. So, the hair loss and everything, we've got it solved, then I look like this. All right, I would like to talk with you about Web3 launches. It's the topic that everybody is interested in because it's about money, and everybody needs money for something, for research, for their living, for pushing the boundaries of science. And so the goal here is to make sure that you kind of get a landscape of what is the stuff that the Web3 ecosystem is made of, and that is basically how do launches work, how do launches have worked in the past, how do they work now usually, and what do we see in the space and how it is evolving. Just a quick check, how is it going with the presentation? Okay, 1 minute. Funny side note, I usually call myself C3PO, like the Star Wars Golden Man, because as a chief product officer, you basically need to speak 1,000 languages, similar like the golden tinfoil man. Because at the end, you need to speak to users, you need to speak to the founders here, you need to speak to patients, to investors, you need to speak the language of designers and of tech people. And so also the presentation that you will be seeing now is from the perspective of a lot of different people. So from investors, especially in the retail space, but also from the founders that we've been leading through the experience of actually launching a token on chain. All right, let's get started. Exploring the landscape. I guess this is the thing. All right, let's start with a history lesson. A lot of people might have been with us in the Web3 space for a while now, but I think it's very helpful to actually get us an understanding of what the process that has unfolded. Early on with Ethereum launching and a lot of other chains, what we saw is a time of the big ICOs. People might remember EOS doing a raise over 1 year with like $4 billion US. Everything was like crazy numbers, crazy hype around blockchain tech. We saw blockchains being promised to use everywhere basically. And so the hype really led to these insane launches without any product being delivered at that point, and just huge promises. Wherever there's money, you immediately see the investors come in, the VCs. They're like, hey, cool, here's music playing, so we need to get in on this. And so kind of the new VC-dominated era started, where we saw a lot of pre-seed rounds, seed rounds, valuations kicking up extremely high, and then the name of the game was usually, okay, you got to launch on a centralized exchange. And so these like pre-seed rounds often went to a valuation of 500 million, and then suddenly boom, centralized exchange listing 2-3 billion. And from there, the unfortunate reality for everybody in retail that was interested in these tokens, often they were down only. So they invested then in the centralized exchanges, and they kind of became the expert liquidity of the investors that slowly had their tokens vested, and yeah, we're basically selling into the market because they are now a liquid token. This is not to throw shade on the venture capitalists. Obviously, they were like trying to make most out of this market dynamic, but it really left kind of the small guy, the retail investor, kind of disillusioned with crypto again. And that's how really the new area, the retail micro-arrays return story kind of unfolded, like Return of the Jedi. People started to invest into a lot smaller projects. That's where also launch pads like Pump.Fun, which were focusing on memes, but you can replicate the whole thing also in other areas, were actually unfolding. And we see these micro raises where there was a lot of price discovered by market demand, and everybody with their $600 or less could invest and actually become a token holder. And this was really also fueled, and we'll see this in a second, by the development and launch of these new blockchains, which were really fast, which were allowing like low fee trading, and therefore anybody to get in on the fun. All right. What are typical fundraise models? Those are like the standardization that we have now seen in the market. There's like fixed price sales. There's usually kind of an auction or a bonding curve. The difference is pretty clear. Fixed price sales, everybody gets the same price. Auction, everybody apes in, and the price is being set over a period of time. And then the bonding curve is just as more tokens are being sold, the price increases programmatically. And for each of them, you have different platforms that made them quite famous. Gnosis Auction, Gnosis as one of the leaders in the ecosystem, we'll actually have tomorrow also the co-founder of Gnosis joining us here on a panel. They've built a lot of infrastructure that have like stand the test of time, and Gnosis Auctions were used over 560 auctions or so in this space, and they actually raised a lot of funds also for DAOs. Most of our DAOs in Bio used the Gnosis Auction to actually get off the ground in the time between 2021 and 2024. All right, so launchpads came around because they now saw, you know, these things need to be structured, needs to be standardized, and why actually have a launchpad? And the first thing is that it democratizes the fundraise for the projects, team, and communities, because there's like one gate where users can come back to see what's new on the market and what they might be interested in. And then it also gives early access opportunities for investors, specifically retail investors. That's where we often like to speak about the degens, like aping in early. But to be honest, it's not just people that are like looking for the newest hot shit. It's often also people who are just really interested in the underlying projects that are being raised. And we're going to get to some of these launchpads in a second. Often these things were no code, so anybody who was having a project could actually launch their own token with that, and low barrier compared to grants and VCs, especially grants, all the researchers know, high barrier to get actually some funding in, and VCs, long sales cycles to actually get funds as well. Now, a launchpad at the end is really just a marketplace. So you have the sellers of the token, those are projects, founders, communities, and at the other side you have the buyer, which are often retail investors, supporters, speculators, but also DAO community members that now actually got the chance to also own part of what they're supporting. And this is kind of like a matchmaking platform, so that's why these different models have been explored, such as auctions, such as bonding curves to kind of bootstrap first communities. And kind of clear winners are crystallizing themselves out here. And at the end, the incentives are quite aligned here. Buyers seek upside and participation in an early project. They try to be in something when it's just a grassroots movement. And the sellers, they obviously want to raise funds, build a community, and get also this knowledge of these people into their project. And here's something that I'm going to get back to in a bit as well, and why we're so excited about all these DAOs that are doing vertical integration of pharma and are actually pushing projects where they are patients that join the Discord are the ones that they're servicing. They're really seeing themselves as a service provider to them, is because you're creating actually these movements where anybody becomes a shareholder, anybody becomes a contributor, anybody becomes also a scientist. And this is like really lived citizen science, and that's why we believe like launchpads that we're going to present now are the future of this trend. All right, quick roundup here, just summarizing old models were very large raises usually, one-off raises where there's not like huge amounts of traction already shown. Often fixed price sales or auctions. On the right side, you see 2017, when kind of the ICO craze was kicking into over gear, and we had 1.2 billion raised in ICOs, and then EOS came, I think started in 2017, ended in 2018, and suddenly did this like insane 4 billion raise, and to be honest, I still don't know what they're doing. So now the new models came around, L2s, Solana, very small raises, usually just actually to bootstrap a liquidity pool, and they often did fixed price sales or bonding curves directly. And everybody's wondering, like, how does that raise any money if there's no money coming out of it? It can only work for meme coins, right? And the truth that I'm gonna like share with you here is no, it actually can work for a lot of different projects as long as they are able to get people excited about it, create a narrative and create traction, create attention for their project. So these faster chains created a new approach to fundraising, and that basically means through high frequency trading, you actually get a lot of volume on secondary markets. When people were trading on Ethereum, they were waiting for their transaction to end and enter the blockchain, and they often, I don't know, in 2018 or 2019 even paid $50 just for pushing a transaction. So completely unsustainable to join any market or even have an efficient trading market. And now we see actually with these fast blockchains, Solana, L2s like Base, algorithms are trading insanely fast. And with that, we see insane volumes on these blockchains, like millions and millions of volumes being traded. And the great thing is with decentralized protocols, DeFi protocols, DEXs, everybody who becomes a liquidity provider now becomes someone who is actually earning fees on these trades. And that is what everybody here is optimizing in these new approaches, is having a big liquidity pool, so that at the end, these fees are actually funding the research project and funding the project on its own. So that's why basically you see these meme coins that are launching at a very, very tiny valuation, put most of their supply in the liquidity pool rocks up to like 10 million valuation, the liquidity pool has now a position of 2-3 million and it earns 1% on that. And so if you have a lot of volume through this, you easily get, and we'll see this in a sec, at a case study, to like 50K to 150K in fees being generated per month. And so large token supplies and pools now you basically lead to this, that the teams actually still have these tokens, and these tokens are earning them a certain fee on the market. All right. This also aligns actually communities with the founding team, because the founding team now actually needs to be in public, needs to work to create attention, needs to make sure that they're pushing forward and communicating well. Science is also a lot about science communication, especially if you're raising in DeSci. And if they continuously do this, they will create the attention and therefore also the volume on their pairs, and with that also the fees that keep them running. So this is like a stark contrast to past raises that we have seen, and that we think are not working well for these founders, but also their communities, is if they raise very big rounds and then they go on to lock themselves up in a lab and disappear for years, and now use Web3 usually just for acquiring funds and not necessarily for actually building a community around their respective project. All right. There's a whole bunch of launchpads that created around this theme. Pumped Fund for memes, DAOs Fund for usually funds, like DAOs that focus around like funding DeSci protocols. Belief app is a mobile app where you can invest in apps and games. Virtuals for AI agents, Create a Bit for AI agents. On the right side, you see just some of the projects on virtuals that have, for example, you see them there, the fully diluted valuation ranging from 10 million to 76 million with the total value locked. This is what is in the liquidity pool, and then next to that, the fees can be checked on Uniswap, and we'll get to that in a sec. And these projects, like they're obviously already quite large in their volume and in their market cap, but the same thing can be achieved with a lot smaller starting market caps around 10 to 30 million, or even like go down to 5 million, as long as the volume is running well. And whoever wants to look into these agents, there's also a lot of promises still behind them, similar like in DeSci. So we think that what is being done there with agents can be similarly just done in DeSci, create movements around these topics, and then slowly start delivering on these promises. Okay, let's look at a case study, Mamo. Mamo actually launched in May 2025, so it's pretty recent. And they're basically just a trading bot that helps you manage your investment. They launched through virtuals. They're now up to a valuation, I think, of, what was it, 80 million, which is, in my opinion, pretty high. But they started with a small raise of 85K through virtuals. That paired with around probably 20% of their token supply, had a liquidity pool of 160K. And now, as a token raise, you basically get to a liquidity pool that is sitting at a 1.6 million valuation. Down there is like the pairs that you can see and the APRs that these pools are basically getting. The APR being like changing, obviously, with the volume that is being traded through them, but that means like how much is being earned through this. And I think a good way to think about this is if you have a pool that is being traded around 100 to 300K in volume per month, you can, no, per day, you usually get around like 50 to 300K in fees out of it. And if you keep this going, you can actually fund a project over like 6 months and actually have funds secured for anything that you want to do in your research projects, because especially the IPTs that we have seen usually want to raise between 150 to 300K. Now, obviously, these raises are a bit more risk on. They're not like we're doing this one-off big raise and then, you know, either it works or not. It's like you're getting onto a journey with a community that you're building, and now you're out in this market, and you obviously need to talk to people, you need to educate, you need to create content around this. It's a very different story, and so it's also very different founders that are attracted to this model. Okay. Yeah, so maybe just a couple of takeaways. Web3 launches have evolved. Investors don't like giving black checks anymore. It's just the EOS case. Please, if you know what they're doing, hit me up. There's just too many people that got burned, and they're looking for actual traction that can be showing that you have patience in your community, you have actually initial products, even if they're just tech products or AI agents that help you better understand your condition. It can be so many small things that can contribute to actually your community being bootstrapped. The fundraise needs need to be broken down into smaller chunks, usually. If, for example, there needs to be a large study run, then usually preparing for that large study and collecting fees over time and then starting that study could be an option. And at the end, it's about delivering value and through that earning fees. Create products and communities and earn fees while you create that, rather than do a huge raise and then promise a big value in the future, and if it doesn't come around, there's the big disillusionment. All right, I think that's it. Oh yeah, just to summarize, continuous community building instead of big one-time launches, continuous fundraisers instead of one-off raises. This is also like our credo now at Bio. We're redesigning our whole Bio ecosystem, or our launchpad, which is one of the things that we're doing to service these needs more, and DAOs that want to start smaller and then build and grow as they prove that, you know, they're creating products and solutions for patients in their lives. And yeah, if you're interested to speak about this thing, I will be on the other side in the workshop space, in the cafe. Happy to jam a little bit more on this. If you have a project that you're considering about different fundraise mechanisms, what's the path to go to? Happy to give feedback on these things. And yeah, that's it. Thank you so much for your attention.
Amazing, thank you, Clemens. This is why I love the duality of DeSci. We can open the session with Ed Boyden talking about hardcore science experiments at MIT, and then we can have an hour later Clemens talking about funding volume and token liquidity. It's always great fun and keeps us on our toes. Next up, we have Ethan Perlstein. So Ethan Perlstein is the founder of Perlara and also the founder of Curetopia, one of the DeSci DAOs. This time last year, he was up on stage giving a talk, and he was just the founder of Perlara at that point. In this year gap, he has managed to fundraise for Curetopia. So yeah, welcome to the stage, Ethan.
All right, good afternoon, Berlin. Wait, that's very low energy. All right, when I say D, you say Psi. D, D, D. All right, everyone's awake now. Okay, my name is Ethan. I'm the founder of Curetopia. Our mission is to end rare diseases for all humankind. Let me share a brutal statistic with you. 1 in 10 people on this planet is suffering from a rare disease. Let's prove out this statistic. Raise your hand if you have or know someone who has a rare disease. All right, we're sort of matching up the numbers. Everyone who did not raise their hand, you have a homework assignment. Ask 10 people in your network, friends, family, and I guarantee you will turn up somebody with rare disease if you don't already. So the problem is that really two major problems in the battle against rare diseases. The first is access to sustainable funding, and the second is really putting teeth into the statement of patient centricity, patient co-ownership. It is time to leave this system behind. I like to say that we're building biotech on-chain. Curetopia is the first biotech DAO that is committed to eradicating rare diseases through DeSci. Curetopia addresses the unmet needs of over 10,000, let me repeat that, 10,000 and counting rare disease communities around the world. These diseases impose a tremendous cost on society. In one study in the US alone, it was estimated that rare diseases impose $1 trillion cost. I'll get to the other side of the coin, which is the opportunity, in a second. And the major pain points that Curetopia is solving is really about empowering and rewarding patient communities with governance tokens in exchange for participating in rare disease research and contributing their data. And we also ensure anti-shelving protections of promising therapies so they don't fall through the cracks with smart contracts. These are the major pain points that are ailing rare diseases globally, and Curetopia is, as a global remit, it is going to implement Web3 to solve this problem. When you hear the word rare, part of you probably shuts down because you think, this doesn't affect me, this doesn't affect anyone I know, it's probably not important, or it's something charitable, something not really commercial. I want to convince you otherwise. I want to convince you that rare is alpha. So when I say rare genetic diseases, I want you to think rare earth metals, something very precious, something very valuable, something you have to go out and find. But once you do find that, it will be a force multiplier for technology. So rare is alpha. And this is not just me fantasizing. This is actually grounded in reality. Everyone here probably knows about the statins, the cholesterol-lowering drugs. Maybe some of you are a little bit on the older side, are probably taking a statin. Well, did you know that statins were not originally approved for the prevention of heart disease? They were actually approved for a much narrower indication, a familial form of hypercholesterolemia, people who were dropping dead of heart attacks in their 20s and 30s. Statins were originally developed for this very small population, and then only later did cholesterol get credentialed as a biomarker, which then opened up the door to seeing statins as a promising therapy to prevent heart disease, and now they're a global mega blockbuster. So this is not going to happen for every rare disease, but there is a promise of a rare disease moonshot for some rare diseases. So let me paint a picture here with some facts. And I'm not saying that NMN is going to be this moonshot, although maybe some of you are already taking this for longevity purposes. We did a number of screens, and I'll talk a little bit more about our process, but we arrived at NMN as a potential therapeutic option for a very rare metabolic disease called DHDDS. And what was really interesting about this is that we were working with families as we were developing this research process. And normally what we had done in the pre-Curetopia days was something called an N of 1. Everyone's heard of Brian Johnson, yes? Okay, so he's conducting probably the most famous N of 1 right now in the planet, but he's doing it entirely off-chain. Imagine taking that N of 1 paradigm and moving it on-chain. Now you can flip the equation, and now you can talk about scaling from 1 to N being any arbitrary number. And for some rare diseases, that N is only 10. In some rare diseases, it's thousands, but it's generally small numbers. But how do we think about scaling N of 1s? I think you do that by going on-chain. And here are just a couple of pioneer kiddos who have DHDS, and I'll show you a little bit about one of their journeys. So this is Rosie. She's suffering from DHDS. This is a progressive neurodegenerative disease. What you'll see on the before is this is her baseline. Oops, this always does this. Let's play the... No, go back. Let's play the first video first. This always happens. Well, I want you, the after doesn't have much of an effect if you don't see the before, but this is really frustrating. Normally I would ask you if you can tell the difference, and you should, but...
That was really good, Ray.
You'll have to take my word for it that she was a little bit unstable when she was walking in the before, and she's actually able to do 2 laps. This is not a cure, but this is hopefully a foundational treatment and the primitive layer of a stack that will hopefully add to as we do more and more drug repurposing and eventually shift to drug discovery. Okay, hopefully the next, I'm going to show you in reverse order just to play with your minds. This is not going to work again. I'm sorry for that. Okay, let's go to the next. Okay, actually, let's do them parallel.
Really
okay.
good,
So
Rosie. One
raise your
foot in
hand as
front
soon
of
as
the
you
other.
notice a difference.
That's it.
Is everyone's eyes open?
One foot.
Come on, do you see a difference?
No, 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 you're fine. Just do one foot in front of the other, Rosie.
Okay, maybe it will be a little bit more apparent in the next test, which is the Archimedes spiral trace. So this is her before. And maybe I'll play them both.
You can hold the other hand steady. You can hold the paper steady with the other hand.
Again, raise your hand if
and
you
now
notice
try
the
and whiz through it
difference.
without resting your hand on the table.
So these are the types of effect sizes we're looking for, not necessarily curative, but something that is sort of obvious to the eye, and then once you apply other forms of analysis, we'll be able to quantify this.
Really good.
And you can see the static images on below.
Whiz it round.
So these are what I call these off-chain N of ones. Now start to imagine a world where all of those were conducted on-chain. I also like to think about rare diseases as a wormhole. I use many different metaphors here because the word rare itself doesn't do justice to this cause. But think about a rare disease wormhole. You start, for example, in rare familial hypercholesterolemia, and you end up in treating coronary heart disease. This process, I think, is going to repeat multiple times. Again, will every rare disease wormhole take you to a common indication? No, but I think many of them will do, especially if you stack the deck and focus on certain metabolic diseases, which I think are models of longevity. And what we're doing is taking an approach where we start with drug repurposing, which has been alluded to several times because it's faster and cheaper. But the part about drug repurposing that I think people sleep on is that drug repurposing constitutes a data set for Gen AI so that you can make next generation drugs. You can start with precursors that are approved drugs and then use AI to make enhanced versions. So by strategically working in metabolic diseases, we think we're setting ourselves up for pretty attractive expansion opportunities into common diseases. You basically think about two buckets of diseases. You're either a rare disease or you're a disease of aging. So there are major tailwinds in rare that people don't often appreciate. So the likelihood of an approval for a rare disease drug is twice as high as it is for the all-disease average. And that's true at the various stages of attrition as you pass through deeper into the clinic. It's still a paltry 17% approval, so 80% of the time you're still failing. Imagine if SpaceX launched a rocket and 80% of the time it would blow up. That was the case many years ago, but now that doesn't happen. But in drug discovery, we simply have that. We're stuck in SpaceX 2010, where 90% of the time we send something down the pipeline and it blows up. The other thing I want to call out is that Web3 really allows for, I think, unlocking of major capital efficiency, and this is something that we can take to the next level with Curetopia. But in my second biotech startup, which was a joint venture between a family that was directly affected by the disease and a medicine that we were developing for that disease, we were able to trim is probably, it's not doing justice. We were able to massively shave down the cost, not so much yet as HairDAO showed, but we're going to hopefully approach those orders of magnitudes of savings. This trial that we ran for phase 3 did not work, but it taught us a lot of things that we're recycling into the next fleet of trials that we hope to get going in the next 6 months plus. So I like to say that I'm a repeat biotech founder backing into crypto. I know a lot of Web3 folks have been the pioneers into the DeSci space. And yes, I have a trad bio exterior, but I guarantee you underneath, I'm a crack degen. And so I think the perspective I want to share here is DeSci needs more, I think, hybrid species like me, people coming from a trad bio background. I do happen to have some crypto nativity as well. That was a nice add-on. Certainly wasn't essential, I think, to start out, but you better get up to speed quickly. And I've also been on the investor side, mostly focusing on YC bio companies. So I think I bring to these three sort of streams together as founder, as operator, and as investor, and now embodying them in Curetopia. So we're a composable community. Shout out Chris Dixon for the word composable. Right now, I want to call out a couple of visionary partners. Obviously, Bio, we weren't able to launch without them, and it wouldn't have been possible for me to do this without them. Also, a big shout out to Cy, our designer, who I'm not sure is in the audience, but definitely talk to Cy McClellan. He designed all of our stuff. And meet Paula, who's somewhere around here, who runs all of our marketing and content generation. We're also going to be working with Molecule, this amazing DeSci platform, excited for Molecule Labs. And then we've been working with Perlara, which is sort of our brick and mortar partner that is doing the actual drug repurposing screens. So a little bit about our team. The team has been sort of imported from Perlara. One of team members is actually in the audience here. Kristen, raise your hand. Go say hi. So I'm really excited to present this team, and we're already cooking. That's the great part about being a repeat founder is I've got a network and traction and experience, and I can put all of that to work really quickly with amazing team members. A little bit about DAO governance. We have a Cures token. We launched our our auction on Solana. We were the first BioDAO to launch our fundraiser on Solana. We raised $2 million about 3 months ago. So we've been officially cooking for only a few months. We have Cures tokens. The plan here is to utilize them, as I said in the first slide, to incentivize contributions and participation of families into decentralized trials. And then, of course, there's access to future IP that will be generated by the DAO. I'll get a little bit into that. I can't really fully explicate all the science here, but go to our website and you can take in all the information you want about using yeast avatars, yeast disease models to model inherited metabolic diseases. We have taken this platform approach of using yeast and other simple organisms to model metabolic diseases, and we've turned the crank now. And then empirically, it's no contest. Yeast gets the best bang for your buck. And evolutionarily speaking, you have a lot of conservation of these metabolic pathways. So this is why Curetopia's first platform construction enterprise is being driven by yeast models. And what I'm showing here is just a catalog of some of the programs that Prolara has worked on directly with families. These are all inherited metabolic diseases. The N refers to number of kiddos who have tried one of the substances. Hopefully you'll notice by scanning this list that many of the molecules here are like NMN. They're nutraceuticals. They're easily accessible, don't need IRB or FDA to get access to some of these medicines. So that's also super encouraging because we can obviously accelerate into the clinic. We're focusing initially on a group of related metabolic diseases called the RS genes. The RS genes are these essential building blocks of every life form on this planet. All of the proteins in your body are beads on a string, and each of those beads is attached into this protein necklace through these intermediaries called charged tRNAs. And as I said, you can think about these RS genes as like Lego bricks of life, right? So alanine, cysteine, aspartic acid, so on and so forth. These are the 20 canonical amino acids. And every single organism on this planet utilizes this Lego brick system to build up its substrates. So we're going to start with letter A, and we're going to work our way through the alphabet. And we already are excited that we have results. And I actually just got results last Friday, and I'll show those. They're hot off the presses. But our first project that we actually launched pre-auction, we had a $100,000 grant from Bio, and we were able to convert that into a screen and to preclinical candidates and to a provisional patent filing that we're preparing, all in about 3 months. And we're partnering with a patient advocacy group called Cure Ours, including the mom shown here with her daughter. Ashley, the mom, is the co-founder of this organization and is helping us access the rest of this community. And her daughter, Aubrey, will be hopefully one of the N of ones to try one of the medications that is coming out of our pipeline. So we did a one-shot screen for ARS2. That's one of those 40 building blocks of proteins. We completed that even before the auction started. And what I'm showing you in this box here, these orange dots represent particular compounds that are rescuing or therapeutic candidates for this particular metabolic deficiency. And I can't disclose the structures yet because this is obviously going to be confidential as part of our patent filing, but we're really excited that we're able to generate these results pretty quickly. And then we're at the stage now with our RS2 program where we're now screening the top of the heap. So we have 3 finalists that we're trying to narrow down to 1. This is just showing you the data that we're able to recapitulate the results of our screen, and we can trust them. And now we're hopefully going to advance with one of these 2 nutraceuticals or an FDA-approved analog. And our goal for this quarter, it's already revving up as we speak, is to scale up from this initial test flight screen to a portfolio of about 40 RS genes that represent this end-to-end cohesive therapeutic pipeline. So by bundling and by doing other types of tricks, we can unlock a lot of cost savings, a lot of efficiencies. So yes, we don't move at the speed of degen traders, we're second by second, but we're making progress on a day to week to month schedule, so not years. And the exciting part about this set of RS genes is that I mentioned that rare disease moonshot. Well, the potential here is that these RS mutations, these RS genes, are responsible for some of the most common neurological neurodegenerative condition called Charcot-Marie Tooth. So even though these RS genes are only affecting tiny microcommunities, there is a possibility that this could expand into something much more applicable. And so this is data that's hot off the presses from last Friday. Again, we have a working screen. We have a number of rescuers. These are going to go into an IP filing. We're really excited about that. And then what we're really excited about is building out this entire 40 disease pipeline over the rest of this year, and then we can start to do some really cool things. And this is where the AI agents will come in to help us extract some of the insights that are not obvious. So you can look at this plot here of the results of compounds that rescue ARS2 on the x-axis, that rescue this other, our second RS candidate that we've screened YARS to, and you can see that there's a molecule right up here that's shared between both of them. That's super interesting. There's other molecules that are shared that are rescuing both of these disease states, and then there are, of course, molecules that are unique to each of them. So as we build out this portfolio of 40 related programs, you can start to imagine this matrix growing. And of course, we're going to need bioagents to help us glean all of the insights. So this is our roadmap. We're maybe a little bit touch behind here, but mostly sticking to this schedule. We had to trim our sales just a bit from 60 diseases down to 40 because the auction pulled in a little less than we might have anticipated. Grateful the auction even worked at all, given how brutal the mini bear was a few months ago. So we're really excited to be cooking and executing as we speak. And if you want to follow along, you can follow along on X, you can follow along in our Telegram. We'll be launching a Discord server later this month. But we're really, really excited to hopefully be launching our first N of ones on-chain later this summer. Obviously more to share on that soon. And then Curetopia will have, by the end of this year, a wholly owned, fully proprietary portfolio of programs where each shot on goal might have been, in the end, 25, 30, 40K. So harking back to those numbers that HairDAO showed, I think that's going to be systemic across all DeSci, where we're going to drive down costs by orders of magnitude. And then, of course, that translates to major ROI on the other side. So we like to think about community medicines, maybe platforms in a pill. As I already showed you, just a pairwise comparison of 2 of our R's genes is already showing us common rescuers. Maybe we can find one molecule that could work across this entire family of diseases, so that you take these really small communities and start to stack them up into something a little bit more commercializable, a little bit more investable. We can go DTC with this approach. We can follow in the footsteps of VitaDAO, and I mentioned Brian Johnson and his blueprint are both proof points of how one could go direct to consumer, especially with these nutraceutical focus. And then, of course, we've heard a ton about IP NFTs and then subsequent IPTs, and we have plans also to spin out potential entities into commercially focused clinical stage companies focused on particular assets. We can co-develop with partner companies. We can even out-license in cases where we trust a partner, for example, partnering with a public benefit corporation. So thank you for your attention. This is Curetopia. Our mission is to end rare diseases for all humankind. Please check us out, curetopia.xyz. Happy to answer any questions in the follow-up sessions later. Thank you.
Cool, amazing. Thank you, Ethan. I mean, if we're not here to make sick children better, what the hell are we doing? So yeah, really, really great use case of DeSci. Okay, everyone, I can feel you guys getting restless. We got a 10-minute break. It is raining outside, but go get a coffee, go to the bathroom, do whatever you need, and we'll meet back here in 10 minutes.
After the presenter is turned off, please take back the USB receiver to avoid losing it. after the presenter is turned off. Please take back the USB receiver to avoid losing it.
Hello. Hi, everyone. Hello, hello, hello. It is time for our final session of the day. So if you can all make your way to a seat and get ready. Good, good. I'm gonna close. Stop it. Okay, everyone. Please take a seat and quiet down. It is time for our final session of the day. It's been a great day. I think I've particularly enjoyed hearing from the new projects and the new things that are coming out of the ecosystem. Tomorrow morning, we delve into AI, which will be very interesting. Obviously, AI is super topical. And I think the impact of AI in science is one of those things where it's a how long is a piece of string. I think if you speak to some people, they say it's the answer, it's the future. And if you speak to other people, they say, you know, the capabilities are really not there yet. And we're not ready to sort of fully transition. So we'll explore that a lot more tomorrow, which I hope to see you all there. Okay, guys. Quieten down, please. Thank you. Okay, so to open up our last session, we have Sergi. So Sergi is from Camus. Camus has been supporting our product team, working very closely with them to get Molecule Labs off the ground. So we're very grateful for them and their help. Sergi is very passionate about open data and citizen science. And so, yeah, that's kind of what led him to co-found and become the CEO of Camus. Welcome to the stage.
Right, hello everyone. It's an honor to present to you today. So as you saw from multiple presentations, data is really fundamental to a lot of data DAOs that presented today. And let's talk about data. So I've been in data for 15 years as a senior architect building data pipelines for big tech companies. My co-founder, Nilay, who's also here today, she's a professor of ML and AI in Simon Fraser University. So we joined our forces to use latest enterprise and Web3 technologies to unlock global collaboration on data processing. We started a company just right when COVID hit, and pandemic was widely regarded as the failure of global data infrastructure. You might remember in May 2020, UK was still using phone, pen, and paper to tally up all the results of the lab testing. And they later admitted that the data they were collecting for like 3 months was completely unreliable and shouldn't be used for any research. In October, they upgraded to a shared Excel spreadsheet file that overflowed and 16,000 cases were lost. The people like you, the volunteer researchers, basically saved the day and were providing observability in the early days of pandemic onto how the pandemic was evolving. For example, in 2021, COVID Tracker project in the US logged 20,000 hours of volunteer time on data entry alone. So this is like 10 years of full-time work to integrate data from multiple sources, from web pages, press releases, from different municipalities, to bring it all together. So this is obviously hugely inefficient, but to us it was a striking example of this global collaboration on data entry and data sharing, data processing. Fast forward to today, all these efforts are undone. Data sets are either not updating or gone, databases are offline, websites shut down. So it's really sad that it took us a global pandemic to just start collecting these basic metrics like hospital bed occupancies or how many people were admitted with different diseases into the hospitals. But it's even sadder that we failed to sustain these efforts. So to me, it's almost like a verdict to every effort that comes after, like, oh, we want to track the spread of the other diseases. It's almost like a verdict that unless something big changes, this is not going to be sustainable. So we're seeing a huge systemic problem. After dozens of open letters, petitions, hundreds of calls for funding, there's still little results. So to me, it's clear that we're just hitting the limit of human capacity, and we need to solve it with better technology. And the core thesis of my talk today is that this is actually one big problem. Different sectors just experience different aspects of it more acutely, and they've developed niche solutions to address them with no common foundation, the foundation that is needed for efficient data exchange. And we believe that there is no shortcuts left. Like if we want to solve the research data problems today, we will need to solve the whole thing. We will need to fix the global data economy. So we have like 10 minutes, so let's try. Paraphrasing Kuhn, the best way to untangle and dismantle the established way of doing something is to find these clear anomalies and pull on them like loose ends of the sweater until the whole thing unravels. So the first anomaly is reproducibility and dynamic data. 90% of researchers believe that there is a reproducibility crisis going on, and we have many tools for the analysis, like dependency pinning, containers, reproducible environments, but the source data, the inputs of the whole process are often non-reproducible. For example, it's reported that 80% of government data perpetually loses history. It's mostly due to bad modeling, some poor infrastructure, but sometimes even censorship, where data sets can just disappear by the decree of someone. How researchers are dealing with this? They do snapshots, right? Before they start their research, they copy the data from original source into some research data management platform like Dataverse or Zenodo. And as a result, we have many copies of similar data existing in dozens of different portals that is always outdated, unclear where it came from. It's creating a systematization nightmare. We're creating data swamps. None of the COVID-19 data, very interestingly, was in RDMs when the pandemic was ongoing. RDMs are basically treating data as books in a library where you put it on a shelf and don't touch it anymore. But this data was changing daily, and the version file model just didn't fit for it. It was uploaded later into RDMs just for archival purposes. We believe that most of the world's data is dynamic, like finance, IoT, blockchains are just very extreme cases of it. But even archaeological data sets continuously evolve. They're extended and revised. So we believe that data should not be treated as books in a library. Data is a rocket fuel of our society, and this fuel should flow. The solution are ledgers. They existed for millennia. We no longer need to write them on clay tablets. And this is a perfect tool that combines archival and real-time. So the ledgers are append-only. So this means that if you have a position on a ledger, this is a stable reference that you can publish a paper with. If you need to do a retraction or correction, you do it explicitly afterwards. So we're talking about pushing reproducibility towards the source, towards the publisher of the data. We can use tools like signing to make the data tamper-proof and assign accountability to the publisher for the data that they're providing. And instead of copying, we use replication. It's similar, but different in the sense that replicas always point to the source of where the data actually came from. So we built Camus CLI as our first product. We call it Git for dynamic data. And its purpose just to make working with ledgerized data super easy. So you can ingest data from external sources into these ledgers. You can explore data with embedded SQL, embedded Jupyter, and very easily to share these ledgers with your colleagues through any decentralized storage like IPFS or just common cloud storage. Second anomaly is reuse. According to Forbes, 80% of time of data scientists is still spent on collecting and preparing data. So super inefficient. In Camus, we say that 100% of this work is bound to be repeated. You might have seen a lot of data sets on GitHub, Kaggle, Hugging Face being shared as improved data sets. So person goes to original source, they take the data, collected from official sources, they clean it up, harmonize it, integrate it into some machine learning ready data set. So desire to collaborate clearly exists globally, but verifying such data sets takes more time than redoing the work from scratch often. The serious projects that are started, they always start from scratch from official sources. So the reuse is clearly broken. Our solution to this is verifiable computing. In Camus, we clearly separate derivative data from the source data. So the derivative data is just a function of the source data. And we use cryptographic proofs to ensure that the results are verifiable in seconds, not in weeks or months. As a side effect of cryptographic proofs, you get 100% reliable provenance. So you always know where the source data is coming from. You can unravel the whole chain. So we're talking about big mindset shift here towards thinking that data without provenance is fake and should not be relied upon. In Camus, we use verifiable computing. We basically created wrappers on top of very widely used open source data processing engines. And we published how exactly provenance should be tracked and proofs should be tracked as open formats and protocols. Third anomaly is composability. So if we zoom very, very far back, this is my kind of artistic rendering of how the data ecosystem functions right now. Right now, there's only one degree of separation, usually. You're either a publisher of data or a consumer of it. And we have these small ecosystems forming around interesting data sets that mostly just don't interact with one another. If you look at the software, the picture is completely different. We have libraries built on top of thousands and thousands of other libraries. We have massive dependency graphs. So clearly, software reached the level of true composability and data did not. So what is different? And we believe that our foundational computation model is wrong. So our society mostly functions what we call batch data flows, where a person, like close to a data source, takes the data, processes it, reshares it with their colleagues in some new format. Other person picks this data up, transforms it into something else, reshares it again. So people are just constantly moving data, touching data manually, and this results in huge latency. Like think of meta research, right? It takes years. So the data you see and the data that decision makers use is actually completely outdated and is its value is significantly decreased. The solution here is temporal processing. So it's a new computational model for dynamic data. I cannot explain it now, but you can see my other talks where I go in detail. The quick gist of it is that in batch model operates on finite sets. So it expects your inputs to be consistent and complete. And this is almost never the case, especially when you're working with multiple data sources at the same time. Temporal data processing model operates on ledgers that are continuously evolving. So as your inputs evolve, your output is also going to evolve, and it eventually gets into a consistent state. So best analogy I have is it's like calculus of data. It's really significant innovation, and it's a revolution in enterprise data space that is now we're taking and using for open data science. I feel like for the last decade, I've been building these Rube Goldberg machines in batch that are super complex, manual, and fragile. Now we're moving towards the space of pipelines, super homogeneous, autonomous, and self-correcting. In batch data flows, as you can see, people are basically the cogs in the machine. They're on a hot path of the data that causes a lot of latency. People are just, by their nature, unreliable. In temporal data flows, we're extracting people from the chain. So people are becoming the designers and maintainers of the pipeline, but data itself just flows through these pipelines. It can flow through real time, even if you have thousands and thousands of different processing stages owned by different organizations and by different people. So this is the foundation of our commune node. This is how these data flows and pipelines look in our platform. And this is the platform that powers Molecule Labs project. Let's talk about effects. How I see it is that we spent the last couple of decades in data space descending into local optima, this local optima of batch and inefficient data exchange. Now with temporal processing and verifiable computing combined, this defines a really interesting new space in data that I think we're going to be moving towards in the next decade or so. It has a really cool effect on systematization. Because of the ledgers, there's less copying, therefore less noise, and pipelines naturally self-organize around each other. So important data flows are being maintained, they're being cross-verified by the whole community. So we can reach the effects of open source revolution in software, but now apply it, reach the same effects in data. Really cool effect on life cycle of research this can unlock. So imagine you have some healthcare data publishers. They can publish data completely decentralized way, achieve sovereignty of data. By publishing data through these ledgers, they're basically held accountable for the data that they're providing. Some other researcher can find these publishers for you, combine them, and reshare with the network as a higher level data set. When you go and do your research, you can reuse the data from that researcher, and through the mechanism of provenance, automatically give them credit for their work. Then you go on to publish your paper. You can include a stable reference to this ledger, and the reviewer of the journal or a conference can verify all your analysis through this stable reference. Other researchers, not only they can reproduce your research very easily, but they can, because the whole thing stays as a pipeline, because it's still linked to the data sources that the data is coming from, they, with one command, can actually pull in all the new and latest and fresh data and recreate the research and see if your conclusions and your analysis still hold months, years, or decades after your research was publishing. So this basically gives a very long life to the research that you're doing. And as a cherry on top, again, because the sources are linked, if there's a significant retraction or a correction in the source that is happening, you can get notified through this pipeline about, okay, you might want to recheck your analysis, whether your conclusions still hold in light of these new retractions. Publishers are basically the weakest link in this model, and they require very special attentions in terms of incentives. And we basically believe that right now these incentives are not there. So right now it's basically economically not viable for small publishers to bring data. The current solution, like we have data DAOs that incentivize in Web3 for people to bring data and reward them for this. But think about, from publisher's perspective, how many steps this takes, right? This person needs to discover that your DAO exists. They need to prepare data. They need to submit it. Then they have to maintain it if the data is evolving. So this is a huge upfront cost and recurrent cost to the data publishers. Now we were talking about a lot of wearables, right? IoT data. This data might be useful for dozens or if not hundreds of different DAOs. And this basically cost multiplies for the publisher. So we're talking about collectively a quadratic cost to bring data to the system. This clearly doesn't scale and is not sustainable. So we're proposing to flip the model into something that composes. Data publishers can basically bring their data to the network. They just need to register it on the network. And this is where their job ends. Other people can discover these data sets by some labels and start accumulating them into higher and higher level data sets, combining them together. So, and feeding these data sets into data DAOs. Because the whole system preserves the provenance, verifiable provenance basically becomes this mechanism through which you can distribute the rewards. It can be instantaneous rewards for bringing data in. It can be subscription-style rewards for continuously supplying data from your devices. Or it can even be like equity that is far, far delayed, like you don't have to, in a rush, design a tokenomic system for your DAO because this provenance stays. Like it doesn't matter how much time passes, you still will know where every single bit of your data came from, and you can use this information to distribute the rewards much later. So I think this is a really cool, scalable mechanism for actually making data DAOs work. The same model works for Gen AI. Like right now, if you look at ChatGPT, right, they're cutting traffic to the websites that they're sourcing data from. This happens with Stack Overflow. Reddit is suing them likewise. So they're actually creating disincentives to publish data in the open while the whole world is starving for more data. So I think verifiable provenance is a solution for that as well. With our partner, Brian, we integrated Camus into their LLM, that is focused on financial, like DeFi research. And they're basically sourcing data by communicating with our engine. They're basically sourcing data from us. So you can ask, like, what are the top DeFi pools to invest on Polygon? And it's going to give you a very terse, data-based answer based on real-time data. But more importantly, with every answer, you get not just the answer itself, but a proof of where this whole data is coming from. So you get the whole provenance of where it's, how this data was generated, through which data sets, etc. And you can think of this proof as always living as part of your agent history. It's always there. Even 10 years later, you can verify it and see that, okay, you can hold the whole system accountable for a very long period of time. So LLMs, this agent naturally prefers more refined and higher level data sets. And when it generates this proof includes the whole provenance of the whole system. So again, we can use verifiable provenance to distribute the rewards even in this system. So this is my conclusion. Research data is inseparable and vital part of the global data economy. I don't think we can solve it one without the other. The pillars of the new data economy are decentralization, composability, and verifiability. And we basically think that, yeah, after years of working on this model, that the problem is mostly solved. Now becomes a long work on the adoption. And to adopt this model, we need to change how we think. We need to stop thinking about data as this book in a library and think more about data flows that power our society. We need to stop treating ourselves as cogs in this machine and become these builders and maintainers of pipelines that connect these data flows together. So I hope you can give our tool a try. It's openly available. Go to demo.commu.dev. And we have an open data science community on our Discord, so I encourage you to also hop in and give us, say hi to us. Yeah, thank you so much.
Awesome, thank you so much. Yeah, I think coming off the back of last year where DeSci had a bit of a boom, a lot of people were sort of going, and very fairly so, sort of like, okay, let's see the data that the science is producing. And so through Molecule Labs and with the assistance of Camu, we are doing that. So yeah, a big shout out to Camu and thank you from Molecule for all your help for what we're building. Okay, next up we have Tristan from Dog Years DAO. Yeah, Tristan.
Hi, everybody. I've been in the crypto, biotech, legal engineering space for nearly 10 years, and this is kind of a synthesis of all of these things together. And before your eyes glaze over, because I'm talking about legal entities, I would just like to emphasize that even if your science is good, if your DAO or your legal model is not good, you probably aren't going to have a good time. So hopefully this talk will equip you with some ideas about how to go forward with your own projects. Cool. So the topic of this talk is hybrid entities, and by that I mean something that has both a legal component and an ethereal or decentralized component. We're familiar with legal entities to some degree, and the ethereal components can come in a variety of formats, but we're generally talking about some sort of a DAO. So some basic examples, an LLC that owns crypto assets is arguably a hybrid entity, but we're interested in more complex versions, so maybe like a corporation that depicts its equity with crypto tokens, or a full-fledged DAO LLC that allows its members to vote on proposals with their tokens and maybe rage quit when they no longer approve of the DAO's direction. There's some parallels between the old system and the new system. To some degree, this is just like a new type of jurisdiction. Rather than having validators, we have judges. Rather than judges, we have validators. Rather than legal entities, we have DAOs. And shareholders and token holders are fairly equivalent. So some of the advantages, first off, not getting sued. If you are in a DAO and your DAO does something legally questionable, you might be personally liable for that action, and you might have your car or your house taken because of whatever things your DAO did. So wrap it up for your protection. Having an immutable public record of ownership is really helpful. A lot of startups die because people think, well, I thought I was going to have this amount or of equity or whatever. So the faster you can put this someplace immutable, the better. But moreover, being able to work with humans and corporations that aren't comfortable with DAOs or crypto is one of the most important parts of this. Ooh, shoot, this is an older version of my talk. So I guess we're going back to the more esoteric version. But basically, before we had blockchains, we were reliant upon the state to enforce our contracts. And we couldn't really scale without having that enforcement action. And so this opens up a whole new world of transactions that aren't based upon violence. I'll skip that. Oh, shoot. Can we update this? This is an older version. I feel like I'm going to be a little screwed. It's the same link. Just refresh the existing link. Well, let's keep moving forward. Basically, I think that there's this concept of egregore in the occult, where it's like a collective thought form that you put energy into, and then to some degree it makes that real. And I think DAOs are a way to give a body or to give like legs to these egregores that normally didn't really have a way of interacting with the physical world. To some degree, memes are driving development. They are pushing things forward, and being able to tap into that and give it a space to act is a nice way of thinking about what we're actually doing here. Hybrid entities are able to interact with both the old world and the new world, and potentially embody memes. These are some of the first examples of hybrid entities. This was around 2020. Metacartel had a venture DAO, and they went full occult with it, making a grimoire rather than a operating agreement. And the Lao was a branch of Consensus that created a legal autonomous organization that started investing into crypto projects, but still had a lot of the protections for investors. Okay, so thinking about how do we relate these things, a loose binding between a legal entity and a DAO might consist of maybe Jeff in your DAO has a nonprofit with a bank account, and he's using that to allow your DAO to do financial transactions. But a stronger version of that would be your DAO has a partnership with a legal entity, and this is what HairDAO has. They have a Wyoming LLC that is like the service provider for their DAO that allows them to interact with the United States jurisdiction. But a tighter connection would be this DAO's equity is the same thing as the legal entity's equity. We can think about binding going either directions as well. Is it just that the DAO owns the legal entity or vice versa, or are they connected tightly? And then we can also think about whether or not they have escape pods, so that what if one of these things gets sued, or what happens if your DAO gets hacked? Are you able to keep moving forward in a way that it's not catastrophic, is another consideration. So yeah, basically the idea is that in your operating agreement, in your constitution, you are pointing to some smart contract and you're saying, this is how we are going to be doing governance, and that allows, hopefully, if you have a dispute, you can go to a judge and say, this is what happened, this is hopefully the basis for that. Oh wow, okay, let's hope that I can get the new version up. Awesome. 2 minutes? Okay. It's not buttoning. No, that's still the old version. All right, the TLDR is that the elephant in the room with legal engineering is whether or not this is a security. And I think that The current solution has just been, well, we are using governance tokens, it's not actually equity, and that has been enough to get crypto to the point where it is. But I think that it's ultimately a turnoff for traditional investors because it doesn't offer the same guarantee of legal standing that equity would do. So towards that end, I found out that there's actually a way of moving forward in this space for an exemption to securities law called Regulation D. And part of that is that if you have accredited investors, then you can sell securities without having to get the SEC's permission. But if you're selling less than $10 million worth of tokens over 12 months, and the tokens are locked up for 12 months, then you are not qualifying as a security. And I think that if we can get to the point where we are able to, sorry, yeah, time up. Okay, sure. Okay, just to wrap things up, yeah, I'm sorry about the technical difficulties. We have to move beyond the governance model, and I hope we can get there together. Yeah, thank you.
Sorry, guys. Technical difficulties, no matter how much we progress, there will always be a printer and a slide deck that wants to fight you. Okay, we have 2 more presentations for today. Next up, we have a panel moderated by Rafa, who is one of the scientific assistants to the CEO here at Molecule, and he'll be speaking to 3 people who are intimately acquainted with the IPT model and these currently tokenized projects. And then after that, we have a fun little roundup of a nucleate pitch competition where you guys get to vote on the winners. So that's what we've got on the agenda. Oh, also while I'm here, there is a side-out event at the office afterwards. So if you don't want to leave in the rain, you can just stay here and attend the side-out event. Cool, okay. Yeah, and then, whoops, for you guys to pass around. Yeah, perfect.
Okay. So, hello, welcome. We're finalizing the first day, and right now we have a panel with one of the first wave of the DAOs that were funded through Bio, Vita DAO, Valley DAO, Psi DAO, and we're discussing basically something around their tokenization of IP, their projects. And we're going to make this quite interactive. So I'm going to ask the 3 of you to please introduce yourselves really quickly, maybe your DAO as well, what your focus area is on, and we take it from there.
Yeah, Paolo Binetti. I am from Vita DAO, which is the longevity DAO. We fund the drug discovery, and in particular drugs which have the potential to extend lifespan and health span. And I've been with the DAO for 3 years. Many look at us as an example, maybe one of the first DAOs, one of the most successful. We have deployed a few millions. Now we have about 25 ventures around. But because people look at us as an example, then I feel the pressure to keep delivering. And yeah, it's great.
I'm Morgan Richards, one of the co-founders of Valley DAO, and we focus on funding and helping to translate climate biotechnologies.
My name is Chris Burns. I'm one of the co-initiators of Psi DAO, a psychedelics DAO focused on the progress of really tokenizing psychedelic science and art. We kind of add a different mission into that in a certain level. I'm also an intellectual property advisor to Molecule and to BioXYZ, and patent lawyer to a number of the DAOs in here. I've done actually some work now that I'm remembering, Pablo, from on the Vita DAO side. And so also inside DAO, it's kind of a fun space for myself and Jesse Hudson, who's also the Molecule Chief Legal Architect. As we do the legal design for a lot of the fundamental protocols that go out into market, there's a whole world of interesting things that come up, you know, in the legal imaginary for different ways to experiment with what we're doing. And so SciDAO, for me, is really this kind of laboratory for legal design as well. And we have some innovative, I think, models and uses in there in some ways. But thank you.
Let's start with you, Chris. I'm curious, let's start as the first question. Very briefly, how do you source projects to the DAO, and what do you decide what's worth tokenizing?
Yeah, so, you know, SciDAO's gone through several kind of iterations, births and rebirths is maybe a good way to put it, until we've got to where we are now. Along the way, we've had different pipelines and sort of means for sourcing deals. A lot of what we, essentially what SciDAO ended up doing and what we're in the process of doing is trying to delegate out our authority to what right now we have 34 different members. We have 2 different tokens in our system. The Sci token, which is the general governance utility token that most people are familiar with all the other DAOs, and the Psych token, which is actually more like a cooperative membership token. And we decentralized progressively with our Psych tokens following the Fibonacci sequence. So it started, Paul, Kohlhaas, Jesse, and I were the first 3 when we did this iteration of the launch. And we've decentralized our way out to 34. So we'll be expanding out to 55 kind of next. We do this so that we can try and choose, bring people into our community who have a wealth of different experiences, including those who are scientists who are already active in kind of what would be a deal flow network. Fortunately, among our psych holders, we have top other, psychedelic lawyers in the space, people who are just following market activity all the time and who get exposure to a lot of deals. So in a lot of ways, there's been general calls out for deal flow, but I think what's come in has come largely through individual relationships that we've been building as we kind of try and build out this inner growing core part.
Thank you. Morgan, what about you?
Could you repeat the question? Because I was so interested in what Chris was saying.
So how do you source projects that come to ValiDAO, and how do you decide what's worth tokenizing?
Yeah, so we've taken a couple of different approaches. I would say to start with, we were kind of inviting people to apply to us and reviewing all of those applications. But what we found was, the projects, it's kind of like a selection bias. The projects that are searching for funding are often the projects that no one really wants to fund. And so now we go out and we proactively search for projects within verticals that we're interested in. So if you know anything about climate biotech or synthetic biology, you'll know that it's actually a very, very broad and expansive field. So what we try to do is break it down into individual verticals or sectors or impact areas that we're interested in. So for example, one of the most recent deep dives we did was in biomining. So we went out, identified all of the most relevant and innovative researchers in that field at that time. We spoke with many of them, we invited them to apply, we helped them craft their proposals to be as good as they could be, and then we took it to the community to review. We also then took it to external reviewers as well, so we didn't just have our own kind of DAO-focused bias on which projects were interesting. We looked at, we reached out to experts in the field who could give their independent opinion on whether or not these actually had a significant market opportunity. As a result of that, we ended up funding a really awesome project in biomining with a Australian, I guess, they're not a university, they're more like a focused research organization. And that project started, I think, February this year, has already started generating some results. And yeah, I think this is the kind of approach that we're leaning towards now. So moving forwards, we're also building a platform for researchers to help make their research more fundable. So our kind of future thinking vision for that is that we will bring in like, 99% of all projects out there in climate biotech, and we'll be able to see them, incubate them, and then get them to a point where either they're interesting to be funded by us as a DAO or by our kind of network of funding partners, which we will be kind of eventually opening the deal flow up to.
Great, thank you. Paolo, same question to you, but I'd like you to maybe add some words to VitaDAO Fellowship and how does that tie up to the whole process?
Yeah, so basically 90% of what you said, same thing in VitaDAO. We have two channels. First channel is we go actively source deals by going to conferences, leveraging our network. And then passively, we have an application form that anybody can fill in. And then once we have a preliminary application or a preliminary proposal, we make sure that it fits our eligibility requirements, so that it is on thesis, that it is investable, et cetera, et cetera, et cetera. And then once that's done, it justifies investing more time on our side and on their side to prepare a proposal and incubate it to the point where it becomes solid. And then it's reviewed by experts in the field, and finally it's voted. So that's the whole funnel, and the sourcing is only the first part. You were asking also how we decide. So how did we decide it's that way? And your other question was
around the fellowship.
Yeah, so we actually, since about a year, have two stages of funding. What I've talked about up to now is research projects which would typically amount to 200 to 300,000 euros or dollars. So the idea is that at the end of that funding, in about 2 years to do the research, you have commercially valuable IP. So typically something that you could patent. And that means that you need to be at a relatively, well, I'm not going to say mature technology readiness level, because we are still very early stage. We are drug discovery. But you at least need to have identified the target and already have some idea of the drug product, the molecule that you are aiming for, maybe some hit. And so maybe you want to do with this 200K target to hit or hit to lead. But what if you are a researcher and you have a cool idea, which is much earlier? So for example, you think that you can discover new targets, new proteins that might be very relevant for longevity. So that's a stage which comes first, and we would fund it with a smaller check, 50K, and we would open it up to young researchers through this VitaDAO Fellowship. And our sweet spot would be a researcher which is able to bring his or her idea outside of academia in order to make it simpler. We don't have to go through the TTO, and then if those 50K are able to generate a killer experiment that produces an excellent target with data, then this would be a perfect candidate as a follow-up for a full project of 200 and 300K. So in fact, by answering very longly to your question, I actually have to add a third way of sourcing projects, which is by generating them internally. And maybe we will have a fourth one coming up, which will be generating them with AI agents.
Thank you. Super exciting. So now that we gave a brief intro as to where is the deal flow, the sourcing of projects coming, I really want to share the next things for the audience. Now that we saw HairDAO's presentation, Curtopia's presentation, and we can see the usefulness, the usage of DeSci in accelerating, cutting costs in some of the processes that in traditional science take a long time or high levels of funding. I would like for anyone who wants to take first the microphone, maybe Morgan, you have it already, but to talk about like the individual projects that you are now developing. How have you seen the development using DeSci tooling, using decentralized communities, compared to what would take in terms compared to traditional science or traditional biotech funding? You can talk about costs, you can talk about efficiency gains, or even patient recruitment if applicable. So, yeah.
Yeah, so I think there's a few relevant key points to highlight. I obviously won't have time to go into like a lot of detail on them, so I do want to plug a video that we recorded with some of our researchers that actually goes into a lot more depth on how DeSci as a whole has benefited their research compared to traditional science. So yeah, just look ValleyDAO up on YouTube and you can find those videos. But I would say there's kind of a few key things. One is like traditional science kind of happens in a way that you go out, you learn something, or you experiment on something, you find something interesting, and then you try and find a market for it, right? But what we're doing is kind of flipping that model and being able to help build a business case for a technology from the very beginning. So when we're actually building the technology, we can use that information and the knowledge of how it needs to be for the market to design the technology from first principles. So we're not, kind of building ourselves into a hole where we actually find we've built something that is no longer scalable because it was built on foundational lab technology that is too expensive and is not going to work at industrial scale. Instead, we can already start to look at what do the industrial bioreactors look like, what capacities do they have, what parameters do we need to optimize for, and design that technology from the ground up. So that is true of particularly our first funded research project where we're producing cocoa butter through fermentation. That already had a major kind of pivot point, which is that we knew we wanted to produce microbial lipids, but we weren't sure which ones. We first thought kind of fuels, like biofuels, and in the end, through market exploration, we decided to go with cocoa butter. For lots of different reasons, cocoa butter market is highly fluctuating, it's very insecure. And so this actually makes a great first market for that particular technology. But of course, the technology we're building isn't just for producing cocoa butter, it's a platform technology. We can tweak and tune it and produce different products in the future. But now we've saved ourselves potentially hundreds of thousands and like years of applying for grant programs because we already know what we're going to market with from the start. We're not developing the platform and then thinking, okay, now we need to actually try and pivot it towards what the industry actually wants. So I'd say that is a major benefit, and it doesn't even necessarily come from DeSci and the primitives itself. It comes from the way in which science is funded, because it's kind of a backwards approach to the funding of science, right? From maybe a slightly different angle, I would say the rapidness of how quickly we were able to fund some of our research projects through the IPT framework is just extraordinary. I mean, we knew what we had in terms of the project and the value that they potentially held, but we weren't prepared for how quickly these projects got funded and how well they were received by, I guess, the demand side who wanted to fund these types of projects. So I would say that has been a huge eye-opener and kind of reinforces the belief that we all maybe held, which was that we can, like, that people, ordinary people, do want to fund science, and they do care about the work that's being done in science, and they do care about the impact that it can have on their lives as well. So I think those are some of the big takeaways from our perspective on funding research.
And Chris, same question to you. I know that right now there's some tokenization projects going on DeSci. Any insights there that you can share against doing the traditional way?
Definitely. You know, SciDAO, again, is I think, really unique in that our goal and sort of market thesis is less about trying to get individual IP tokenized that's going to be of particularly high value. Of course, we want that. But I spent over a decade in the patent licensing world and doing patent litigation and all different types of IP and international trade in large deals for a while before coming into this space, and saw everything move where IP risk management is actually kind of the driving thing of cost of doing business, and intellectual property in the market just generally has shifted so much towards IP risk management and really thinking about ways where intellectual property networks themselves can reduce the cost of accessing the IP justice system altogether. Tokenization is, in my mind, the future for intellectual property. And in this vein, in the psychedelic space, even though it probably be more interesting for everyone if I would share cool psychedelic projects that we are working on and tokenizing and cool art projects, I'm talking a lot about tokenization as a concept and for what we're trying to do and bringing it into the psychedelic space, because it fundamentally is, I think, disruptive in a positive way towards psychedelic culture. We have in the psychedelics market a big gap and a lot of suspicion and tension between really capitalism coming into the psychedelic space and everything that comes with policing and whatnot into a space, into essentially a prohibitionist era. And most psychedelics as well, the classics obviously aren't very patent eligible in as much as there's been publicly disclosed information about classic psychedelics for a long time. But indigenous communities, people who are constantly sort of historically marginalized and on the outskirts of this economy perceive all types of harms of expropriation regularly. And tokenization, I think for SciDAO, we go all the way into taking these issues very seriously and thinking about intellectual property and culture and what decentralized science inside psychedelic culture can mean if we can use it to be something that is much more expansive, really something that can help reframe intellectual property culture more generally. And it's in that space, I can get into specifics anywhere from how tokenizing intellectual property ownership at the patent level can save tens of thousands of dollars in due diligence costs down the road. That's one angle. But all the way to tokenizing, we work with Shipibo. Jesse Hudson, who's here somewhere, I'm sure, has worked closely with the Shipibo in Peru for well over a decade in tokenizing art and kenne, and these kind of things that we've connected to our tokens have also helped bring in a whole other angle of tokenization and I guess really decentralization, I think, in this broader sense that I think, we're still seeing this. If I had to guess when we'll have it was actually just after hearing more about Molecule Labs today that we were hammering out, even this afternoon, another model where we can further show how a DAO as a trade association, as a space where we're actually facilitating and administering just a network of trading tokenized IP more generally, can itself become a platform and scaffolding for all types of interesting cultural production in that space. So I know that was a little off, but it's where we are.
Thank you. So just to finish off, I think we could talk plenty of time about this, but Paolo, maybe you can talk about like the assets that you have, VitaRNA, VitaFast, maybe talk about VitaRNAs, like super fast preclinical and also spending way less money than...
I will talk fast about VitaFast.
Exactly.
And slowly about VitaRNA. So yeah, VitaRNA, it started from the idea of one of the contributors of VitaDAO, a researcher who had already founded a company that went on to be funded subsequently with very big rounds, Michael Torres, and the idea was embraced by one of our entrepreneur in residence, Anthony Schwartz, who is experienced, having been CEO of several biotechs. And the idea is extremely exciting. So in the DNA, you have mutations that take place on a regular basis. And some of these mutations are of a specific type that basically stop all the translation machinery from producing the correct proteins. And it's a class of mutation, and there is one technique which is leveraging RNA that can somehow fix it without modifying the DNA. So that's super cool because you can address not only one disease, but entire classes of diseases in one shot with a single intervention. And then also you're not changing the DNA permanently, so it's safer. And yeah, that's the idea. And we gave less than 100K for a very quick killer experiments, which worked. And that's when we had the data justifying a proper intellectual property token launch, which took place, raised $300,000 more. And with that money, they were able to do more in vitro studies. And just lately, they actually, I think today, they disclosed the results of an in vivo study where they gave the intervention, which is an RNA construct packaged inside an adeno, like by AAV virus capsid. They gave it to mice, and the mice basically experienced no sign of toxicity, and the compound went to several different organs. So that's extremely promising, and that's amazing what they were able to do with just 400K. So now this paves a way for further development, and that's super exciting. And I need to be fast for VitaFast, they promised.
You have time, you have time.
So here the idea was didn't start from one of our contributors, but from an academic lab. And it turns around autophagy. Autophagy is a process that it's taking place in humans, but actually in any animal and even other organism that cleans up the bad products inside the cell, and self-eating, that's autophagy. And it's actually one of the key mechanisms of longevity or of aging if it is impaired. And here the lab had found a way to screen small molecules that were able to boost autophagy, which is relevant in particular for neurodegenerative diseases, but not only. And with that screen, they produced a few hits, and then the project was able to optimize the hits further. I think we are now at the third iteration. We are expecting the results for the third iteration. And the more they optimized, the more the compounds became potent and drug-like. So that's super exciting, and it's more conventional in terms of modality. It's so small molecules, but it is a bona fide longevity mechanism that we're acting upon. Longevity mechanism, the beauty of it is that it has the potential to be a pipeline in a pill, meaning that with a single molecule, well, you can apply it to different diseases. And so it's happening under our very eyes. It's extremely satisfying.
And one of the things that Molecule is building right now, you saw it in the presentation of Kevin, Molecule Labs, you'll be able to see real live the updates of the scientific projects that get tokenized as well. So right now you can see the latest development of Vita RNA as well. You can follow their Telegram as well, and you can see what's up, what's the news. And to wrap it up, I'd like for you to share something about how does your DAO support these IP projects, this IP, either IP NFTs or IPTs, but how does it support them? Can be starting from funding. What else can you provide to them?
Yeah, so I think I already mentioned some of the things that we've been doing for our projects, but I would say, yeah, beyond funding, it is exactly the business support. We see ourselves as being an extension and an addition to the research team. And we're really able to kind of explore, not only because we have within the community like the depth and breadth of expertise necessary to evaluate the business and explore different market opportunities, but we have the time, right? We have the capacity that researchers don't when they're spending their 9 till 9 and in the lab trying to make the research and the technologies work. So we see ourselves as being that kind of hive mind, that collective that can help support and incubate the project beyond what would be done through the research. Because typically, like I mentioned, that the yeast fermentation project to produce microbial lipids, I mean, they would have raised the grant to produce this microbial lipids system, but probably at no point during that whole 2-year research span would they have done a market analysis. At no point would they have gone and spoke to customers and tried to identify pain points and needs and requirements for the technology. So, we see ourselves as being that extension, saving time, money, and hopefully, fingers crossed, improving the odds of success of deep tech, which are pretty damn low for the most part.
Yeah, I'd say at SciDAO, we're really trying to become, again, as a tokenized network, build a tokenized IP commons, become a space where essentially our community is the asset that one really gets when you're participating in tokenization, be it an audience or one of our projects that we're building out as an open science, tokenized psychedelic science survey platform, where we use tokenization. There's a great white paper we have up, the OPSI white paper, if you feel like taking a look, that really helps to solve the problem of getting large data sample sets from people taking psychedelics. You can imagine how that's historically not the easiest data set to get, but just how valuable it is. So we're building ways to use tokenizations to help there. We're also using, I think, about to use tokenization as a means to administer our community, again, in a more native way by actually tokenizing, making an IP NFT of the SciDAO brand assets, and then distributing as IPTs, as essentially maybe another Molecule Labs experiment, kind of going meta with it, brand equity that would go out to our psych holders, which are already kind of encumbered on some other duty of care obligations that they have towards the DAO. So I guess in another way too, just getting creative and getting psychedelic with tokenization and science and art is hopefully what we become kind of known for and the go-to spot for.
To wrap up this, Paolo, what about VitaDAO?
Yeah, we help founders and scientists by providing access to experts, advisory, and some extra funding in some cases.
After the first initial funding?
Yeah.
Okay. Well, that's it, folks. Thank you very much, and I hope this is useful in your knowledge of DeSci.
Amazing, amazing. Thank you, guys. We've got one more mic. Yeah, always good to hear about our IPT projects. Cool. To close off the day, we've made it almost through day one. We are closing off today's session with a pitch competition. We started this pitch competition last year. We partnered with Nucleate, which is, as you've heard, a student-led non-profit organization that basically is aiming to create the next generation of bio-entrepreneurs. And last year we partnered, we got 9 fellows, they came and worked with Molecule for 6 months, and we've just really built this relationship, and so we decided to put the pitch competition back in. So we'll have Fabio and Kamali, who are both part of Nucleate Germany, to sort of explain a little bit about Nucleate and to introduce the competition, and then we'll have our 4 contestants come in and pitch.
Okay, hello everyone. So as Ella said, I'm Fabio. I'm the National Managing Director of Nucleate Germany. I'm here with Komali, who is the co-director of our Activator program. And today we're just going to give you a bit of, well, I'm going to give you a bit brief information about Nucleate, what we do, the activities we do globally, but also within Germany, and then hand it over to the early stage biotech startups that take place within our Activator program. So at Nucleate, what we kind of focused on is turning these academic projects into impactful ventures. So we take early stage projects, usually led by early career researchers, and give them the tools, the knowledge, and perhaps the capabilities to then commercialize their research and turn this into something actionable in the real world. As Ella said, we're a non-profit organization, and yeah, our goal is to empower the next generation of biotech leaders. So this can be anything from company formation, which can also come as part of the program, professional advancement for startups, for founders, and also in general building the whole next generation leaders of the biotech ecosystem. So this can be VCs, business development, and so on. And we're really big on community building. So Nucleate, as I'll come to, is a global organization. It's not just restricted to Germany. And we really utilize this global approach to kind of not only help the teams in each of the regions to expand beyond their region, but to bring everyone together to exchange ideas and to really push it forward. Yeah, so briefly, our core principles. First and foremost, it's an educational mission. We try to lower the barrier of access, similar to DeSci, to biotech entrepreneurship. So introducing ideas to maybe PhD students, postdocs that haven't had them previously, then identifying these early stage startups, helping develop them, bringing together people for networking events to kind of spark ideas, spark conversations. Yeah, as I said, so Nucleate started in 2018 in Boston. You can see here just how much it's grown over the years since then. So it's spread throughout the US, it's spread throughout Europe. We even have in Latin America and Asia now some chapters. This is just a region. In total, we have over 800 leaders in our leadership team, over 40 regions, and these 800 leaders are part of over 440 academic institutions. Our main program is the Activator, is this accelerator program, which on the next slide I'll tell you about, but we've developed much further beyond this. So we do workshops, we have lecture series, obviously networking events, career development opportunities for leadership within Nucleate, but also for the Activator teams. But yes, the Activator, which the teams who will pitch now have just gone through, this is the main flagship program that Nucleate runs. It takes no equity, charges no fees. It's all focused on biotech, but it's agnostic to the type of biotech. There's therapeutics, diagnostics, green tech. But we start with a team formation. So we try to, a lot of the teams that apply are either PhDs, postdocs. They may not have a fleshed out business plan yet. So we try to pair them with business founders that can maybe help in this area. We provide hands-on workshops led by experts. So in IP, strategic fundraising, market risk and application. And these are all tailored in mind to the teams that we have running the program. And finally, we have a final pitch showcase, which for Germany is on Friday. And then this follows by the global summit where we try to bring together people from all of the different regions where Nucleate is. These are just some numbers to kind of show that the impact the activator has had. So these are globally. So since 2018, since the first activator was run, over 100 companies have been formed, over 400 million USD has been raised, close to 300 biotech jobs, and 1 acquisition of a company. And on the right-hand side, you can just see some of the bigger names that have come through the program and are now alumni. And as we keep going, the idea is this alumni, this community gets bigger, and it just keeps feeding into each other. I thought I hit this slide. So in terms of the 2025 cohort, so we have 200 venture teams. This is globally. You can see the breakdown in distribution here. So as I said, quite agnostic. I mean, there's a large proportion of therapeutics, but it covers a lot of biotech areas. Specifically in Germany, we had 9 finalist teams. You're going to hear 4 of them pitch today. And this is just quick for some of the events that we have upcoming in Germany. So as I mentioned, we have the final pitch showcase in Munich on Friday. So if any of you are in Munich, feel free to come down. But if you're based in Berlin and you're not going to make it, on the 23rd of September, we also have a bio Innovation Day. So this will feature Startup Bootcamp in the morning. We're actually open for startups to apply now to see, and then we'll run through and see which ones we accept. And then in the afternoon, we'll have a public session where there's panels, keynotes, pitches, and networking. Yeah, and this is, thank you, we're a non-profit organization, so our sponsors that kind of make all our activities possible. And then I'll hand over to Komali, who will introduce our teams.
Okay. All right, everyone. Let's get to the most exciting part, that is the pitch competition of Nuclear Germany activator teams. In the next few minutes, you will be hearing back-to-back pitches from 4 high-impact pitches from 4 teams who are researchers who are bringing their ideas, their science from lab to real-world ventures. So at the end of the presentations, you, the audience, will decide or will vote for your favorite. Hence, get ready with your phones and to choose your favorite. With that, first team up is Chandrashesh Ghosh, who will be presenting auxiliary therapeutics. Unfortunately, he couldn't join in person today, so he will be presenting it virtually. And he's building a next-gen therapeutic platform to revolutionize the infectious disease treatment. Okay, can we have CD presentation? Yeah.
Hi, good afternoon, everyone. My name is Chandrashesh Ghosh, and I would like to thank the organizers for giving me the opportunity to present Olexia Therapeutics to you. And so the global goal of the company is to transform toxic drugs to make them safer, cheaper, and better. And to do that, I will tell you about a problem that is plaguing human health right now, and that is fungal infections, and mainly invasive fungal infections. So all immunocompromised patients suffering from cancer, HIV, or people who've received new transplants, or ICU patients actually suffer from invasive fungal infections. Around 6.5 million is the number that we look at. And around 4 million people die due to invasive fungal diseases. And all of the patients that I told you above actually succumb to these fungal infections, around 20% of them. So it's a problem that needs to be solved. And one of the leading drugs against that is amphotericin B, which is in the list of essential medicines of WHO. And this can be used for treating infections caused by Cryptococcus, Aspergillus, Candida. These are all pathogenic fungi, and also a parasitic disease called leishmaniasis, which is affecting a lot of people in South America, parts of India, and also parts of Africa. Unfortunately, amphotericin B, although it's a great drug, is extremely toxic against liver as well as kidney. And it is absolutely not soluble in water, so you cannot take it like a pill, like orally. It needs to be formulated and given as an intravenous injection. And if you formulate it with lipids, for example, then the cost of using a standard 15-day treatment of amphotericin B lipid formulation is around 18,000 euros. And you can appreciate people in India, South America, and Africa would not be able to afford this sort of treatment. So we need to come up with a formulation of amphotericin B, which is water soluble, not toxic, and as well as affordable. And to do that, we have a new formulation, which can, in principle, it's like a platform technology of sugar-based gold nanoparticles, and we have conjugated amphotericin B to it with 2 to 3 very simple steps, and you get a 10 nanometer nanoparticle of amphotericin B conjugated to gold nanoparticles, and it is extremely soluble in water, till 10 mg per ml, to be honest. And if you look at it, if you leave amphotericin B in water, it falls down like this, and this is the formulation. You can see it's a clear see-through like amphotericin B in DMSO. And it's non-toxic, and we have shown this by a hemolytic assay. That means the red blood cells, if there is a toxic agent, it bursts and releases heme, as you can see here. Amphotericin B releases heme in 12.5 micrograms per ml, and this is the formulation at 64 micrograms per ml, which is much, much more therapeutic index. And you can see that the properties of the formulations actually become more effective, 2 to 4 times more effective. We've done tests against the pathogenic fungi that I described before, and we have looked at 50 clinical isolates from hospitals across the world as well. And we've seen that every time the formulation is 2 to 4 times more effective than the parent drug. Apart from that, some of these fungi can form these things called fungal biofilms, and amphotericin B is not so good at treating these fungal biofilms. However, the formulation is 2 to 4 times more effective than amphotericin B at treating these biofilms. And similarly, some of the fungi can form these vesicles inside your immune cells and survive within. For example, Cryptococcus, and amphotericin B, the parent drug is not able to do it so well, and the formulation is very good at it. It is also very effective against leishmaniasis, and the IC50, that is the concentration at which 50% of them are killed, is brought down from 1 microgram per ml to around 0.1 microgram per ml, which is very, very good. And in comparison to all the other formulations that are there in the market, we have a less toxic, very efficacious, and very, very cheap formulation, which is the next generation therapy. And one good thing about it, you can just lyophilize it, put it like in a powdered form, and probably use it orally as well, just by putting water into it and taking it as a pill. And we are trying to take this particular formulation forward for amphotericin B into a market which is around 16 billion strong. The lipid formulation Ambiazome alone actually generates around more than 500 million, and we want to tap into that market, which is going to grow at a CAGR of 6.5%, and also fueled by the aging population of the Western world, and they will rely on this kind of drugs. And of course, people back in India or in South America also would require these formulations a lot. And where we finished the laboratory models, and the animal models are ongoing at the moment. We finished a preclinical toxicity model, and I can tell you it's doing very, very well. Hence, I am out here to raise more funds. We are looking to 2 to 5 million euros to complete preclinical studies and then go into the next round of phase 1 clinical study. And we are willing to partner with any big pharma, and also are willing to be acquired by them at a given point in time, because the formulation is doing very well. And we also have ambitions of expanding this nanotechnology into other diseases to make their drugs soluble and less toxic. And I am going to be the CEO, and I'm generously advised by Professor Seeberger, who's the director of the Max Planck, where the work was initiated. I'm supported by Nucleate. Thanks guys, Max Planck Foundation, NIH, and also we're looking for team members to join this team. And I'm very happy to have any questions that you might have. Unfortunately, I apologize that I couldn't be there in person for personal reasons, but I hope you guys have a successful conference, and I'm willing to hear from you. Thank you so much. Bye.
Negar, who will be presenting us with Exosphere. Negar is a medical engineer, and combining her technical expertise and her vision for early detection of cancer was where the Exosphere was built from. With that, I welcome Negar.
So, hello everyone, my name is Negar, and I'm very excited to be sharing with you how at Exosphere we are saving your lives by introducing early cancer diagnostics. You might be asking, why my life? Because in this room, out of every 2 people, 1 will be diagnosed with cancer at some point in their lives. And unfortunately, the diagnosis will be likely at a very late stage. And when you're diagnosed late, your chances of surviving this disease is significantly lower, by even up to 14 times. If you look at aggressive cancers like the pancreatic one, you can see that diagnosis at stage 4 has only 3% chances of surviving. And it is more scary to know that almost half of the patients are diagnosed at that late stage. It is crucial to diagnose the patients early on. But unfortunately, right now, there is no accurate and cost-effective solution that you can utilize as a screening method and to not wait for the symptoms to appear on the patient. But I'm not here to just get you scared today. I'm here to also give you hope. Because at Exosphere, we are building a solution to this. We have built a system that can target and identify the biomarkers of cancer inside blood. How it works is that you put the sample in a very small microfluidic kit, which is this big, and you insert the kit in a reader device, and you can get a signal readout, which is the indicator of the concentration of the target cancer biomarker. The innovation of this system is that it combines a low-cost test with a very high sensitivity. Even if you are at the very early stages of the disease and the tumor is only shedding a small amount of molecules into your blood, this system is able to identify those. Our business model consists of selling these kits and the reader to diagnostic labs and centers where this test will be then provided as a service to the patients. Long term, we would like to also have this reimbursed by insurances. There are several companies in the liquid biopsy market, but if we look at the 2 important factors, again, for early screening, what's important is cost and sensitivity. We can see that a lot of them have a sensitivity very low, even as low as 40%, and costs that are above $1,000 per test, up to even $4,000, which makes them not very suitable for screening. Exosphere is, oh my God, the colors are bad, but you can see it's the basic 2-sided matrix is the only solution that combines the high sensitivity with low cost. If we look at only one indication, for example, pancreatic cancer, we can see that the addressable market for this technology is very high, up to billions of dollars. But what is important to keep in mind about this technology is that it is a platform technology, meaning with minor adjustments, we can adjust it for other indications of cancer, as well as infectious and cardiovascular diseases. So not only the target market is very large, but also the business is highly scalable. So far what has happened is that we have tested this system and our kits with several different biomarkers that we have listed here, and we have seen amazing results. And at the stage that we are right now, together with Germany's biggest diagnostic company, we are doing testing with patient blood samples and plasma samples to also show data with relevance to clinical samples. At this stage, we're also looking for angel investors to join us and help us with the financing of the round. Our team comes from several different backgrounds, from technical, biotechnology, biochemistry, but we all share a vision of saving patients' lives by bringing innovations to market. And last but not least, we are thankful to our advisors, many of which who come from the Nucleate program, who have been supporting us in different aspects along our journey. Thank you very much. I would be happy to chat with you after the pitches and looking forward to the conversations. Thank you.
Yeah. The next up is from Stefan, who will be representing Onsera. Stefan is currently a research group leader who is pioneering the translational oncology initiatives at LMU Munich. Today, he will be presenting the Onsera platform where it works on this early cancer diagnostics related. Yeah. Over to you.
Thank you. Thank you, Kumali.
Thank you.
Together with Max. Yep. Okay, let's start. So we're presenting you Onsera, a collaborative project between Helmholtz Center Munich and the LMU. And it's about the usage of tumor avatars and structure-based AI for target discovery in solid cancer. This is Thomas, and he was diagnosed of metastatic liver cancer. And he was one case of 18 million cases each year, but it was a very personal case as I accompanied him and treated him during his disease course. And he had not the luck of having a targetable mutation, but he needed general therapy for his cancer and had severe side effects, and his tumor did not respond to it. So we had to change it to another general therapy. Again, severe side effects. Again, his tumor did not respond to it, and ultimately he died. His case is representative of the majority of solid cancer cases and highlights the urgent unmet need for better targets and treatments. There is hope on the horizon, as last year a study was published that showed efficacy of Enhertu, an antibody-drug conjugate, even in low to ultra-low abundance target patients. However, these new therapies like ADCs, bispecifics, and CAR T cells, they simply do not work so well in solid cancers. Why? Because we lack really solid targets. And why do we lack solid targets? Because the classical target discovery approaches fail in patient proximity, for low abundance targets, and the turnaround time. So, what are our solutions? First, patient-derived organoids. However, these do not represent so well the patients, as the success rate and take rate is often not so good. We developed in our lab new methods and new media formulations to increase the success rate. And from now on, we call them tumor avatars. As you can see here in this RNA-seq analysis, they cluster very well with the original tumor tissues.
Thanks. So, together with our AI approach, these technologies form a synergistic platform enabling a groundbreaking target discovery pipeline with unmatched advantages. So, okay, so this slide should go step by step. So at Helmholtz, we created a structure-based AI model, which has the beauty of not only identifying targets on the surface of proteins, but also aids in drug design. And this has the potential to lead to completely new patient therapies. So using our Beam AI, we call it, we in silico create multiple binders, and subsequently we validate them with our tumor avatars. So here you should see a video of an immunofluorescence tumor organoid, and we have internalized it with an E-cadherin antibody, which diffuses through the gel, binds to the membrane, and even is internalized. On the right-hand side, we have the second technology, our AI system, which creates a higher proportion of high affinity binding compared to our non-structure competing systems. So while other competitors primarily rely on diffusion or sequence-based models, these non-structure-based models often struggle with identifying new target spaces, and they lack the direct patient relevance. On the other side, our organoid-based competitors, they are closer to the patient model. However, they lack the AI integration, which is needed to scale and automate the discovery. So with our approach, we combine the best of both worlds. We are close to the patient-derived models with our tumor avatars, and we use our structure-based AI. This leads to several key advantages for our partners. First of all, we have access to a new target space, and we have a reduced failure rate due to the higher clinical relevance. We have a faster validation, and we are in regulatory alignment with the FDA's roadmap plan to phase out animal tests. So this is where we stand today. So we tested both of the technologies separately, and as a next step, and with your help, we will validate the synergy of both technologies. We will file a patent for the AI and avatars, and we deepen our interaction with pharma. We organize follow-up financing, and we start a dual business model as CRO and co-development. Upon that, further scaling and exit. So Onsero is the team, and without our team, we would not stand here. So thanks to all of them, and thank you for your attention.
Thank you so much. The next up and the last one will be Henrik, who will be presenting Keynostics. He's the business mind behind the Keynostics team. And it's Keynostics is a diagnostic platform which is for vitamin diagnostics. So with that, I will hand over to Henrik.
Thank you. Hi, everyone. My name is Henrik from Keynostic, and what we are building is the novel diagnostic platform for personalized deficiency monitoring. Thank you. I want to present you later on our first use case, which is vitamin diagnostic. But before diving there into the deep end, I'm just going to start with my hobby. I'm actually an ultra marathon runner. This basically means I run more than 40 kilometers by choice on the weekend through the mountains. What I ask myself there often is, do I actually have a healthy body? I guess this is a question which most people ask themselves, and if you eat healthy and you have a good lifestyle, most would say, I'm fine. But the question is it really true internally? And I will start with the topic of vitamin diagnostic. Now, on the left side, you see me during a run last year, 106 kilometers, 5,000 meters in altitude. And basically, I did a blood test before and after the run, and it showed me some constants, some markers went up, but also regarding the vitamin markers, we got a drop of more than 40% in that case, for example, for vitamin B12. What most people, on the other hand, take every day is medication. So also for medication, you have very specific indicators on micronutrient levels. So for example, a few 100 million people take metformin every day, and basically it has a clear case with B12 deficiencies. Now, you could go to a doctor repetitively, get your blood collected, send it to a lab, get the results, but it's very expensive and cumbersome. And even though there are 200 million vitamin tests performed each year, and this is only for Germany. And we are here to change that. What we are building is a novel diagnostic platform for personalized deficiency testing. We start the technology with building a lateral flow assay, which you might know from the corona test. We are basically using capillary blood, putting it on the pad, and having multi-stripes to determine multiple biomarkers at the same time. And to enable a quantitative readout, we are actually using a smartphone app to determine the bands. As this is a platform technology, it's not only for vitamins, but the next use case afterwards will be hormones as well. Now, for the patients in itself, it will be faster, easier, and do-at-home test. Now, let's look at the technology behind it. And as I'm the business guy, I keep it very simple. The black dot here shows low vitamins levels. But what does low vitamin levels actually mean? It means that the vitamin in blue here binds to a protein in gray, but you see a lot of non-binding sites. And this is where we come in. We are developing mimics. These are shown here in orange, and they fill up the open binding sites, and this is what we're detecting. So the very interesting part, number one, this is completely new diagnostic approach. No laboratory is going to do that. And secondly, it is extremely personalized because it shows your levels. Now, looking at the markets, we see extremely interesting markets. Of course, on the lifestyle markets, every vegetarian and vegan knows you should take B12. How many people do it in the correct dose? Nobody knows. Also, the whole topic of personalized supplementation. A lot of people take different kinds of supplements, but is it in the correct dosage or not? Also, nobody knows. Then at the medical applications, we already talked about the topic of drug treatment, but also the post-cancer treatment. For example, if you had pancreatic surgeries, your body does not absorb micronutrients as good as it was before. So there is already a medical need for testing repetitively. Now, where are we right now? We're currently doing a proof of concept and putting 2 markers on a rapid test. We are in the rounds for a pre-seed, finalizing that in September. And our goal is to have an MVP in 1.5 years. And that means we have a rapid test with 3 biomarkers and a quantitative readout. As already mentioned, we're doing a pre-seed, 990K. The interesting thing, we already have a technological lead investor driving that, and we are now rounding up the amount. And lastly, let's look at the team here. We have all the team from organic chemistry, biochemistry, engineering, and business already in there, but also a very good advisory board. And now, let's enjoy the evening. If you want to talk more, happy to, even if it's running or funding, I don't care. Happy to talk.
Yeah. That's all for all the pitches, and please give again a huge round of applause to all the teams who pitched it today. We will have a QR code now. Please, all of you scan your QR code and vote for your favorite team.
Okay, everyone, you can vote, and then in 5 minutes' time, we will announce the winner. So everyone get voting.
for the fill-in, so do you want to refrain and ask?
Yes.
Yeah. Tell everybody to sit. Should we tell everybody to sit and we'll announce? Should we tell everyone to sit and then we'll announce?
Yeah.
Hello? Oh. Okay, everyone sit down. We are going to announce the winners.
Okay, all right. Are we ready? Oh! And the winner is Negar from Exosphere. Applause. Congrats.
Thank you so much.
Maybe you can say some words.
Oh, okay. I wasn't ready for that. Okay, yeah, thank you everyone. It was a pleasure to share our idea of Exosphere with you, and I'm very much looking forward to the networking. I'm happy to also get to know you and what you're interested in, and perhaps there will be also collaboration opportunities in the future. And thanks a lot to Nucleate for the amazing program that you provided us with. And yes, congrats also to all the other speakers and the startups, amazing pitches. Thank you so much.
Okay, amazing, everyone. That is day one closed, finished, but only technically because we also now have the SciDAO event here. So mill around, we are here to chat. Tomorrow morning we start, breakfast is at 9. There will be a second round of molecule Uniqlo bags, so if you didn't manage to score one today, be here at 9 to get one. There's a rumor going around that we might even have temporary tattoos, so just go crazy. And then of course we've got the BioAC rave tomorrow night, which is where a temporary tattoo would be pretty cool. So I don't know if you're gonna put 2 and 2 together. But yeah, looking forward to seeing you guys tomorrow. Stay safe.